Click live.
You carry stuff?
I guess if you don't say caretaker, you can't figure that out.
Oh, a caretaker. No, you shouldn't be in charge of taking care of anybody. Bev, you can't manage yourself.
I want her booted.
Mm-hmm.
Can I do that?
Well, I'm just doing the Buster.
Yeah, get rid of Brenda. She's not going to take over this live show. I can promise you that. I'll figure out a way.
If you had a giant 1 mile long spirit level,
imagine LIGO, right? It's 2 miles, isn't it?
Yeah, if you were to put a bubble level on like the intersection of LIGO, that would be level. If you were to walk down the arm and place it on top of that, I would say it would not be level. That would be another good.
So you say at the split point, that's where it's level on both arms?
Yeah, I'm pretty sure that's where they level it.
And what are the arms? What are the arms? If the center is level, how do you envision?
No, he said no, not the center. The apex where they both meet.
Oh, the apex.
Yeah, it's different.
So
yeah, it's
changed.
How do you envision the end of the arms, then, the other two ends?
They're just going to go straight. But this is in the engineering.
The end of the arms. At the end, you have the apex, and you have two arms running along, right?
Yeah.
How are they? Are they in the same level as the apex, or how do you envision them? Higher, lower?
So at the end of the arm, they had to pour more concrete because it was at a higher elevation.
It's not what I asked you. It's not what I asked you. When the job was done, you have your apex, it's level.
Mm-hmm.
Either arm, how are they in relation to the apex?
They're flat. They're straight. They're straight.
Yeah.
Are they also level?
No. They are. They at spot. They are not level. They like if you put a bubble level. If you put a bubble level on the apex and you started moving down the arm, it would get off and more off level.
How? Towards the up or towards the down?
With the bubble level, it would either go left or right.
No, hold on a second. You have a level at the apex, and you have two arms running, and I'm asking, you say they're not level at the ends. So I'm asking you, are they lower than the apex or higher than the apex?
They have a higher elevation than the apex.
So they're higher than, wow.
So the horizontal raises in elevation for you. No, you said it would be higher.
Hold on. The horizontal plane that was established at the apex will diverge from the surface of the earth. The horizontal plane stays straight, but the level of water starts diverging from the straightness.
What? How do you envision that? You envision level water diverging from straightness?
Yes, I do.
Wow.
How is that possible?
Because level is a curve. And water is level.
That's my model dictates, right?
No,
that's
absolutely. But as I was saying, like, if we go back to the straight line test, you would be able to see which one's true. If water is curved, then there will be an angle. If level water is curved, there will be an angle between B, A, and C. If water level is straight, then all of them will be collinear. It's a test.
I don't think there's any possibility of reaching you, bro. I just don't think so.
If we do the test, that would reach me.
Did 2 songs for it?
And we are live. I have to do that twice. Completely fucked the shit up out of that thing. Probably had 2 Buster songs going again. It was all crazy shit.
Buster is actually pretty talented.
He's the most talented, I would say.
I don't know about that, but he's pretty talented.
Mhm.
He should focus on his music.
I should what?
He should focus on his music.
Buster should. Yeah, he does.
Yeah,
Yeah.
this stuff. This is just the dead end.
What? Other than what?
He'll get
Focus
more.
on many things, I'm sure.
He'll get many more followers than you ever will, Bev.
I hope so. I hope so.
Yeah.
I'm trying my best, Brenda. Are you pushing it like Buster? I think everybody should go and subscribe to Buster.
What do you think of his lyrics?
Already done.
I don't really listen to him.
Oh.
So how do you know he's any good then?
I don't really pay attention to the lyrics.
Oh. It's just got a groovy beat.
Yeah.
Yeah,
Clicking your fingers and stomping your feet. I can imagine it, Brenda.
It's hipping and hopping. It's hipping and hopping.
You don't understand. That one. It's your favourite. Have you heard your special ones?
No, I don't listen to him.
Yeah, he's got a good one. There's a You Don't Understand dedicated specially to you, Brenda.
Don't care.
You're wrong. Was it?
It's the one where you said that Euclid doesn't work. Euclidean geometry doesn't work in the presence of gravity. Imagine that.
True. That's true. So that, kudos to him. Yeah, he got it right.
No, it was you. You said it. It's just in the song. We put it in there. We like to put all of the stupid shit people say in Buster's songs. Or I do, anyway.
Well, you say it's stupid, but it's actually just physics.
What, that physics changes geometry?
Yep.
Wow. Does that be physics changing a straight line?
So what happens is in the presence of mass, geometry changes.
Wow. Mass changing geometry. Does it change by the amount of mass?
Yes.
Proportional?
Uh-huh.
Quadratic?
So
Exponential?
near a black hole, for instance,
Linear?
or near a black hole, you would get turned into spaghetti. Spaghettification.
Black hole? What, you mean like a hole in the ground?
Yeah.
A black hole.
Yeah, like a black one. Yeah.
Yeah, a hole in the
Not
ground.
like a
that.
white hole or a purple hole or anything like that. Just the
White
black
hole.
ones.
What a white hole would be the opposite of a black.
Black hole in a work surface.
A white hole would be the opposite of a black one. What about a red hole? Would blue be
Those are just probably, red giant stars or something, right?
I don't know.
Red holes are dangerous.
Red giant stars, or white dwarfs.
Mm-hmm. What about a finger hole?
I like Red Dwarf myself. That was a great show.
What about a glory hole?
What about a blue hole?
So in the presence
So fun.
of a mass, geometry of the universe changes, of space-time.
Mm-hmm.
It gets distorted, stretched out, compressed.
What happens to geometry around glory holes?
Stretched out. Did you just say stretched out and compressed?
Stretched out black hole.
Yeah,
did you say?
depending on what's going on. Yeah.
Can we back
Stretched
up a little
out.
bit? Doc? Stretched out black hole with space time involved.
Yeah. So around
You got a video of that?
around the Earth,
Can we see a video, maybe?
you get what's called frame dragging. The rotation.
Frame
of the Earth.
dragging.
Oh,
Frame.
that's what they do at the banger car racing around the corner. Lose a couple of wheels and you start having to drag the frame around.
Yeah, you probably won't win if your frame is dragging.
Mhm. won't win.
Or if you're a black hole stretched out during space-time hour, you're not going to win. either.
Dragging your frame through a brown hole, a black hole.
That's called,
Danger, danger. Beware of the red hole on the other side of the stretched out black hole.
it means that as the Earth rotates, and with the gravity, it actually.
Brenda, just a minute. Your mic's fucked again. You may be a bad connection. Are you driving?
Let me.
Sounds like you.
It pulls part of.
I'll just help her. Black hole, white hole, red hole, Earth rotation, gravity, and radius, globe. Okay, Brenda, we got them all in.
Draw a circle. You forgot. Draw a circle.
Put some toothpicks
And
on a
tangent.
ball and tangent card on a ball. Pretty much sums it up, right, Brenda?
So what did you want to talk about? Is this what you wanted to talk about? Oh, Brenda's gone. Didn't like to talk about black holes. I think you overdid the whole thing. Guys.
Couldn't help myself with the stressed out black hole during space-time hour. With a spinning ball. With spinning balls. I mean, that sounds like a good time to me. It is Friday night.
Yeah, free for all. But I mean, Brenda did come round today to try and explain to us, because Brenda thought it was funny, that we didn't understand the blue marble elevation profile of LIGO, the horizontal line. So, thought I'd aid everybody. Yeah, it was Glory Hole, yeah.
This is a better mic, I suppose.
Oh, yeah, that's loads better.
Well, that depends.
We can hear more about the stretched out black holes during space-time glory hole hour.
It's called, get your mind out of the gutter. So it's called frame dragging. It's called frame dragging.
Gutter.
The Earth, basically, when the Earth is, because it's rotating, drags part of space-time with it as it rotates and revolves around the sun.
Yeah,
sort of like if a ball is rotating in a thick, say like treacle or honey or some thick fluid, as it rotates, it would drag part of the fluid with it.
Ooh, dirty fluids.
Oh
No, you don't want that.
Like honey. Let's say, don't think dirty, think honey. If you twirl something in honey, it will
Like
drag part of the
space
honey.
honey.
How are you relating this somehow?
Not dirty.
What are you doing?
Isn't
It's to
Seafood?
space time.
Mm-hmm.
The Earth drags part of space time with it as it revolves.
The vacuum.
How is honey not
Space-time.
dirty? Isn't it?
Space
bee
time,
throw up
honey.
or something?
Did I hear space?
Yeah. Vacuum honey. Space-time vacuum honey. Like you think of it like a big goopy liquid
Right.
sort of
No,
stuff.
just think of it as bee throw up because that's what it is, isn't it? Isn't that dirty? I don't get it. I'm confused.
It's definitely
Frame
a
drag
sticky
honey.
situation.
It's definitely a sticky situation.
Well, it's called frame dragging, so that's something you can research into and
What's
something
called?
to give you
Wait.
material.
Oh, is this just at the black hole?
No,
are you just
it's
talking
the Earth.
literally about what sort of ball are you talking about here? You know, like why would we want to just put a ball in honey and see if it fucking drags? Sorry about the language.
Oh, no, that's black holes. Black
That's
holes.
actually that what he said is what Spot On said is actually really good. If you put like say a bowl in a large tub of honey and then you rotate it, the bowl will drag some of the honey with it. That's called, and for the Earth,
Are you
also, that
equating
would be called-
the honey
Hold
to a
on.
vacuum?
to the space time. Yes, space time is a physical part of the universe.
With
Like
nothing
honey.
there, like a vacuum with nothing,
Like honey.
like
Is
a
it clear
vacuum honey.
Will honey survive in a vacuum? Just
No, I think
wondering.
if you suck enough of the air out, turns into like a honey stuff. That might be where they get all of the honey from. I've always thought
Right.
there's too much honey for the amount of bees that we seem to have.
Yeah, I don't believe in bees. Bees are fake.
Space-time honey, just when you thought you heard it all.
And this
Well,
is
honey,
something you
like,
can
has the
try at
same
home.
properties. Yeah.
You can imagine it at home anyway. You can yourself.
Yeah, it does.
If you get
It'd be
clear
like-
glass bowls, you could draw a black hole and a red hole and a blue hole on the bottom and look through the honey as you spin it. Just be careful.
Imagine
Kids.
your children like picking
Kids.
a Go on, back here. Finish. Sorry.
I was just gonna say, kids, don't use your mom's good glass bowls. Get some older stuff.
Yeah, I was saying that the children, when they go and get their basketball and like, oh no, what's all this shit all over it? And be like, oh, Brenda's been dipping it in honey again. Sorry, guys.
Brenda's got kids poking toothpicks in balls. The other guy had people laying strings over their basketball. Shouldn't they be practicing shooting the basketball or dribbling?
Nah,
Oh,
man,
and then
just stick a triangle
drag.
on it, put a couple of toothpicks, make some tangents.
I was saying the other day,
Cut.
I reckon sales of balls have gone up.
Cut a section out of it.
Tell us some more about this
Toothpick
honey,
tangent.
Brenda.
Seriously, we don't need to know any more about.
Essie, come on, man.
Yeah.
Oh,
Brenda's-
come on, guys.
Brenda's
Brenda
def-
just
loves
dropped
it.
that
Essie,
bomb.
really.
Brenda is deafened at the moment.
Yeah.
Brenda
See
has
ya.
deafened at the moment.
Well, it's Friday, and I was going to ask Bev, when did the Friday start? Is it all day Friday? Like earlier on when I was talking with Brenda, was that part of the Friday? Like free for all Friday, or is it actually from the show onwards?
Well, it's only going out live. I mean, that earlier stuff is. I've got it saved because I think it was pretty good.
Mm.
Brenda did really well explaining the elevation profiles. The LIGO. Welcome to the globe of blue marble science.
Oh yeah, you just plot the height, the points of height, right above sea level.
Yeah.
Yeah, and if you plot them, then they form a curve.
A straight
Because-
horizontal line in elevation.
No, they
nothing
form
to do with
curve.
LIGO, though, is
Yeah.
it? LIGO's straight, isn't it?
They form the LIGO's straight. The Earth is curved.
Right. Just say LIGO straight. Yeah, you agree?
I go
LIGO's
straight.
Earth, the Earth itself is curved.
Right.
And I put a video.
So there is a drop in the elevation of the soil. Is that what you're saying?
The elevation of what?
Well,
No,
the
it's the
soil.
elevation of the concrete bit. Spot on.
No, it's not. It doesn't have anything to do with the soil.
Yeah.
Snap on.
Yeah, it's
Snap on.
it's just the concrete, isn't it, Brenda?
Oh,
No, it's from mean sea level.
Yeah, but it's the height of the concrete pad. Because that's what Blue Marble says, the pad at Hanford.
you do know what you're talking about, right, Brenda? You know those elevations are of the concrete pads, right? After all that you've said that I didn't know what I was talking about.
Well, you didn't know what diagram we were even talking about.
No, I said I hadn't seen your diagram. Didn't
Yeah.
never say I didn't
thing.
know about the diagram or know that you're full of shit and that you actually don't know what the diagram represents, which is the pads, the concrete pads, right, Brenda? You knew that, right?
Yeah, it's a plot. It's a plot of the height above mean sea level
Of what?
The plot. The
Of
height
what?
of what?
The height of
Yeah,
a
sorry.
horizontal.
of the northwest arm of LIGO.
You just said it was level, straight.
No, it's straight. It's not level.
It's horizontal, right, Brenda?
Yeah, it's horizontal,
Mhm.
not level. Not level. Level.
Horizontal and straight.
Well,
Not
the,
levels.
yeah, all horizontals are straight,
There you
All
go.
And level?
horizontals are straight. Not level.
but they aren't level. They aren't level.
Mhm.
Can they be level if they're horizontal and straight?
No, level is curved.
Level is
You
curved.
got that out there, all you plumbers and builders?
And because you think level is curved, when you do an elevation profile, or when Blue Marble Science does an elevation profile of a horizontal line, you know, because the globe graph reader expert that you are, Brenda, can read the graph as being a horizontal. The blue line is the horizontal elevation profile, right?
It is a plot of the height, right, of that arm above mean sea level.
Yeah, the elevation profile, right? Definitely. Blue Marble. Like you said, you came round to tell us that you were laughing at us that we didn't understand it. Well, I still yeah, I know. I still don't understand that. I mean, it's fucking ridiculous to me.
Well, I basically agree with MC Toon on a lot of these. He's one of my favorite Glober flat Earth debunkers.
Is he listening in?
I doubt he gives a damn about you today at all.
Shout out McToon.
He has.
He's a debunker, is he? Is he a debunker? What's he debunking?
Flat Earth debunker. He said
he debunks people who say bonkers stuff on the internet.
Bunker stuff, like level is horizontal, right?
Yeah, that's bonkers.
Yeah. Okay. So McToon. Wait a minute. So McToon is going to debunk level being horizontal, is he?
He already has. Yeah, It's pretty easy. Yeah,
that's good. Easy. Yeah.
You just need to cite a reference. That's all you need to do.
Right, and he's got loads of references, has he?
Yeah, he does. Yes, for level, yes, several.
That's McToon of the YouTube fame.
MC, don't say Mick. I mean, I know.
I didn't say Mick. I said McToon. He's like Scottish. He comes from Scottish heritage. He's definitely not an MC. He's told us that, so it's McToon.
No, he's told us what he means by it, so that's what we go by. I do my best to correct myself, but I said McToon a lot.
McToon,
yeah, but correctly it's MC Toon.
Yeah, I know, but we can let's say use a little bit of wizardry to get people to say things. And I think after a short amount of time, I've managed to turn his name to McToon. Lots of people say it. It just rolls off the tongue. McToon. McToon.
I suggest not going anywhere near it, to be honest, because the guy's talking about level being curved. So if you're doing any construction work, you won't be wanting to listen to that.
He has citations to back up his claim. You don't.
He has citations. Oh, no way. He wouldn't have a proof or anything, would he? Just citations, just words.
You don't. Do you need to have a proof to define a term, Bev?
I would hope so.
Why would you need a proof? You just define it, right? Just like Euclid does. He just defines terms when he wants to, right?
Those terms that Euclid defines are they carry through all the way. They are proved within the book.
You don't prove a definition.
Yeah, that's they are proved by the fact that yes, they are proved the fact that they are used and not falsified.
That's not a proof.
Yeah, it is.
No, it isn't. So you don't prove a definition. A definition would be used in a proof. Yeah. It's not the other way around.
So you don't think you can prove perpendicular?
Right. Perpendicular is simply defined as 90 degrees, right? 90 degrees to another line.
It's not 90 degrees, no. At
the
right angles.
Same are those the same thing? Is 90 degrees equal to a right angle?
90 degrees is only 90 degrees if you give the full value of 360, isn't it?
Yeah. Is 90 degrees equal to a right angle.
All right angles are equal. That's an axiom of Euclid.
If all right angles are equal. Are all 90-degree angles equal?
I would say so. If they're right angles, all right angles are equal. So you can change the value of a right angle to whatever you want, can't you? And all right angles will always still be equal. Every one of them.
Are all 90-degree angles right angles?
It depends, doesn't it?
It depends. Are some 90-degree angles not right angles?
Well, some people change angles and the different meanings of angles. So, I mean, just to make sure, in Euclid defines a rectilinear angle as the inclination of one straight line to another. Will you go ahead with that? It's the one definition just right before the perpendicular definition that you're going with.
Right. So you're just not very good at line, are you?
So an angle is definitely the inclination of one straight line to another, Brenda.
Are there any 90-degree angles that are not right angles?
Oh, I wouldn't know, Brenda. Can you
know?
Imagine of any?
So Bev, the great geometer.
I'm not a great geometer, Brenda. It's just basic shit that we do here. Really basic stuff.
Doesn't know if all 90-degree angles are right angles. Bev doesn't know this.
Obviously.
It's amazing.
It is, isn't it?
90 degrees convention. For example, formerly in Russia, they invented new unification, and they divided a circle into 400 degrees. So the right angle in their unification is 100 degrees. So it doesn't change anything in geometry, but units are different.
Yeah, so you would just need to have a way of changing the unit measurement, right?
That's why geometry doesn't operate in units.
That's why we use right angles, Brenda. The correct one. The right
if
one.
If we understand that we're working from a 360-degree reference, then we know that all 90-degree angles are in fact right angles.
Yeah, perpendicular.
If we divide a circle into 360 degrees, then yes, but we can also divide a circle into different number.
Yeah. Is that what you thought I said?
Into two.
Is that what you thought I meant?
The proof is that the angles on both sides are equal. And they are equal only in one position, and that is called right angle.
Are all 90-degree angles?
Oh, Brenda, come on. Stop with the childish shit. All right angles are equal. Yes, if you divide a circle into 360, all of the 90-degree ones will be called right angles. And they will be exactly the same. Well done, Brenda. You're a genius.
Finally, we get right angle. It doesn't call it 90 degrees.
Like pulling fucking teeth.
Well, you managed to get that one out of us. Well done, Brenda. You genius. But, you said... in the presence of gravity, Euclidean geometry doesn't work, but that says Euclidean geometry says all right angles are equal, that you just agreed with.
It's obviously we're talking within a certain context, right?
Yeah, we're talking about right angles in reality, Brenda. That's where they get used. But you say it doesn't work in reality because there's gravity around here. So what are all right angles if they're not equal in the presence of gravity?
You presuppose that Euclidean geometry is true.
Yes, it is definitely.
Yeah, that's
absolutely
yes.
That's
a metaphysical presupposition on your part, and it is false.
Not metaphysical. No, Brenda, I can prove it.
Can I just say that I can create a right angle in construction and prove that it's the right angle using Euclidean geometry?
Yep.
You can't draw a right angle in reality.
What?
What?
Yes, you can.
Of course
You can't.
Yes,
You can draw something that approximates or represents a right angle.
No, you can use geometry to literally make a perpendicular.
Oh, because geometry is conceptual. It's a concept.
It's not, Brendan.
Angles, lines, and
you
points.
can actually draw a
are
circle in
in-
reality. You
That's
can
right.
do
Use
that.
geometric principles. Principles, yeah?
Yeah, you
That's what
cannot.
we use. We use the 3, 4, 5. Yeah, you know
You
that? You know what that is?
draw.
Do you know the Pythagorean theorem?
You
3,
cannot
4,
draw.
5. A
you-
squared plus B squared
Jesus
equals C
fucking
squared.
Christ,
So
you
the
people
hypotenuse.
are it's like talking with
Do
fucking
you understand
2-year-olds.
that?
Calm down, Brenda.
It really is.
We
yeah.
know it's free
We're
for all
trying to
Friday, but
explain
don't
to
get
you what a
triggered.
right angle triangle is.
So,
but you're just getting
Can you
triggered.
draw me? Can you
Gets
draw
triggered
me
at
a
right-angle
line
triangles.
in reality? Draw me a line in reality.
Yeah.
Can you draw a line in reality?
Absolutely not.
Wow.
Oh dear.
Yeah.
This is embarrassing. Brenda can't draw a line in reality.
Absolutely not.
Globe
Yeah.
geometry's got Brenda, right?
I'd like to. I want to hear more of that laughter. You can't draw a point, a line, or a triangle, or a square, or a circle in reality.
You have a citation for that?
Is that globe? Is that
Yeah, I'm
globe
not
geometry, Brenda?
Just show me in reality,
You have
right,
a
a
citation
line that has one only the dimension of length and no width. Go ahead, do that.
You've never seen a line,
Oh,
Brenda. Have you never seen a line in geometry? Have you ever seen a triangle and it has 3 straight lines on it?
yep.
Brilliant.
Yeah, these are.
So I think we all know what a line is then.
Oh yeah, they're
Yeah.
concepts. They're concepts in your mind. They're not in
So
reality.
we do know that what a line is because you've seen them. You've seen
Yeah,
a triangle, so you understand what a line is in
No, I've
reality.
seen-
So thank you
seen
very
rep-
much for agreeing with us there, Brent.
No, I didn't.
We
I
are.
said-
We are making
You just talk
strides
over
here.
me. You talk over me
Hmm.
and then claim I agreed with you when I didn't. No,
You have.
I have
We just
never
agreed to a straight line to a
No,
triangle.
no, I didn't.
Yes, you did.
Straight lines are concepts. You have never seen a straight line in reality, Bev.
Can we get someone in here that's going to agree with you? Can you find someone that's going to
never
come in
seen a
here and agree
circle.
with what you just said?
citations.
You've never seen a circle
got-
in
have you
Yeah,
got
I
reality.
have
someone to
definitely
back-
seen a
have you got
circle,
anyone to
Brenda.
back this
I've
up?
definitely seen
Not
a
in real.
circle.
You've seen a representation of a circle. You have not seen
Yeah,
a
it's a
circle.
circle. It's a circle.
No,
Brenda.
a
Definitely.
representation of one. You've never seen a circle.
Yeah, yeah, of course you have.
No, have
Yeah.
you show me a circle?
We do that. I think it's elementary school. Circles, squares, triangles. Loads of people have seen them, Brenda.
Well,
You're not going to be. You're not talking to the audience here now. As a general, I'm telling them that they've never seen a circle. You can't be that bad, Brenda. Globe geometry can't have got you that bad over the last few days.
Right. So maybe you went to elementary school, but I went to elementary school.
Mm-hmm. And we did circles, squares, triangles.
We drew shapes that represent the concept, the idea of a circle, a line, and a point.
Uh-huh.
You've never seen a point, have you, Beth?
A point is that of which has no parts. So, I mean, I
It
could have seen infinite of them, couldn't I? How would I know?
It has.
Have I ever seen something that doesn't have any parts? Well,
no, I don't
could
think
be
you
looking
have.
at loads of them, couldn't I? Could
No,
look right
you-
straight through them.
Have you ever seen something that has neither width, breadth, nor length?
Well, I would say not, Brenda.
No, you've never seen.
Have
You've never
you?
seen a point.
Have you ever
You've
seen a
never
point?
You ever seen a unicorn? I mean, what
never
is
seen
this
a point.
question?
This is great, isn't it? I mean, this is the globe argument.
Yeah, what's your point?
That we only have representations of concepts and ideas like point, line, right, and circle.
And
Circle,
these
square,
representations are
Right.
sufficient.
distance.
Yeah, but they're
They are
not. They're
sufficient.
not the actual things. They refer to.
Yeah, a
the-
square is a
No,
square.
not refer.
Brenda.
They
It is.
represent. They
Yeah, that's what-
represent.
That's what refer means, you mong.
Whoa,
No, it
Brenda.
means that
Now,
they
Brenda,
represent. So
please
when
don't.
I see
You've only
when
been
I
here a bit.
see a drawn line, which is straight enough to call it straight, I call it straight line.
Yeah, you can call it that, but it isn't.
What do
Because
you call it?
if you
It
look
is.
at it under a microscope, it won't be straight, and it won't be a line. It will have breadth.
Like a survey microscope?
Yeah, everything in reality, Brenda, is 3D.
No, that's your claim. How did
That's
you
my
decide
claim.
that?
Because it is.
Yeah.
Everything is in reality. It is
No, you don't get
3D.
to just say, you don't just get to say everything is 3D because it is. You have to justify your claim.
No, it is, so you get to say it.
Yeah.
No, that's not how logic works. That's not how anything
What
works.
do you mean that's not how logic works, Brenda?
It's not. You have to prove your claims. Otherwise, it's just
It's not a
bold-
claim, Brenda. It was just everything in reality is 3D.
Yeah, that's a claim.
Yeah.
What?
Well, you can measure it, can't you? Like
Like
you've just said, Brenda, lines don't exist. Why is that? Because something has length, breadth, and thickness. In
No, I didn't say
reality,
lines. I
3D.
think
You
line-
just said that.
Yeah,
It was your argument against.
I think lines exist. I don't think they don't exist.
What, you liar? What did you just say before?
Line,
You
I
bull-faced
just
liar.
said- Okay, so allow me to
You're a dial.
answer your questions. Lines, circles, points, squares, triangles, all of these exist. They are concepts, but they exist.
What concepts exist now?
Of course they do.
Where do they exist as
Your
concepts?
Your mind. They're in your mind.
Right. They don't exist if they are in your mind, Brenda.
Yes, they do. What, your mind doesn't exist? I think you could make a good argument for that.
They exist in reality when you draw them,
Oh,
when you
they
make
exist-
them, when you sculpt them, when you realize them. You make them real in reality, then they exist.
No.
Yes, they are.
They
They are. This is image of. If you draw a straight line, this is image of
It's a
the straight line.
representation. It's not the thing itself. It's a representation of the thing.
No,
It's
this is
not
image.
the thing itself.
Image. Yes, like
An
like
image is not the thing. An image of a thing is not the thing.
Like
It
a map.
is the thing
Brenda.
that is. The map is the map, Brenda.
Triangles, lines are concepts. Concepts exist. They exist in your mind.
If I go, look, there's a triangle, and point at it, and it's there, a triangle, then it exists. That triangle that I'm
Oh.
pointing at, going, look, there's a triangle.
Yeah, but what you're pointing at isn't a triangle. It's the representation of a triangle.
Okay. Well,
yes, this is
most people would
of
say
course it
yes,
is.
Brenda, wouldn't they? They would say, yes, that's a triangle. Most people.
And this representation we call representation of triangle. We call triangle. Correct.
Yes, but we understand that it's not actually a triangle.
It is a triangle, though. That's what
No,
people
it
call
isn't.
it.
It stands for, or stands in the place of, refers to, or represents the
A triangle.
the concept or idea of a triangle. This
Yeah.
is something I learned in elementary school.
Yeah, it's a
And
triangle.
they are sufficient representation for a triangle. So drawn triangle is sufficient representation for ideal triangle,
Yeah.
and that's why we call it triangle.
Not
Everything
perfect
drives.
Plato's perfect form that can never be achieved of anything. Right? No, it's just a triangle.
No, it's an idea. It's an image.
Plato's ideal form is an idea. A triangle that you draw is a triangle.
No, the triangle you draw is the representation that refers to the Platonic forms.
You
don't
just
even
need
know
three.
Plato.
You just need
Not
3
refer-
points, don't you, Brenda? Really?
Yeah, you don't even
Ideally,
know Plato.
3 points.
A point, line, circle, square, whatever you want to call.
Just 3
whatever you wanna
points.
talk about. A
Because
line-
the concept, Brenda, is the ideal straight line between those 3 points. There's your triangle.
That's the concept. What we
It's a
draw
triangle. In reality, those 3 points exist.
Wrong.
Therefore,
Wrong.
the triangle is there. In
Wrong.
reality, there is the shortest
Wrong.
distance between those points.
Yeah, the figure that you draw on paper or
realize
mark
in
sand,
reality, measure
yeah,
distances.
That's not a triangle. It's not a triangle itself. It refers to the concept or idea of a triangle.
Yeah, 3
And
points.
if we draw triangle,
that's
this is a sufficiently true image of this ideal triangle. So it matches
Right,
reality.
I agree. It's an image of,
Yes,
or an
image
idea,
of,
or a
yes.
representation of the concept or idea. Yes, you're on my side. I see. Thank you.
Not correctly, because you say that they don't exist, but they do
No, I
exist.
say they do exist.
Right, okay,
You
okay.
Don't
All right,
strawman me.
let's
I said they do
let's
exist.
get
Concepts
over
do
this
exist.
triangle, whether they fucking exist or not. It's a ridiculous fucking idea that you're coming over here, Brenda, to tell us that triangles don't exist. Everybody uses triangles,
You
trigonometry, triangulation. Triangles are used
You liar.
in
I very
reality,
clearly
Brenda.
said, liar. I clearly said
stop
that
with the
triangles
fucking
exist.
lying.
You said
You're
they
a
don't
liar.
exist.
I said they do exist. They are concepts.
Brenda, if you draw the triangle on piece of paper with a ruler, and it's sufficiently not curved, it is straight line, you can see that these lines are straight, and you cannot see any curvature or incorrection in that lines. Therefore, this representation is, you cannot distinct between your ideal the triangle and this drawn triangle. So
I can distinguish them.
No,
Yes, I can explain it to you. I can, because if I look carefully at what I drew, the lines have breadth.
But in this line with breadth, there is this ideal line inside. You know that.
The idea is in your head, dude. It's in your mind.
We'll see. Hey, Brenda, what's the surface of the Earth? What's the surface of the Earth, Brenda?
It's not
3D or
on
2D?
You're segueing to a different topic. So it's
No.
not.
I want to expose your dialetheism.
Yeah, I don't care. I don't care.
What's the surface of the Earth, Brenda?
Yeah,
2D or 3D?
Yes, you're pivoting away from the topic.
Point, Brenda. What do you
No, it's
get?
ridiculous. Just tell me, what is the surface of the Earth? Is it 2D
So,
or
I'm
is
not-
it 3D, Brenda?
Oh, the surface is 2D. Yes, absolutely.
You hear that, people? You're standing on a 2D surface.
Any solid object.
It doesn't exist, Brenda.
You said they
You
don't.
just said it
Your
doesn't
your
exist.
surface doesn't
Brenda.
exist, Brenda. What are you talking about?
Absolutely. Yeah, it exists as a concept, of course.
What, the
So
surface
you're
of
standing on a
everything is only a concept.
But do you think that the Earth has a surface, Se?
The surface of the Earth is a concept to you, Brenda?
Yeah, because if I go out into my yard, I step into dirt, right?
And is that a concept or is that 2D? Is that dirt 2D?
The dirt is 3D.
There you go.
There you
It's not
go.
2D.
Welcome to
So the
reality,
concept-
Brenda.
So the
Welcome. Right.
concept of surface is itself an abstract concept.
So the top of the dirt is what, Brenda?
There really isn't a top of the Earth. If you look closely at the Earth, it's tiny little grains of matter, various particulates of matter, right? It doesn't have a surface.
But you just said it's 2D. Are you contradicting yourself?
If you take, for instance, a sandbox, look at the sand. If you look at it closely, it's grains of sand. There's no surface there.
So you're contradicting yourself. So the surface of the Earth you just said is 2D, Brenda, correct?
No, I'm saying surface itself is a concept that we use to talk about things in a certain way. We can do that. We're allowed We
You
are
realize
allowed
the
to talk about.
nonsense. You realize the nonsense of what you said, and now you're changing it. So the surface of the Earth now is 3D, Brenda.
Yes, well, according to what you said, it has to be
please. Hold on,
3D.
paper. Please hold on.
Surface is a geometric concept or idea, and
So
we
the
apply
surface
it.
of the Earth is a geometric concept.
Yes, just like line is a geometric concept. There are no lines in nature, and there are no surfaces in nature.
So where you're standing on the Earth, I just want to make sure that we got this straight. When I'm standing on the Earth, I'm standing on a concept, not on the Earth, the ground.
No, I'm not standing on the concept.
So is the Earth 2D or 3D, Brenda?
The Earth is a solid object, which is a collection of atoms packed together.
Is
Yes,
it 2D or 3D, Brenda?
It has length, breadth, and width.
So that would make it 3D, right? The Earth. Now,
The whole
the
extent of the Earth
surface,
is.
we agreed. Okay, so now the surface of that object, what is it? What is it?
Well, it isn't a smooth sheet of paper, is it?
You said 2D before. Are you now
Right.
changing your mind, Brenda?
No, I'm not.
So the surface of the 3D planet, which you call Earth, is 2D, correct?
Yes, when we're talking about it that way, yes.
I'm done with her.
Yes. So
Brenda,
if you look at,
you are wrong, because if you
I'm not.
take into consideration these atoms which are on the surface, this is the last atom, which is before air atom. Still, this is an atom. It's 3D still.
Of course it is.
So if you sum up these all atoms on the surface, they are still objects, three-dimensional objects.
Of course
these
they are.
atoms.
Of
So
course
they
they
are
are.
not 2D.
Yeah, but the surface of the Earth is 2D.
So surface of the Earth, this is not the collection of these atoms.
The surface of the Earth, it's a concept. It is a way of talking.
The concept
about
for
an
you,
object.
Brenda. For everybody else,
No.
it's like real.
Very real.
If
But you can see that, Brenda, you can see that with your own eyes. Surface of an object you can see. So you can see
No,
with
you've
your
never
eyes
seen a
and
surface.
concepts.
You've never seen a surface. A surface is a concept.
Oh, Brenda.
Oh, but we can see with our eyes.
Like a work
surfaces.
surface.
Oh, you
when
can't
you
see
when
a
you're at
surface.
work and you have a work surface, you can definitely see the work surface, Brenda.
But if you look at that under a microscope, it is not flat.
It's a surface, though, Brenda. It's a 3D surface. It doesn't have to be flat, Brenda.
It's composed. It's surfaces
3D.
don't have to be flat. Bev, is that right? Surfaces don't have to be flat.
Yes, they're 3D, Brenda. For fuck's sake, the surface of a ball is 3D.
Is Earth a flat?
No, the Earth is not flat, Brenda. Get that out of your head. Please,
So
Brenda, do not think that the Earth is flat anymore.
And
Lose
ball
that
is not
really
flat. Wait a
fucking weird concept out of
So
your
wait a minute.
head. Right?
So wait a minute. You're trying to say
we're not flat earthers here, Brenda. Please,
Earth have a
please
surface
don't
or
bring
not?
flat Earth into this. It's ridiculous. To
the
think
Earth-
that the Earth is 2D is absolutely ridiculous.
Does the Earth have a surface or not?
It's 3D, Brenda, yes.
So it doesn't have
Everything
a
everything
It
in
has a
reality
surface.
is
So the Earth-
3D,
surface. So it
Brenda.
doesn't have. So the Earth does not have a surface.
Of course
then.
it does.
Wait a minute. You're contradicting
No,
yourself.
you're contradicting. You just don't think that
You just said
surfaces
it's
can be
3D, but it
3D.
has a surface. How is that possible?
Because there are 3D surfaces, Brenda. Hello?
No, there's not.
We live in
No, there
reality,
isn't.
Brenda.
No,
That's
there
what-
isn't 3D surfaces.
Of course
No.
there is.
No, there isn't.
Yes, there is.
Surfaces are are 2D. They are one dimension below the solid figure.
Have
That
a citation.
No, Brenda.
Show us a citation.
It's n minus 1, right? So if you have an 8-dimensional
God.
sphere
N minus
and it's
1.
An 8-dimensional sphere. Brenda.
Yes, if you have an 8-dimensional sphere, then its
Okay.
surface.
What the
Again.
fuck's an 8-dimensional sphere? You think
sphere-
everything's 2D when you look at it. Like,
An
where do you
8-dimensional
get 8D from?
8 freaking D?
Yeah.
My God.
An 8-dimensional sphere would be a sphere
Brenda,
with 8
You
dimensions.
you shouldn't really go to 8. Just stick at 3, right? In reality, let's stay in reality. Let's get 3D sorted first.
So an 8-dimensional sphere.
Wow,
would
Brenda,
have a
you've gone
surface-
from 2D.
Would you stop interrupting?
You've gone from
me?
2D to 8.
Yes,
You've
to
completely
illustrate-
skipped 3D, like reality, that
yes,
everybody else
to illustrate a
understands.
point. To illustrate a point.
To illustrate a point of how fucked your head is.
So the surface
think
of an
so.
the surface of an 8-dimensional sphere is n-1, so it'd be 7 dimensions.
What's in 8 dimensions? Come on, Brenda. You're talking
8-dimensional sphere is a sphere with 8 coordinates, all orthogonal to each other.
You're delusional, Brenda.
Did
Can
you
show
just
us
say?
this?
Did you just say an 8-dimensional sphere has how many corners?
It has I said coordinates, not corners.
8 coordinates.
Right. It would have 8 dimensions.
Are they?
Right. And they would all be orthogonal to each
8
other.
coordinates.
Eight
What are they,
eight
Brenda?
axes. 8 axes. Every axis is orthogonal to all the other
Perpendicular.
At what angles they are to each other?
90
Perpendicular.
degrees.
Yeah,
90
that's
No,
degrees.
they cannot. You can produce only 3
No,
in
that's
the 90
That's
degrees.
true. That's not true. You can have 8. You can have 8.
No, you no.
You can have any number.
Okay, so
Show us, Brenda?
please draw to us this.
I'll
You
just
have
let
to
you
show.
guys- I'll let you guys let your fingers do your walking for you.
What the hell?
Just the fact that we're entertaining this is sheer delusion.
This is-
Eight-dimensional sphere. This is like unbelievable. Not even Michio Kaku came up with that one, Brenda.
Oh, yes, he knows about that. He would know. He would understand me completely.
You're in La La Land, like, yeah, and you don't even realize it.
This is just math, dude. It's just math.
No,
Brenda,
it is not math at all.
eight-dimensional sphere. Think of what you're saying. I mean, I know you're trolling, but come on.
I'm not trolling. This is absolutely not. An 8-dimensional sphere has 8 axes, all orthogonal or perpendicular to each other.
Please show me that. Please show me that in picture. You have to depict us, to depict it.
No, I don't have to.
No.
Yes,
No, I
to
don't.
prove that we are right. This is your claim.
Brenda,
So
you're wrong.
you have to support it.
I don't.
Please.
I don't have to. No, it's not
9 dimensions, not 8. They
Oh, I said-
changed it. It's now
I said
9.
8. No, it's 8.
No, they got rid of 8 2 years ago.
No, it's
Do
5.
your research, Brenda. Before you
I
come
can
to the
have
conclusion.
a sphere of any dimensions.
No, they stopped at 9 2 years ago.
No, they didn't. No, they didn't.
See, I can make up shit just like you.
No, you can have an infinitely dimensional sphere.
You have a pen and a pencil, Brenda. Can you draw this thing for us, please? I want to get an
Not
idea.
anything for you. You just do the math. You just do the math.
Yeah, there you go.
Just math?
N minus
Yeah.
1.
Yeah.
Can't you draw those pretty circles like 8? Like I want to see how. Like I want to envision this.
How about you show it to
Yeah,
us?
it's not my job to do your work for you. You go and look it up yourself.
No.
on,
I
come on,
need
Brenda.
I need this coordinate system on the paper, please.
I didn't understand anything he said.
You just show us so I can show
Coordinate system. This 8 coordinate system. You have to show this on the paper.
We know X, Y, and Z. Can you just give us the other 5?
You could just name them 1, 2, 3, 4, and 5.
Yeah, but go,
There
can
you
you
go.
do that? Go on then.
Yeah, I just
you
did.
do that.
No,
I just did.
Well,
have
we
to-
know
no,
what
you-
X,
you
Y,
are
and Z
talking.
look like.
yes,
No,
to
they're all
show them.
lines. They're all lines that are orthogonal to each other.
No,
Okay.
no. Don't
X, Y,
talk
and
about
Z are.
them. Show them. Show them.
They're axes. They're axes. 1, 2, 3, 4, 5, 6, 7, 8. There you go. Done.
No, don't talk about
it,
them.
Brenda,
Just show them on the
Please.
picture.
No, I don't have to.
Can't. This is
Because
a
because
case
you
of
can't.
give
Oh,
me
you
R.
have to
It's
do the
something
math.
Brenda can't give you, right? And keep
I don't have
asking
to.
Brenda for something Brenda can't possibly give you is ridiculous, And it just makes Brenda look fucking stupid, to be honest.
I
I'm
love-
trying to
I
save
love
you,
it.
Brenda.
I love it. I love this. I love it.
You love talking about
Yeah, absolutely.
not
wasting-
reality.
I don't even know why y'all.
She loves wasting our time. Yeah. Let me
Not
help you,
wasting your
Brenda.
time.
I
I'm,
wonder-
Fourth
how many-
dimension.
No.
I'm introducing
How
you.
many?
I don't.
Can I
Right,
just-
wait
can I
a
just
minute.
ask-
Yeah, whoa. Everybody,
I don't
please.
talk that much.
Everybody, wait a minute. Whoa. Everybody, calm down. Remember, this is just
calm.
Brenda. Yeah, I know, but everybody's trying to
No, it's
jump
not.
to ask Brenda a question. It's just Brenda. There's no need for everybody to rush into it. And since Brenda wants to be the star of the show tonight, that's right, Brenda. You want to sit on a pedestal and you want people to be asking you questions about your model, right? That's what you want.
Of course.
This isn't a model. This is
Yes,
just,
it is.
But problem is
dimensional
that Brenda doesn't respond
Mhm.
to question. I ask Brenda to show eight dimensions in coordinate system.
Yeah, show me the number 2.
No, I didn't
No, go
ask
ahead.
for
Show me-
numbers.
Show me the number 2. Show me the
coordinate.
number 2.
No,
Yeah,
show me
I've got one
coordinate
as well.
lines. Eight
Show me the
coordinate
number
lines. 8 coordinate lines in a 90-degree relationship.
Absolutely. Show me the number 2.
No, not number. We are talking about coordinate system. Show me
Yeah.
8 coordinate
Val?
lines in relation to each other with 90 degrees. That's what you were talking about. You said that between them there are 90 degree. So you have to show them on the paper. I can't show you 3 on the paper. Like a part of cube. X, Y, Z. Simple. Show me 5 remaining.
You do have to stop talking. So,
And is that
Bev,
logical?
Bev, what you're showing me is the numeral 2, not the number 2. I want you to show me the number 2, not the numeral.
Yeah, that's what we're doing, Brenda. Obviously.
No, you're showing me the numeral. I want you to show me the number.
There you go.
I've just
2.
about had enough for you, Brenda.
That's not
That's
a
2.
number.
1, 2.
The numeral. That's a numeral, not a
No,
number.
it's not. It's 2
What?
of them. 2.
What's the difference between a numeral and a number, Bev?
Brenda,
2.
why are
You
we
asking
showing
for?
you things when you're not showing what you've
You're
been
waiting
asked
for
to
the
show
8
at all?
dimensions. Where's that at?
What's the difference? What I'm just introducing you to concepts in mathematics
Yeah,
that you're not
without
familiar
proof,
with, and
without any
then you get all
citations,
triggered.
Blah,
You
blah,
get all
Give me
triggered.
some space time, honey.
Those are
Yeah.
all. That's frame dragging, right?
Where can I buy some space time, honey?
Game dragging.
No,
At
we,
the Space-Time Honey
we can
store.
show you 3-dimensional coordinate system.
No,
We
you
just
can't.
need- yes, we can.
Brenda.
No, you can't.
Fucking
No, you
hell.
can't. You
We
can only
Stop
show me.
saying no, you can't, Brenda. It's getting
can't.
old.
You can't, paper. All you can show me is a 2D representation of a 3D coordinate system.
Okay,
Right?
so I ask you for
Right?
for representation
Right?
of 8D
Isn't that,
of
am I
8.
right or
I
not,
ask
paper?
you for now
Am I right
to
or
show
not, paper?
Goodness
to show-
gracious.
to
This is starting
show.
No, you're
I ask
not,
you to
Brenda.
show 8-dimensional representation of your coordinate system. Now,
I
please.
don't fucking have to.
Yeah, why are you moving off of that, Brenda? You said it.
Oh, because you people are all over the map, all triggered, also salty, also massively triggered
You're
and
just
buttered.
Give me a 2D object.
Such salty tears, salty,
Give me
salty.
a 2D
tears.
object, Brenda.
I feel bad for you.
Give me a 2D object, Brenda. See you later. Who's trolling who, Brenda? You think that you control us? Give me a 2D object, Brenda.
Can't
I'll
quite
show you. I'll
straight
show you.
line.
I'll show you an 8-dimensional sphere in the text chat.
Let's see it.
Go on then.
How can it be 8 dimensions
crap,
bet
with,
what was
on a
that?
2D?
Pseudosphere.
How can it be a good question?
The little caret indicates that it's a superscript.
S
So
to
it's
the power of
Time
8.
waster.
No, it's not power. It's superscript.
Right. What does that
S-
mean?
It means it's an 8-dimensional sphere.
Oh,
what
so
the S
that's an
stands for.
8-dimensional sphere, that S.
There you go. Yep. There you go.
Yeah, wow. That's amazing, Brenda. I'm so fucking glad that you came over to explain this to us.
Where did
Oh, yeah.
No, but
Where did you
you
post it?
were asked to draw this, not to explain or name it.
Oh, that's it. That's
just
it.
name
No,
it.
no, that's it. That's it. Look at it. Wow.
S.
Let's have it.
This is not
S and a
sphere.
8.
I cannot
Yeah, it is. That's an
recognize sphere here.
8-dimensional sphere. Don't go with it. Go with it. We'll move on to something else. Wow, Brenda, thanks for that.
You mean S8?
Yeah, that's it. That's it. 8-dimensional sphere. Look at it.
Holy crap, Brenda. You outdid yourself.
Yeah, that's brilliant.
Why can't I refer to things with algebraic terms?
You're delusional. That's why.
No, don't.
No,
See, that's fucking amazing, Brenda.
algebra.
That is one of the best 8-dimensional spheres that I've ever seen.
Beth, it's algebra. It's algebra.
I know it's an 8-dimensional sphere. It's amazing. We should frame that. Remember that. Let's
algebra is not a sphere still.
Let me.
Sorry.
I'll pin that. Look at it. Pin that
So I
message.
asked her
Keep
to
that.
give me a
Pin it.
2D object, and she writes on the freaking text S8.
Yeah,
Like, this day is going to go down in history, Brenda.
that's brilliant. Oh, look. Euclid's done a fucking 9-dimensional sphere.
Told you.
Yeah.
I told
Ooh,
you.
boom.
Yeah, that's
Add
absolutely
one.
true.
Plus one. Let's have it.
And you can put any. You can put
How
any
far?
number.
What's?
You can put any number up there.
Haven't they said that there's a limit?
Right now it's 9.
You might
No,
want to
there
check.
isn't.
There's no
Are
limit.
you sure? You might want to check with Michikaku.
You can have a sphere with infinite dimensions. So
Or
you
you
would
might
put,
want to check, Brenda, before you embarrass yourself, you might want to check Dimension Man himself, Michikaku.
Yeah, I don't really.
Have
pay
you
any
got your
attention to him.
geometry there, Brenda, though, to support this? Because Euclid only went to 3, didn't he? The sphere in Euclid was the revolution of a semicircle about its diameter. That was a sphere for Euclid. So what's the definition of these ones in this other? Because it's definitely not Euclid. Have you got a definition of these spheres in these other geometries? Do they have their own geometry? When you just like plus one, is there a geometry that's already been wrote up there? Because I would imagine the addition of an extra dimension changes the geometry tremendously. With Euclid, it did, didn't it? He had to book 11. He had to put some new axioms in there, new definitions of stuff to add that third dimension in.
Then you can put a 4th, a 5th, a 6th. But you might want to check with Michikaku because you put a cap on that, Brenda. You might want to keep up with your fantasy stories.
I don't understand why you keep.
You don't
talking about
understand.
Nietzsche.
Top astrophysicist, you don't understand. Obviously,
Brenda
you
So
don't.
what? What would that have to do with mathematics?
You not understand it.
Are you kidding me? What does mathematics have to do with astrophysics? You're kidding me, right, Brenda? That's all it is, basically.
All in the mind.
No, it isn't. It's not all astrophysics is.
Mostly all numbers and freaking calculations. Yeah.
Astrophysics is just physics.
Physics is just physics. Yeah.
Right. It's not. It uses math, but it isn't all of math.
Oh, it uses math. Correct, Brenda.
Yeah.
So this is the top astrophysicist telling you there's a cap on
Yeah.
dimensions. Now, not that I believe him, but just hold on. It's your fantasy.
Oh,
Now, you're
you mean
disagreeing with him?
Oh, for string theory? The string theory, the cap is 11 dimensions, right?
Yeah.
Yeah, that's for string theory. I'm not talking about string theory.
That's for dimensions. They can be no more than 11 dimensions, according to your guru, one of the top astrophysicists.
In string theory, not
And
math.
Sir Brenda Isaac Newton is telling us now unlimited space time, honey.
Yes. No, I'm not talking
Bullcrap.
about space. I'm not talking about space time.
All you do is talk bull, Brenda.
This isn't space time.
We're talking about math.
Math.
Math?
Yes, that's what a sphere is.
Yeah, it's 3D. A sphere is Euclidean. 3D.
Well, not all of them are. An 8-dimensional sphere isn't Euclidean, is it?
There's no such thing as an 8th-dimensional
is.
sphere, but there isn't.
You can just define it. You can just define it into existence.
You can just define it into existence, Brenda. Are you sure?
Absolutely. That's what you do in math.
No, no. That's what people who use definitions to magic things into reality. But
like
reality
Euclid?
only exists in your mind. You can say
like
words and spells and magic things into your mind and then imagine that they're real.
Like Euclid did. Like Euclid.
Euclid goes to 3D. He only went to 3, reality.
No, Euclid just magicked things into existence, didn't he?
He just defined circles, triangles, and squares.
No magic at all.
He magic.
There's no magic about
Do you know
that,
what proof is? Do you know what proof is, Brenda?
You don't
You know what
prove.
proof is?
You don't prove definitions.
No, fuck.
Brenda, do you know what definition means?
It means to define something.
No. This is tautology.
Yeah, all definitions are tautological.
The origin of the word. This is folded word. De finis. Finis means border. De from border to border. This is definition. You defining things means that you are describing from which border it is to which border it is not.
Yeah, you don't understand the meanings of words by etymology.
I know. I
understand. It's called the etymological fallacy. Right? What is the etymological fallacy, Paper?
For example, if you have triangle, the finis, it means border. It is number of angles or sides.
This is just the etymological fallacy.
So 3 sides means we are talking about triangle. If you have
that's just the etymological fallacy.
So this limit of the triangle is 3 to be 3 lateral. This is definition of triangle. 3 lateral.
No, it's not.
So if it is 4 lateral, it means that is a square, for example.
That's not the definition of a triangle.
Yes, this is definition.
No, it is not.
It can be it is definition. It is part of definition at least. So you can describe this as that. So this defines triangle, because if I say that triangle, it is a geometrical figure that has 3 sides, it is definition of triangle.
Right. So that's the etymological fallacy. Right.
This is
so
not fallacy.
We don't know things by their etymology. We know things by their definitions.
Yeah, but you just said you can make shit up, Brenda, with definitions.
I gave you definition of triangle.
3 angles, triangle. Hello.
What is Euclid's definition of a triangle?
Oh, that which it's a
Brenda, just go make some coffee and take a break. You're giving me a headache.
Trilateral figure.
Brenda, make a shit up fallacy.
Can please any other baller come in and talk with us? Please.
Yeah, Brenda, you're boring.
Please save us.
Brenda that says that definitions, there's some sort of a fallacy around definitions, yet Brenda also says that you can define things into existence.
No, that's not what I said.
It is what you said, Brenda. Definitely what you said. Yes.
Where'd you get your 8 dimensions from?
I said that paper was committing the etymological fallacy. The history of a word doesn't tell us what the word means.
Yes, and definition is very word definition. It has meaning, so it defines itself.
Words have meaning through their usage, right? How people use them is what determines.
We've done that, Brenda.
Words mean
Trivium.
So
we did that.
Usage is what determines what a word means, not its etymology.
Mm-hmm.
You said you can just define things, bring things into existence.
Yes, that's called. Well, in this area, it's just how math is done.
It's called magicking things into existence, Brenda.
It's also called mathematics. It's called mathematics.
No, that's magimatics. That is.
But they just invent new terms and the rules that govern those terms, and then they see how things work out. And if it works out, we got a new branch of mathematics.
Wow, Brenda.
Who does that?
Yeah, that's how it works.
This is how it works, Brenda. In your mind, this is how it works.
No, that's how it works everywhere.
No, it doesn't work like that everywhere, Brenda.
Yeah, it does. That's what mathematicians do.
No.
Definition is description what the thing is.
Right. So I could make up a number which is negative, which is the product of two whole numbers. Say
you can make up a number. I think all the numbers are already there, Brenda. I don't think you can make one up.
I can make up a number which is negative, right?
You just do a number and put negative in front at the beginning of it.
A number whose square is negative.
You can't.
I can't?
Well, you mean an imaginary number?
No. I mean a complex number.
And what the square is negative.
Correct.
So you can times one number by another number and end up with a negative, can you?
That's absolutely right.
Go on then.
Yeah,
negative 2 times negative 2. What's the answer?
It's a plus bi. That's the number. That a plus bi squared is a negative 1.
I think you've got I there, which is an imaginary number, isn't it? Didn't you just say that you weren't going to use imaginary numbers, but then you put an I after it, which...
Imaginary numbers are real, Val.
What?
What?
Oh
my God.
Jesus.
Imaginary numbers are real. This is great.
Yeah. You did just say that then, Brenda, right?
Are real.
The diletheist in you
Brenda,
just snuck out.
This is 100% dialetheism. Imaginary numbers are real.
There are unreal numbers.
Complex numbers were invented a long time ago. Same with non-Euclidean geometries.
Imaginary.
The proper term today is complex.
That was 2 years ago, Brenda.
Wrong.
Brenda.
Are you sure you should be here, Brenda? I mean, that is imaginary numbers are real.
Well, thank God Alpha
I
is
love
here.
it. I love it. The laughter of fools.
Okay, sit down and be quiet now. What's up, Alpha?
Alpha's come to back Brenda up.
Listening.
Thank God. Thank God you're here.
Do you want to come and put your arm around Brenda and give him a... Do
you think, Alpha,
give
that
him
there's...
talking to?
Do you think, Alpha, that there's a number whose square is a negative 1?
Wait, tell me about your 8 dimensions.
No. Let's do the real imaginaries first.
Okay.
Tell Alpha about your real imaginary numbers.
All numbers are made up, right? So
of course they are. Yeah.
So I mean, you guys saying that it's not a real number is irrelevant because you could say no number is real, essentially. So what Brenda's saying isn't incorrect.
It's incorrect. Did you say?
Oh, you got help.
What's incorrect?
Brenda.
It's not incorrect.
It's not
because-
incorrect. What, to
So it
say
is-
that imaginary numbers are real?
All numbers are imaginary, Bev. They're all a construct.
So imaginary
you
numbers
can't
are
say
real,
only
you're
some
saying
are
is an
imaginary and
okay
some
thing
are
to
not.
say.
So
Because
that's
everything's
just it.
imaginary, it's okay to say the imaginary things are real. Oh, yeah.
No,
Bev?
Bev,
They're the rules we're working with, I'm guessing.
you can't pick and choose what numbers are real and what numbers are not. Just
But
'cause
the
they're-
imaginary numbers...
all numbers are imaginary. Bev. They're
No,
all made
no,
up
no.
by
The
humans.
real numbers
Yes,
are real
they are.
numbers. The whole numbers are whole numbers. The imaginary numbers are imaginary.
This is hilarious.
That's
This
what
is
signifies
absolutely
these
hilarious.
numbers.
Bev,
Irrational ones are
You
irrational.
walk around so ignorant with horse blinders on that anything outside of your paradigm is just wrong and you dismiss it. It's pathetic.
It's hilarious.
It is,
So
isn't it?
Alpha,
It's fucking
imaginary numbers
brilliant.
are real. You're on that bus.
This is prime entertainment right here.
Yeah, we
This
know
is
you're crap.
this is
Brenda, but
gaslighting from the troll crowd.
Oh, it's true. Bev,
Yeah.
the set of imaginary numbers is larger than the set of reals.
Well, I'm no doubt you can make up anything you want. Obviously.
It's not made up. You can prove it. You can prove that the set of complex numbers is larger than the set of real numbers.
You
It's
said
a proof.
you said complex.
Complex and imaginary, same thing.
Oh, are they? So they've got
Yes.
two different meanings now for imaginary.
Just the old term versus a newer, better term.
Which is the newer, better term?
Complex.
All right. Is that because it doesn't say imaginary?
it doesn't sound stupid, right, Brenda? Completely idiotic, right, Brenda?
Bev, do negative numbers exist?
You said not. Alphag said not as well.
But you say numbers exist, right?
Well, yeah, you can definitely have two apples.
Can you have negative two apples?
No,
So negatives don't exist.
apparently not.
Apparently not. There. See how easy that was, Alpha?
Alpha, you sure you want to team up with Brenda? Think about it wisely before you answer.
I got him to say that negative numbers don't exist.
Yeah, they don't.
Yeah, he's a fucking idiot. I mean, holy shit.
Negative apples don't exist. Simple.
Of course they exist. Of course they exist.
No, they don't. If they're not there, Brenda, they're not there.
But you said
They
that
don't
numbers
exist.
But you said that numbers exist.
I
Negative
said
numbers
two
are
apples
numbers.
definitely exist. Yes.
But you said numbers exist.
Yeah,
And
two.
negative numbers
Two
are
apples
numbers.
definitely
Negative
exist.
means not. So
Okay.
not number don't exist.
Negative numbers are numbers.
No,
Paper.
sign
Saying
of
negative
sign,
apples exist, you imbecile.
It doesn't mean
Do
not.
negative apples exist, Brenda?
She ties you up on this bullshit.
Let her answer the question. Do negative apples exist, Brenda?
My bank account shows negative
I didn't
numbers.
ask you about your bank
It
account. Can you
does.
have a negative apple?
It hurts. It hurts, man. It hurts.
Sure, it hurts because you're
My
idiotic. You're saying
savings
crazy
account.
things.
My savings account shows negative numbers, and it's real. Oh,
Can
no,
your apple
no,
basket
you-
show
this-
negative apples? Two negative apples?
Is Alpha the male?
SE, do you think that in the real number system, negative numbers exist?
That's not what I asked. Can you have two negative apples? Yes or no?
Well, you could view it that you owe two apples that you do not
That's
have.
not
Fucking
what I
answer the
asked.
question,
That's
Alpha.
not what I asked. I have
That's
two apples in my
what it
hand.
is. In a real number system, a negative number is any number that is less than zero.
Well, I mean,
I'm talking
real
reality.
number system.
Reality.
Negative
So in
numbers are
reality,
used to represent magnitude of loss or deficiency. So there you go.
okay, let me get a sentence out without interruption.
Alpha, we're asking you a very specific question. Why
Yeah, and I'm
you?
asking you a very specific question. Can you have loss or deficiency?
In return, you're asking a question rather than fucking answering it.
this is just glorious.
Oh,
Yeah, you
we're
guys
laughing
are
at
just
you
fucking
with your negative
terrible.
apples.
Listen, ballers. Do you have negative apple in reality?
Can you owe somebody two apples?
Damn right. I
asking you
owe
a
the bank.
specific
I
question.
owe the bank, and
I'm
trust
asking
me,
you a
this
fucking
serious.
specific question. Brenda, shut up. I'm asking you a very specific question. Address my question.
Are you asking, can you hold negative apples?
Yes, I'm asking you, one of you, to answer and address simply my question. Go ahead.
I'm already in address.
Brenda, can you owe to bank negative money?
Hold on. Can you have a
you have
negative
to give
dressed,
them
Brenda?
negative money or positive money.
Yeah, let's not get him off the track. We
Yeah,
would just like
two negative
Alphag to
apples.
It's so much
answer,
fun, though.
please.
Right, so you can have both negative money and
Do
positive
you
money.
do you always answer when somebody asks Alphag? Is that you? Are you pressing the wrong button, Brenda?
What, you think
Shall
we're
we
the
mute
same?
you for a couple of minutes, or
Yeah.
can you let Alpha talk?
Who's the alpha male here?
The male, yeah. You were
Alphag, are you allowed to answer without Brenda talking for you? Brenda, will you give Alphag permission to answer this question,
Brenda's
or
not
is it one of
talking
those
for me,
ones
Bev.
that he can't answer?
Bev,
There you go.
Brenda's not talking for me.
Okay, good. Can you answer that question that SE's been asking you about 8 times so far?
Can you owe 2 apples? Yep, you can.
Okay.
Can you own 2
Was that
negative
what I
apples?
asked you? Was that what I asked
No,
you?
you have negative 2
No,
apples
no,
because
no. We're
yeah,
not.
because
We're
you
not
see when
asking
you
about
receive 2
ownership.
apples, they're gone to somebody else. They're not yours.
Again,
So you're
deflection.
in
Why are you
deficit.
deflecting? You are
Are you
deflecting.
asking if you can physically hold
You are fucking
negative
deflecting. You're
2
not
apples?
addressing my question. No, you're not addressing this question. Why are you being so fucking stupid? Answer his fucking simple question.
They can't. They're trolling.
They can't just say no to a
Wrong
simple
with you
question.
people.
Ask it
Fucking stupid. Look at that.
specifically.
Well, no, you're not addressing my question.
Oh,
It's
yeah.
quite fucking simple. No, listen.
You haven't asked if I
You
physically can
fucking
hold
sitting
negative
there.
apples.
You fucking sitting there, and you think that you fucking smart. You fucking complete dumb and stupid.
No, skeptical.
The
You
question
fucking
is
retard.
fucking simple. Can you? We're not again deflection. We're not asking you about the ownership. I own it. No. Do you have? Can you have negative fucking physical apples in reality?
No.
Ridiculous. See, yes or no. That's it. There's no fucking third or fourth option.
Wow, it's like pulling teeth. Well done.
They're afraid
Bro.
of being wrong.
Ridiculous, man. Why are you so scared? Why are you so scared, man?
Scared
Why
of
are you
what?
so fucking scared? You're fucking scared and
that
terrified.
You're afraid to ask
Scared
if
because
you can hold
you
physically hold something
you
that's
are
negative.
struggling. You are struggling
I'm not
internally.
struggling at
You
all.
have
You're struggling.
you are struggling internally. You have an inner struggle.
You
An
are
inner
struggling.
doubt. You have an inner doubt, an inner uncertainty. You live in uncertainty. That's your world, mate.
So a
Why am
real
I
number
here? I am
system
highly
has
certain.
negative numbers. A real number system has negative numbers.
You said
That
all
is factual.
First of all, we were talking about imaginary numbers, number one. And then we took it to this negative business. Let's keep that in mind. Imaginary numbers. Put in actual calculations.
Didn't Brenda say she can take 2 negative numbers and have it positive? She made up a new number.
She says you can bring anything into existence. Correct.
Anything.
Well, it has to be consistent.
Like, not like you then.
Like
No,
8 dimensions?
I'm consistent.
You're not. I don't know if you're a man or woman. I can't even tell. Now you said you were in a
I don't
dress.
care. I don't give a shit what you think about me.
Well, you were talking about consistency. You said
No,
you
I
had-
am consistent in that regard.
Are you a man or a woman?
How does somebody's gender matter at all?
Does not. I'm just like.
Yeah, I don't give.
So
Yeah,
then don't ask.
Are you a man or a woman, Alphag?
It doesn't fucking matter.
Well,
Jolly
when
good.
I was in the
what about?
military, I would say yes.
What
sir,
about
and
you,
yes,
Euclid?
ma'am.
What about you, Euclid? Are you a
I'm a
man?
male.
No,
I'm
you're
a male.
not. You're a child.
Wow. So you're going to ask somebody and then tell them that they're not.
Interesting.
Yeah.
Oh yeah. That was. Yeah, that's beyond the Paul. Yeah, absolutely. That is beyond the pall. How dare I?
Atheist.
Let's get back to mathematics that you don't understand. You don't understand anything other than 1, 2, 3, 4. That's about
You
the
don't
limit of your
understand. You want to
understanding.
understand everything. You want to understand. Shut the
Shut
fuck
up,
up. You
Brenda.
knew nothing.
You don't understand negative whole numbers. Holy
False
shit.
Idiot. You are
Negative whole
stupid. You
numbers. You
live
can't
inside your head. Like, you
beyond
live inside your head.
negative whole numbers are beyond are just boggling to you. Holy crap.
But Brenda, you don't understand the word mathematics because you are talking about arithmetics and you think that you are talking about mathematics.
Arithmetic is math, you fucking idiot.
No,
Holy
this-
shit.
This is
Holy shit.
arithmetics.
That's math.
No, this is arithmetics.
Arithmetic is not math?
Wow.
Not necessarily.
Yes. Holy fuck.
You can use it in mathematics, but
Jesus Christ.
adding numbers, this is not mathematics.
Yes,
You're
it is.
saying that arithmetic is not.
No, making up
It's
making
fucking
up
amazing.
numbers isn't really mathematics, is it?
Adding numbers or multiplying them, this is not mathematics. Mathematics,
Fucking A, what the hell is it, Jack?
Euclid is mathematics. It is proving relationship between quantities, or rather qualities.
Dude, just, you know.
For example, longer line, shorter line, relation between lines or figures or whatever. This is mathematics. This is not arithmetics. There are no calculations in geometry.
Arithmetic is mathematics. Just
No,
just
this is
going
not.
to be the
This is
ultimate
false
geometry.
equivalence.
Hold on.
False equivalence.
Paper. Geometry is a branch of
Oh, you're
mathematics.
going to get jumped on here
Sorry,
now.
mate.
They're just going to say it is and then sit back on their definition.
No,
because you have to justify everything you ever say. You have to prove it. They just sit back and say, well, it is.
He's wrong.
It's about to come here now. You're wrong with zero definition about it. And then he's going to sit back and say, there you go. Come on, Alpha, go on.
Okay, here we go.
Geometry uses mathematical proofs.
Paper, hold on a second.
But there is nothing to do with arithmetics there.
Branches of mathematics consist of algebra, geometry, calculus, trigonometry, topology, arithmetic.
Topology?
So you're wrong, Paper.
This is new definition.
Topology.
You
Why
don't know
did
what
you
that
just
is.
sneak that one in? What the fuck?
Topology is math? Bev, do you know what topology is?
It's
No,
the
I
land,
didn't
isn't
think
it?
so. You don't know what a fucking negative
It's
number
the
is.
shape of the land, isn't it? Topology.
No, topography, not.
Really, Bev?
Mhm. Okay. Let's go.
No, you just went.
Okay. Well, I guess that invalidates everything, doesn't it? You guys can just go now. Go on, off you go. You've done. You've done.
Paper is wrong. He's got it backwards.
No, I am not wrong. This is new definition. I don't care. I don't care about.
Paper. Show a citation then.
Brenda said you could just make up your own definitions. So you're wrong.
In mathematics.
You have to be consistent about it, and a lot of
You're
people
consistently wrong.
and a lot of people have been there before you. So it's pretty unlikely you're going to.
Oh, I see.
So it's pretty unlikely you're going to invent a new branch of mathematics.
Yeah, you can't, but Brenda
I'm
can.
already on it, Brenda. I'm doing it right now. So sorry.
Yeah, you can add to Imaginometry with us if you want.
Yep.
That's right, innit, Brenda? Because this with the new geometry mathematics, you don't even have to prove it, do you? Because we know now that there is no such thing as proof. Can't have proof in reality, so you could just make stuff up and then go, well, I can't prove it. Nobody can prove it. You can't prove me wrong.
Prove I'm wrong.
Yeah.
You can't prove I'm wrong.
There you go.
Right, Brenda? Can't prove I'm wrong. I told you there's 9 dimensions. Can't prove
There's
I'm
an
wrong.
infinite. There are infinite numbers of dimensions.
No, Brenda, there's 9. I'm sorry.
Oh god.
You can't prove I'm wrong.
Yeah, you'd have to show him. You'd have to show him the 10th one, Brenda, and that'll prove him wrong. Go on, off you go.
Show me.
Let's see the 10th dimension to prove him wrong that there's only 9. Show us the black swan of the dimensions. There are only 9 dimensions. Well, no, 3. There's only 3 dimensions.
Yep.
There you go. I'll say that, Brenda. In reality, there are only 3 dimensions. Prove me wrong. Nuh-uh. I'll just say every time you say something. I go, You say, what about I'll add time in? And I'll go, nuh-uh. Show me.
They are desperately losing.
Just make shit up.
Yeah, we know that they make shit up, right? And if it's a game of making shit up, well, I prefer to stick in reality. But just know, Brenda, we know that you're making shit up. And it's a nice little curtain to hide behind. Oh, but nobody can prove anything. Well, yeah, there are proofs.
In math, yeah, absolutely.
Mm-hmm.
Yes, and if you are talking about math, you can see Sarugaki's math. His last picture about verticals and horizontal. This is math.
No, that is not math.
Yes, it is.
No, it is not an
It
argument
is.
at all. It is not.
Mm-hmm.
It is not
It
an
is.
argument at all. It's just a bunch of shit thrown
It's
together.
mathematical statements, isn't it, strung together to give a mathematical proof. You
It
can
is
follow.
not
You
a
can
proof.
follow
Not
through
even-
with every step of it, couldn't you?
There's no steps at all. You
Yeah,
haven't
there
got
is.
the fucking clue
Vertical
to prove this.
is a straight line perpendicular to horizontal.
What's
That's
the
truth.
first premise?
Vertical is a straight line perpendicular to horizontal.
Okay, what's the second premise?
Vertical is a straight line established by a plumb bob.
Debunk that.
And then we get a connection. Vertical equals plumb line. And then we've got plumb is a straight line perpendicular to level.
This is
There's no
conclusion.
escape, Brenda.
Is that
There's
okay?
no
Are
escape
you all
from
right with
reality.
all of those, Brenda? Every one of them. Are you okay?
And this syllogism is based on axiom below. Things which are equal to the same thing are equal to one another. This is application of this axiom.
Mm-hmm.
Yeah,
Are you okay? Are you okay with that as well, Brenda? Just to make
No,
sure.
it's formally invalid.
Things which are equal to the same thing are equal to one another. Surely you've
no,
got
the
to go along with
conclusion-
that axiom. It's common notation, right?
Yeah, that's Leibniz's theory of the indiscernible.
It's axiom 1.
No, it's Leibniz's principle.
Well, it happens to be axiom 1 of Euclidean geometry.
No. So
yes,
plumb
it is. It
a
is.
straight
So
line.
do you
Did
agree
you
with
just say
it, Brenda?
no?
Yeah. Brenda, do you agree with it?
I'm not sure.
Oh. Okay then.
Why?
So
It's
your
the
conclusion-
diletheist in you, isn't it? It's one of those definitive statements that's like sort of
No,
self-evident, but obviously hard for the diletheist.
The principle of indiscernibles is not.
Where's
a
the other
diletheist.
truth in that? Things which are equal to the same
you-
thing are
could you
equal to one another.
Could you just fucking not interrupt me every time I fucking start
It's
talking?
all right, Brenda. Just calm down, please. It's okay.
No, how
You're
about
all
you
right.
just? How about you just
Brenda,
not over
but
talk me?
Brenda,
as I'm
no,
talking?
Brenda, you please calm down. We
So-
know what you get like when you go like this. Please.
So your
Brenda,
conclusion-
please don't Don't just calm yourself down for a bit. Take a breather. We'll
So
just
you're-
go over. We'll just go over
Yeah,
this
the
proof. I know
conclusion
it's
here
these geometric proofs
invalid.
that get a bit too much for you.
Your
Sit down.
conclusion
Take
is
a breath,
invalid,
Brenda.
Bev,
Breathe
your
in. Come on,
conclusion
Brenda.
here-
Breathe in with us.
Bev, your conclusion is
And
invalid.
then slow
Why?
breathe out.
Why?
The conclusion is
Why?
invalid, Bev.
Why? Why?
Wow.
Things which are
I'm
equal
really
to the
relaxed.
same thing are equal to one another.
No, that's not the conclusion.
But the
The
conclusion
conclusion
is
plumb is a straight line perpendicular to level.
yes. Is that
Yeah,
good?
That's invalid.
You don't like
Why?
that?
What
No,
is it
no,
then,
it's not
Brenda?
whether I like it or not. It's not valid
Why is it not
Why?
valid?
You have
because it doesn't follow from the premises.
Doesn't follow from which premises?
The
We
three
both-
premises above it.
It's not got there yet, right? It's another statement. Do you agree
you
with
said it
this
was the
statement?
conclusion.
No, it's not the conclusion, is it? It says things which are equal to the same thing are equal to one another. That's a common notation. Axiom 1, Euclidean geometry. From that statement and all of the ones that have come before it, you can use your little noggin to do a bit of reasoning to work out the next part, which you obviously going to struggle with. Because, I mean, it'll freak the shit out of you, Brenda. But, I mean, this is like Paper was saying, like Saragakis wrote it, this is a mathematical proof. This is how you form mathematical proofs.
This is not how you do proofs in logic.
It is.
No, it isn't. You
Yes,
don't
it
have
is.
the first clue. These are just definitions.
Mm-hmm.
No, because we have
Yes.
predication. No, you have you don't know anything about proof. Seemingly,
When you say
vertical. Sorry, vertical. This is something, and predication about this vertical
this is not predication.
Sorry,
These are
give me chance to
definitions.
It's a bit too much
end
for
my
Brenda to
statement.
hear.
Vertical. This is what we are predicating of, and predication is. This is straight line perpendicular to horizontal. This is predication.
So vertical P is a straight line perpendicular to horizontal is a definition.
No, this is not definition. Sorry.
Predication
This
of
is predication
vertical,
about
Brenda.
this is predication about vertical. Definition of vertical that is the plumb line for example.
Yeah.
This would be definition, not that is straight line perpendicular to horizontal, because this is relation between two lines, vertical line and horizontal. So we are predicating about vertical that this is has relation to horizontal. This is first premise, and predication that is perpendicular to horizontal. In second premise, we have same noun vertical. Is straight line established by a plumb bob. This is middle term in proof. You know what this is middle term. I hope. Yes, and this is established by a plumb bob. It means by experiment. So we have here a hypothesis if plumb bob does show vertical or not. It does. Therefore, it is proof. This is middle term.
Horizontal is undefined.
Of course, here there is no definition. We are not using definition in proof.
No,
we are using
these are
already defined terms in proof.
No, you're not. You're defining your terms here in these premises.
No,
right?
This is not. Yeah, definitions are not proof. This is Aristotle's statement.
Well, of course
this
they're
is
not
common.
proof. That's why this isn't a proof.
This is common mistake of people who think that they are doing logic and they are not. Proofs are not definitions. Sorry.
We also didn't define level.
Proofs are using already defined terms.
What is level?
Brenda, it says plumb is a straight line perpendicular to level, if you didn't notice.
Yeah, but what is level?
It's perpendicular to plumb, obviously. Do you not understand the geometric term perpendicular?
Well, that's not what it means at all.
What do you mean it's not what it means?
Yeah.
Perpendicular.
defined what level
It
is.
says plumb is a straight line perpendicular to level. That
Yeah,
tells
that
you what
defines-
level is.
No, it does not.
It
tells
does.
you
It
what-
tells you
it-
perfectly through geometry
No,
what
it-
level is.
It
It
tells
is
you what plumb is.
perpendicular.
It tells you what plumb is, not what level is.
Mm-hmm. Perpendicular, Brenda.
It
do
tells
do
you
you
what
know what
plumb is.
perpendicular is?
The fourth line tells you what plumb is. It doesn't tell you what level is.
It tells you that plumb's relationship to level is perpendicular. So yes, it does. It geometrically defines level with a
No, it doesn't.
relationship to plumb.
No, it only defines plumb. It does not define level.
How do you know what level is?
Well, in your argument, I don't know what level means.
It's perpendicular to plumb.
That's not what that says.
It is.
That's called affirming the consequent.
No, it's understanding the geometric
No.
words that are used, Brenda.
No, that's affirming the consequent. You don't get to affirm the consequent. The antecedent, plumb, implies level.
Is
That's the
plumb a
consequent.
straight line perpendicular to level or not, Brenda? Is that what
That's
you're
what the-
disagreeing with? You don't think plumb is a straight line perpendicular to level, do you not?
Oh, I think
You're
that's
disagreeing
fine.
with that.
That's fine. It just
Oh,
doesn't
so it's
tell
okay,
me.
it's
what
fine.
It doesn't tell me what level is though.
It's perpendicular to plumb. Obviously, there's a relationship
No.
between the two lines, which is perpendicularity.
But you can't affirm the consequent. You can't do that.
This is not
Yes, you
affirming the
can.
consequent. Stop
The
using
consequent
terms
is
you don't
level.
understand.
The consequent is level.
No, perpendicular, Brenda. Do you not understand the geometric understanding of the word perpendicular?
The antecedent.
Which line is perpendicular, Brenda?
The antecedent
Plumb
is
or
plumb.
level? Which of the two is perpendicular, please?
Antecedent is plumb, and the consequent is level.
Which one's perpendicular?
Plumb is.
Plumb's perpendicular.
Yeah, to level.
Perpendicular to what?
To level. The
Okay.
consequent.
So what's level?
Don't know. You haven't defined it.
It's not perpendicular to
don't
plumb, is
need.
it not?
You don't need
No,
here.
that would be affirming the consequent.
No, you've
Bev.
just said it
No.
is, Brenda.
No, I didn't.
Yes, you did.
You did.
No. I
Yes,
said what
you
plumb
did,
is. I said
Brenda.
what plumb.
Your
I said what-
dialetheism's showing, Brenda.
No, this isn't dialetheism.
It
This
is.
you
Oh, yes,
affirming
it
the
is.
consequent.
It sounds like
Plumb-
you're just being a negative ninny. You did just say it was perpendicular.
What is the antecedent in that sentence?
What is the antecedent? Perpendicular is the
No,
geometric
it's
relationship.
plumb.
Which line?
Plumb is the
Which
antecedent.
line is perpendicular, Brenda? Do you understand the geometric understanding of the word perpendicular?
Plumb is the antecedent.
Is that the line that's perpendicular?
Plumb is the antecedent. Level is the consequent. And you are not allowed to affirm the consequent.
This is relationship.
Why are you not allowed to do that?
Between two lines, which are, it doesn't make any sense. Vertical doesn't produce level. This would be affirming the consequent fallacy. But vertical is not producing.
A vertical is not in the sentence we're talking about.
Just said
Vertical is
before,
not-
vertical equals plumb. It's just the line before it. Vertical equals plumb. So when you say of plumb, you can say of vertical because
Sure.
things which are equal to the same thing are equal to each other. So
Right.
plumb
So by
is equal to
substitution-
vertical.
By the
Vertical is
so-
equal to plumb.
So shut your mouth. So by the substitution rule, I can go vertical is a straight line perpendicular to level.
Yeah,
That's using
Yeah.
the substitution rule.
absolutely.
I know this is yes, but that third line is not is not part of the proof. But
Yeah, it is. What are you
No, it
talking
is
about?
not. No,
It's
it
the
is
third
not.
line.
Third line is not part of the proof, because proof is one premise, second premise. It means middle term and conclusion.
You can have more than more than 3 premises. You can have 10 or 15 premises.
No, you cannot.
Yes, you can.
It
What are you
would be.
talking about? You don't know anything.
Go ask Baby. He said
Yes.
specifically that if you have more than 2 premises, the syllogism is invalid. Go ask him.
Yeah, but that's just what Betty was saying. It doesn't really count.
Yes, but I use him as hostile witness.
Yeah, but Brenda won't bother
Well,
doing that. It's just
vertical-
bringing somebody in who's not going to come in. It's like Jesse Kozlowski, the famous surveyor that's pissed off he won't come back. Betty's never going to come back and try and talk about
Yeah,
logic to us.
yeah.
He can't.
Because he has better things to do. So, according to you, paper, the vertical equals plumb is not part of the proof.
It's part of that. It's on that page. Do
It's
you
on that
disagree
page.
with
It's
it,
not
Brenda? Do
This
you
is not-
disagree with it?
Paper said it's not part of the proof.
Fucking well, it
is
is.
not
It's
part of
on
the
that
proof.
fucking thing.
Well,
It's
which
there.
is it? Is it part of the proof or
Brenda,
not?
yes,
it
it
is
is. It's on the fucking paper.
Well, paper said it's not part of the
Oh,
proof.
well, that must mean it's
What?
fucking invalid then, mustn't it,
Wait,
Brenda?
Wait.
Well, which is it? I just want you to make up your
I
mind.
explain. It is not part of syllogism. This is not part of syllogism because
part of
this
the
is not
proof?
premise.
Is it part of the proof?
Whole proof, you can say syllogism, but in fact,
Yeah.
middle term is proof. This
So then
middle term is second line. Vertical is
Right.
straight line established by a plumb bob.
Right. So
And this plumb bob is in a conclusion. It has to be, because you cannot, otherwise you cannot connect a
Where's the
middle term
conclusion?
with conclusion. Yes.
where's the conclusion?
Conclusion plumb bob is a straight line perpendicular to level. This is
That
conclusion.
told me that wasn't the conclusion. Why don't you two guys get together and figure out what?
Yeah,
you're talking about?
why are you talking about it, paper? Because if you notice, it says things which are equal to the same thing are equal to one another. Right after it. So he's made a load of statements, and then he says vertical is perpendicular to horizontal. And then vertical is perpendicular to level. Plumb
Yes.
is perpendicular to level. So then you use your processing power to say that things which are equal to one another are equal to the same thing. Therefore, level is horizontal. Mathematically
that doesn't
proven,
follow.
Brenda.
That
Yes,
doesn't
it
follow.
does. It follows
That's
every
invalid.
step of the way on every little bit of that
No,
proof.
it doesn't.
Yes, it does. Which
If
bit do you
vertical-
disagree with, Brenda?
So let's go through this. If vertical is horizontal,
No,
and
vertical is a straight line perpendicular to horizontal.
I was trying
Let's
to
start
shorten
at the
it up.
beginning.
I was trying to shorten it up. So vertical is perpendicular to horizontal.
Yes.
And vertical is
Is
perpendicular.
that okay?
to
Are you
level.
okay with that statement? Let's go
Yeah,
one by one statements.
Yeah, I'm okay with both of them.
Okay. Vertical equals plumb line.
That's just a definition, right?
Do you agree with it?
It doesn't say plumb line. It says vertical.
Vertical equals plumb line.
No. Well, the GIF that I have maximized says vertical equals vertical.
I don't know where you are. We're at the third line from the top. Vertical equals plumb line.
Well, all I did is scroll up to Saragachi or whatever the fuck his name is with the woman holding a card up,
Yes.
right?
Yes.
At 329.
Okay. I've got it on screen.
It says vertical equals vertical. It doesn't say anything
It says
about
vertical. Look at the very top of it, right? Read the words with me. Vertical is a straight line perpendicular to horizontal.
Yeah.
Do you agree with that statement?
That's fine. That's kind of
Okay.
a definition.
Next one. Vertical is a straight line established by a plumb bob.
Sure.
You agree with that too. And then we can do a little bit of processing power here to say that vertical equals plumb line. They're the same thing.
Yes, and then we have your conclusion. Plumb.
Well, no,
a
it's
straight
just there's
line.
another one here. Plumb is a straight line perpendicular to level. Do you agree with that?
I'm not sure I do.
Because it's another statement, right? Nobody's introduced level. We're just introducing level. Now we've understood that we know what plumb is. We've made an equality between plumb and vertical. Now we're bringing in a statement about plumb and relating that to level. Now, do you agree that plumb is a straight line that is perpendicular to level?
No, because you haven't
Okay,
defined
you don't
what
agree
level
with that is.
You haven't defined what level
It is. Just then, Brenda, in this statement, I'll read it out again.
That doesn't
Plumb
define what level
is a straight line perpendicular to level.
Right. That talks about plumb, not level.
It tells you perpendicular to level.
That's right. That tells you what plumb is.
Tells you the relationship of plumb to level geometrically.
Right. Correct. It doesn't tell you what level is.
Perpendicular. Now, do you know what perpendicular is?
It means at right angle.
Okay, so now you know the relationship between plumb and level. Do you agree with that?
No, because I don't know what level is.
Wow, this is struggling. You don't know, even though you've just said it is at right angles to.
Yeah.
Okay.
It doesn't say what level is.
It's perpendicular.
That's just simply the property that plumb has to level.
Yep.
It doesn't tell me what level is.
It does. It tells you perfectly what level is. If you had any inkling of geometric knowledge, you would definitely know what that means.
No, I'm just going by your logic here.
So this is this is Saragaki's statements.
Well,
your logic seems to not let you understand the relationship of perpendicular.
No, I understand the relationship.
Why is that?
I understand the relationship.
I think I sort of sorted this one out about ages ago. The perpendicularity. I mean, it's the straight lines that worry you, isn't it?
So I understand what perpendicular means.
Mm-hmm.
I understand what plumb is. Plumb is a straight line established by a plumb line.
Mm-hmm. So that's a straight line.
I don't know what level is because you haven't told me.
Perpendicular to plumb.
But that doesn't tell me what it is.
Does it not?
It don't need to. Doesn't need to.
Yeah, you do.
It does.
You do.
It definitely does tell you what it is. It's perpendicular.
So that just tells
everybody knows what perpendicular means, Brenda, apart from you.
Yes,
I'm agreeing with perpendicular. I just don't know what level is.
Yes, because the proof is about relationship. In first sentence, you have vertical has the relationship of perpendicularity to horizontal. In conclusion, you have plumb have a relationship of perpendicularity to level.
Yeah, that's not.
That means that vertical have the same relationship to horizontal as plumb to level.
Yeah, vertical.
And because plumb is the same as vertical, it is the same.
Yeah, but this is an
this relation is
paper.
Conclusion is that level and horizontal are the same because they have same relationship.
You can't make that conclusion. You can't. You can't do that.
This is valid proof. This is very valid proof. Yes.
It is formally invalid.
It is completely valid.
Prove it.
It's just read it.
Well, give me, do it. Do a formal proof.
You have proof. You can see it and read it. This is proof.
No, it's not. Simply putting something up doesn't make it true. What makes it true is if the conclusion follows from the premises. And the
Yes,
fourth
and
line.
it does
Well,
follow.
just a minute.
It does follow.
It does not. It does not follow. It does not follow that because vertical is equal to plumb, that therefore plumb is perpendicular to level. That's not a valid conclusion.
In middle term, you have the same noun vertical in premise first, and in middle term vertical.
Yeah, in your middle term, you have.
Yes, and a middle term is also in a conclusion. That validates. Słucham? Sorry.
Where's level?
Perpendicular to plumb. It says there.
No, that's the conclusion. You're not.
It's not the conclusion, Brenda.
Yes, it is.
No, it's not.
It's not justified by the premises.
No, the happy ending hasn't been come yet, Brenda. You've got to slow down.
Aragaki is begging the question in his so-called proof.
No, he is not.
Yes,
this is classic. This is classic.
Debbie said he is as well. A bunch of other people that know logic say he's begging the question.
Oh, come on. This is sad, guys. Like, which one of the statements do you not agree with?
Understand it, Bev. You don't even know
Which one of the statements do you not agree with?
He has pulled level out of thin air.
He said it's perpendicular to plumb. Do you not agree with it? Do you not agree with it? No, he's not begging the question. He's just making a load of statements and then relating them together by equals. This is pretty bad, guys.
It is fallacious. It is pathetic.
It's not fallacious at all. What you're doing right now is gaslighting.
No,
yeah, I don't know who you think you're trying to kid, but you're only fooling the Globers to me.
What is begging the question?
Because this is as close as you guys get to logic.
What is begging the question right now? Say
it. It doesn't matter. This is what it is.
I didn't say begging the question at all.
No, you're saying it's not begging the question. I'm saying it is. You don't even know what begging the question is.
This is Strawman. This is correct, formally correct. This is.
He has multiple fallacies in it. One being begging the question.
Tell us what it is.
Where is begging the question here?
So you don't know what begging the question is either.
Where is begging the question here?
This is a embarrassment.
Where is begging the question here? Point it out. No,
give us the begging the question fallacy. Please tell us, Alpha. Be quick. Be quick. Be quick.
But you're gonna tell us.
Saragaki doesn't know what it is. Paper doesn't know what it is.
I know.
He's on a 5-minute timeout. Whoa, slow down. He's on a 5-minute timeout because I think he's claiming fallacy, but then not stating the fallacy and trying to divert like he always does. It's pretty sad.
He told you the fallacy, you piece of shit.
Which is the fallacy?
He told you it's begging the question.
What is the begging the question fallacy that he's talking about?
He told you what it is. It's begging the question.
What is begging the question, Brenda?
When you state a fallacy, you have to explain it. And watch the language, Brenda, or you're going soon.
And citation.
Where is the begging the question fallacy?
He's gone. He's gone. Whatever.
Yeah, thank you very much.
Yeah, you knew it was coming, didn't you?
Okay, so can we just go over this now without the Globe gang, obfuscation gang to go over it, right? Statement 1. Vertical is a straight line perpendicular to horizontal. Like that perpendicular relationship, nobody said there was anything wrong with that statement. Vertical is a straight line perpendicular to horizontal. Okay, accepted, granted. Vertical is a straight line established by a plumb bob. Absolutely. That means vertical is a plumb line. So we go back to the beginning statement. which was vertical is a straight line perpendicular to horizontal. Now, we've just changed vertical to plumb through the relationship of similars. And then we're going to state now that plumb is a straight line perpendicular to level. So we're just making the relationship of plumb to level, like he did at the beginning, vertical to horizontal.
Yes, so we can exchange every time plumb with a vertical. So we have vertical in first premise as a connection in second premise. Third is not premise because this is just statement. This is tautology. This is not premise.
Yeah.
And the conclusion has this vertical in, so this is connection to level. So in first sentence we have vertical connected to horizontal, and in conclusion we have vertical, that is plumb, connected to level, and this is proof.
And that
All
is a truth statement
connection
as well.
works. Yes, true statement, but we have connection. This is validation of proof that we have connection between three sentences.
Obviously, everybody can obviously accept it. Now, the problem for anybody who's just listening in thinking, what the fuck's going on with Globe Gang? Well, the problem is what we've just done is we've linked vertical with plumb, and this statement by similars links horizontal to level. That's a problem for Globe Gang. Although the logical statement obviously stands true. Geometrically, it stands true. It's provable.
And experimentally checked.
Obviously, I don't know. It's a hard thing for a staunch globe defender to take this one. And I don't know, you might find it, you can do it in reality, but just don't mention a model. If the model comes into the conversation, people will turn like Brenda and Alfag. Literally. Like, I don't know what the problem is. It's sort of like the fifth axiom in Euclid. The ones they got rid of all of the other ones. Get rid of the other 10. Chuck them out the way. And then we'll say we've got a problem with the fifth one. But nobody knows what the problem is. It's the same as this proof with Saragaki's. It's not really Saragaki's. It's just Saragaki's put it together. Just link things together. That should be obvious to everyone. But the problem is, it's not. It's like a magic trick that's right in front of your face that you can't see until somebody points it out, and that's what they're upset with. Globe Gang are upset that somebody's made this connection.
And this is mathematical proof. So this is math, not arithmetics.
Yeah, there's a logical process that your brain can follow along every step. But that's the problem with Globe Gang, because they've had it for years. They've been telling everybody that Bev's stupid and level can't be horizontal because I don't know why. For some reason, they linked it to something that they shouldn't have. And then they started fighting against it. But I mean, it is and always will be a truth fact in reality. Level is horizontal. You'd be better at just changing your concept of what you think horizontal is. Mentally. To be able to let the model exist. It's the best way.
The things that they have to say, it's just a space-time honey. Thank you, Brenda. Thank you.
Yeah, because you have dodos floating in space-time honey in your mind.
Yeah, doing the backsplash. Swimming happily.
Yeah, so, I mean, this is one of those things that it's a very simple process to walk people through. And you'll find out who's model afflicted.
How about 8-dimensional spheres? Like, how do you come up with this stuff?
Literally just defined it that way.
Yeah.
Yeah, it's easy when you can literally just make stuff up. That was the rules. It's already been laid out many times by Brenda. They can literally define things into existence. And existence for them is in their mind. In their mind.
Yeah,
Definitely.
and then they normally got someone like Alpha to back them up, and then between them they've got their you know. That was pretty crazy listening to that, to be honest. I mean, I went out of the room for a bit.
How much denial do you want to have, and how much avoidance?
I think it was pretty clear for everyone to see.
Yeah.
I think the moment Brenda started saying that, didn't know what level is, even though it says perpendicular, that's the moment where Alpha is like, oh shit, Brenda's stuck in the corner. I have to come in and save him.
And they both got the, let's get out of here. Let's get ourselves kicked out of here. Turn the button up.
Yeah, it is interesting how many people will just claim, oh, this is fallacious, but they will never state any reason for why. They will not explain the fallacy that they've named, as in what it is, and they will not explain it in context of the proof they've been presented with either. They've got nothing.
Yes, I asked for where is begging the question here. I even didn't ask what it is. I asked where it is. Point out where it is. Cannot. So it means that Brenda slash Alpha didn't know what it is, seemingly. It was a nice try to reverse of burden of proof. That we have to explain what is begging the question when he brought this, not us. This is normal tactic for Globbers to reverse the burden of proof.
Yeah, well, it is Free for All Friday, so
yeah,
we have to put up with that.
Yes, but this is normal tactic. This burden of proof is on person who is bringing claim, not for us.
At the very least, explain your fallacy. That's what triggered Brenda. When you claim a fallacy, don't ask the other person to explain it. I mean, that's just ridiculous.
Yes, that's reversing of burden of proof.
Yeah, they think they can play these games.
Yeah,
are you guys serious?
Very long time they are playing the same games.
And this one is really bad, I think, because they have this misconstrued concept of what level is, that's why they have to claim fallacy here, because under no circumstance can they have this conclusion stand in their own mind, even though it's perfectly sound and valid proof that they are the same thing.
They're crazy, Saragaki. Listen to the statement. Level is curved.
Yeah, that's crazy. I agree. I
mean, it's like take head, bang on wall repeatedly. Eight-dimensional sphere.
Oh my god, I was just gonna say that. I was just gonna say 8 dimensions. I gotta take off, but yeah, Brenda's insane. They're all insane. 8 dimensions.
Before you go, Space Time Honey. Get it at your local store.
Space Time Honey, that's right. All right, guys, have a good one.
All right, see you later.
Later.
All orthogonal to each other.
Yeah,
I
I
mean,
was gonna
oh,
mention it.
come on.
That's the crux of that one for anyone listening, right?
Anybody
Orthogonal
draw that,
meaning
you
perpendicular.
you get past 3, and then you'll find yourself back at one of the other ones again. If you go perpendicular, there's only 3. You'd loop back on yourself. Which obviously Brenda's doing mentally. Wrapping herself up in knots. But that's what they've got. That's the globe. Yeah, this is a good one. This is nearly as good as Blue Marbles. Elevation. Well, Blue Marble Elevations. Have you seen them?
Yeah, I saw them earlier. They're great.
There you go. Doom. So here we have first one, the Blue Marble elevation profile of Lake Rakia, formerly known as Lake Pontchartrain. And you can see the shape we have here. He's labelled the straight line a tangent plane. And Jesse Kozlowski apparently was measuring the elevation above the tangent plane of the Rakia Causeway. But you can see the nice dome shape of it. Curvature. Who's a big hump. 90-foot hump as well, he says there at the beginning of that one. And to contrast that, we have the LIGO profile. And the LIGO elevation profile, which is obviously a straight horizontal line, is the blue one. He says the orange line is the straight line connecting the end of LIGO. I mean, how can you do that? How mentally, how could you possibly do this? The orange line is the straight line connecting the start and end of LIGO Northwest pad at Hanford. So they do have a pad, concrete pad, that's very, very, very straight. Very straight. Well, the tube on top of it is, but I mean, the concrete, you could say it's, within tolerances. And he's drawn the profile of it on this picture here, and it's the blue line. But then he has the idea of putting an orange line from the start of it to the end of it. On the horizontal line. Yeah?
Yeah, how has he gotten the blue line curved? Number one, calling it horizontal when it's a curve on his thing.
Yeah.
That's elevations on the side, is it?
That's the that's it that goes height. It says elevation
the
above
y-axis.
mean sea level. Yeah.
And
then
distance
X is
on the
distance
X.
in feet. Yeah. It's literally an elevation profile of the horizontal line. And then what he's done is just to show it's a horizontal line. He draws another straight line, because it's a horizontal line, obviously, LIGO, from one end to the other to show you the difference between a straight line and a horizontal line. Blue Marble science. Blue, he says, give up. You aren't smart enough to understand. Yeah, I'm just trying to go over it at the minute, Blue. We're just trying to comprehend it. We've got a horizontal line that's blue. This is your elevation profile, right, Blue? This is a horizontal line, the blue line, and then the orange line is a straight line drawn from one end to the other. And you can tell that the blue line's a horizontal line because the straight line drawn from one end of it. Yeah, he says the blue. And then, welcome to the globe. If that doesn't sell the globe for you, I don't know what would. How do you reckon Blue would do with the globesman?
Not very good, I'd say.
How many globes do you reckon you could sell with that?
With that,
yeah,
I'm gonna actually give it a go, Blue. This is interesting. I'm gonna bring this up to people.
Yeah. Welcome to the globe. It's even got it wrote on it. Blue marble science elevation profiles. We was thinking earlier if Blue could do any more for us. We were thinking of the Giza plateau, right? The base of the pyramid. Elevation profile of that. That'd be interesting, wouldn't it? 3D elevation profile.
Yeah.
Mm-hmm. What about the elevation profile of the Leeds to Liverpool Canal? I'd like to see that one of them, Blue. Which one would you go with? Would you go with the inverted? Would you go with a straight line? Or would you go with the curve, the other one? Not too sure. I don't know. I'm going to wait and see what Blue might come up with. Are you doing requests, Blue? I hope so.
I think you'd have to just do one of these elevation drawings at a time if you're going to sell a globe, because somebody might ask, why is the horizontal line on this one, a curve? And why is the horizontal line on the other one an actual horizontal line? What's going on, Blue?
The orange line is a straight line, and the blue line is a horizontal line.
I'm talking about the bridge, the elevation profile of the hump.
Bridge.
Yeah. He has a horizontal line there.
Yeah, he called that one a horizontal chord. You could call the chord a horizontal if you wanted to, but he has actually labelled it a tangent plane. So you could call the tangent plane horizontal if you wanted to.
Even though it cuts through the hump.
It's an internal tangent plane of the globe model, right? I mean, if you want to sell the globe to people, you've got to go the whole thing, right? Internal tangent planes, horizontals that you can contrast a horizontal to a straight line in an elevation profile.
Well, the new version has an unclamped button, so you can have two views of it: clamped and unclamped.
Yeah, I'm not too sure that this one's was a good one. I think originally when we did the double drop hump, I think Jesse Kozlowski got sold the hump by Walter Bislin. And then I think Jesse Kozlowski's then gone on to pass it on to Blue. And now Blue's stuck with the hump. But then he also managed to pick up LIGO as well. Can you imagine? It's just the same as Jesse Kozlowski and he's dropping the hump. Blue's fell into the same thing. Except Blue Marble got stuck with a straight line. Blue. There's this wasn't the Blue Marble Science with the copyright thing on Blue. And I've changed it. It's the Blue Marble elevation profiles. It's a good one. Can everybody ignore the internal tangent plane and the elevation above the tangent plane that Blue did? It's a mistake. If you didn't know. It's one of those mistakes that you left on there, though, just for people to find. But let's see this one. Is this a mistake, Blue? This horizontal blue line. It's that one, because that one was a good one. Welcome to the globe. Come on. I mean, like, if you want to know how to put your mind in a position to be able to accept the globe, this is the perfect thing for you. If you didn't know what is required of you when you accept the globe, this picture will tell you everything you need to know about it. Welcome to the globe. As I said, I just can't get it. I guess I'm never going to be able to truly understand the globe model.
Not what's it called? Like, not a very sought after recruit, you.
Well, I don't know. I mean, it's going to take a special globe salesman to do it, and this one, I'm still going to use this, Blue. I think this is one of the tools. This and the internal tangent plane drawing. I mean, I know it's got the tangent. You sort us a new picture out for the elevation profile of Lake Rakia, and I might see about it. I've got I'll tell you what. I'll put this up because
how about if they offered you a lifetime supply of space-time honey? Would you consider it then?
Oh, well, I do like me honey. Right, yeah, I'll listen to this.
What Jesse is trying to measure is the elevation above the tangent plane.
See? What Jesse is trying to measure is the elevation above the tangent plane. And the tangent plane, which tangent plane, you ask? It's got a picture of it here. Elevation above the tangent plane. That's what Jesse was trying to measure, apparently.
Yep, clearly says it. Elevation above the tangent plane.
And then have you clicked the thing down at the bottom, Jesse?
What Jesse is trying to measure is the elevation above the tangent plane.
And that's not me. I'm no good at making voices like Blue. That's real Blue saying that.
What Jesse is trying to measure is the elevation above the tangent plane.
Mm-hmm. Oh, Ruhif's gone. That's a shame. I was getting used to have those conversations with Ruhif in the mornings.
Did the council call him out?
It must have done. He might be upset with Saragaki's proof. He might have to see that.
I hope so.
He won't be able to now. He was telling us about refracted curvature, and he's got a debate with him. Perhaps that's what he's doing. He doesn't want any distractions. Perhaps he's swatting up for his debate soon with refractive curvature. I've got a video in the making. I'll try and get it out over this weekend sometime with Ruhif. Sad to see you go, Ruhif. You will be missed. Nah. He was playing poker. He told us he was shit at heads up.
I do agree. It was kind of nice to, early in the day, check Discord and see Ruhif in the chat, because you always know there's something funny to be heard if you join the chat at that point.
I've had so many conversations over these past few days that I've recorded, but I don't get a chance to put them out. so many conversations with so many globe contradictions, but I don't think that they realize it. They've got a model built on adductor reducto ad absurdums, literally.
Yep.
And they'll come and tell you that you don't understand their fucking ridiculousness, their absurdities. The model of absurdities.
It's strange, though. You tell them, no, I don't accept this because it's absurd. Here, let me show you why. And then they go, oh, that's only because you don't understand. But you've just showed them you understand perfectly how absurd it is. And that's the reason why you actually deny it.
Yeah. Yeah, I don't know. It's become apparent over the last few days that they ask you a question and you'll answer them, but they won't accept the answer because it's not the answer that they're waiting for. And I don't know how many of those conversations I can have anymore. It just gets old. I guess other people have to have them though. I think most people are getting fed up with it too. But it does go to show how bad the model afflicted people are at accepting a geometric proof. And that's, if you can't accept a geometric proof that's made as basic as possible, I don't know. Don't think you should be
once a
around a
week.
debate arena.
We can let them in once a week on Free for All Friday. They can show us their paralogisms and we can laugh.
Yeah, they've turned the dial up a bit just recently, though.
Yeah, they're triggered big time, yeah. Angry, very angry.
Yeah, I noticed a couple of them. It's a good job Brenda and Alfag left, because I think they did need to cool down a bit.
Well, everybody knows what Brenda does. She's a professional troll, and good job, Brenda. You did not disappoint.
Yeah. Still waiting for our special guest. In half an hour.
See, they don't like to be pressed on. They don't like to be authoritative in a sense, right? Fucking crazy, brutal spastic people.
Yeah, you try and get, like, once you start doing this and you go through these logical steps and you work something out, and then somebody like Brenda comes and Alfag, I mean, they were double teaming. Sometimes some people may be questioning themselves because of that behavior. And that can't be good. Because I know for a fact that there are Globe guys out there that are really struggling at the minute. I mean, Brenda was talking a load of shit, but Brenda's on the Globe side. What are they meant to do? Perhaps they don't understand this sort of stuff. I mean, it is pretty basic, but perhaps they don't understand it. And they see Brenda and Alfag doing that sort of stuff. What are they meant to think? Oh, well, I don't really understand it. And Brenda looks like, and Alfag looks like that they don't understand it. But that stuff seems to make sense. But I can't go with it because there must be some sort of fallacy there, which was their only argument, that it perhaps wasn't wrote to their liking. Well, that's not what we're doing. We're doing basic logic, the processing that goes on for you to realize something, to make that proof connection. That's all we're after. They can't even go along with that. If there was something wrong with the fallacy, they should have said, well, let's have a look at it. Let's go through these steps. Let's say this. Let's change this and put this here. And that's the way we should word it. And then we end up with the proof. But they can't do that. They're not allowed to.
They are upset because logic is not on their side, apparently. And they want logic to be on their side, but there isn't.
I've yet to hear any good globe logic. I mean, I am reminded of Effie Pilot or whatever his name was when I say that. But yeah, please bring some good globe logic our way. I wanna dissect it.
That's asking a lot.
I know. I'm sorry.
Yeah, we've got a few
Globe
people.
and logic.
In the chat. Eric says in the chat, you don't understand, quote, isn't good enough. This is possibly the most literal topic you could discuss. It's geometric. There is no debate. There is no middle. It is or it isn't. Well done, Eric. I like that. That's nicely said. Pop in any time, Eric. Come on. Well done. Thank you very much. Yeah, I mean, it's just basic logic. We're not talking about anything else other than the relationship of vertical and horizontal, level and plumb. Right, I've got to make a brew for the missus, so anybody want to talk for a bit? Or should I put a Buster track on for a short while?
I say Buster track, and I can science that here, so.
Oh, okay. Oh well, welcome.
Hello, hello. Yeah, I'm early, so if you want to start, just you let me know.
Okay. Well, I'm just making I'll make a quick brew. I'm gonna put a Buster song on. Anybody? What do you reckon? Anyone in requests?
We all know
You
you're
don't
insane.
understand. No, we'll go with
Yeah,
whoever
that one.
said it before me. Ladies first.
Well, what was that? Yours then, Paige?
We all know you're insane.
Have we got a new one? Insane
Good choice.
Sunset. Buster Live, Insane, with the Sunset film the other day.
Nice.
I'll be back shortly.
Wish I could work in some more licks. never measure words in the real world. All you show is your stupid carbon. You never back your claim. Your world is full of illusions, contradiction between fact and fiction. I know you never back your claims. It's like driving the wrong way down a one-way street. And they pour your pride right in front of your feet. Straight lines converge in the distance. Why do I get so much resistance? I know you never prove me wrong. All we get are physics deniers, pathologic compulsive lies. I know you never prove me wrong. It's like driving the wrong way down a one-way street. And they pour your path right in front of your feet. Paradoxes and confusion. Your mind is in delusion. We all know you're insane. We all know you're insane. You try to explain your stupid tangents. I can see why everybody's so frantic. I know you never back your claims. It's like driving the wrong way down a one-way street. And they pour your path right in front of your feet. Paradoxes and confusion. Your mind is in delusion. Oh, we all know you're insane. We all know you're insane. We all know you're insane.
And we are back. Welcome, everyone. Got a guest in today. I can science that. We're gonna have a go at sciencing the shit out of something. I don't know what though. Welcome. I can science that. Is a little bit early. We did schedule you in for 11 o'clock, but
Yeah, I'm 20 minutes early now, so.
yeah, nice and
If you guys
casual.
want to start? I'm good, or I can just sit quietly while you guys conduct business.
Well, I don't know. Did you hear of any of the earlier stuff that?
No, I just popped in.
Yeah, we did have Brenda in. when you came in today, what is it that you came in here for? So we can sort that out for everybody.
Right. Yeah. Why am I here today? You promised, Bev, you promised you were gonna do some kind of test. You had a plan for a test. You wanted to tell me about it. So I think I'm here to hear your idea of what you're going to test, and hopefully I can provide some kind of, other opinion. Like the Glober opinion of your ideas and
Okay.
how great they're going to work or what problems I might see with them.
Nice. Well, the test we've already done.
Oh, okay. Well, that's cool too.
But that was just a test, right? For us, first off, to do things, you need to test. So all of the things that we're talking about now have already been tested and done. So I just want to be able to walk people through the entire process, right? So see whether you can come along with us on the journey that we did for this, what we call realizing Euclid.
Realizing Euclid. Take me through it.
Okay. Now, the basic concept of what we are going to be doing is proposition 1 within book 11 of Euclidean geometry is the 3D solid geometry of reality. So all of the 2D stuff that goes before it, circles and all of that, we have to go along with the understanding that people already know that to be able to go to the test. But you can't assume that people already know the basic principles in order to establish a proof. Okay, so within this, the idea of it, we sort of tried to formulate the idea that you have to start at a base somewhere, which is what we call first principles. Reducing everything back to the most basic you can, and then building up from there every step of the way to make sure that what you are talking about is very clear. Right? Would you agree on that? In order to try and portray it to anybody, you have to make an assumption that people know nothing. You know nothing. You start at the base.
I would say that sounds like it could be extremely tedious.
Yeah, I would agree.
How about I propose a compromise, which would be we identify where we agree and go from there.
Okay, well, did I take you through the 12 last week?
The 12. I don't recall.
Okay, right. Well, let me get a...
I mean, couldn't we just say that, we agree that two parallel lines that are not, any two lines that are not collinear form a plane? I mean, can we just move on from there?
Don't think so.
Do we need to really take it back to 1 + 1 = 2?
Yeah, I think so.
It will be fast.
Yeah,
We'll
go through it really quickly.
All right. If that's what you want to do, go for it.
Sorry, I just want to cut it. No, it's not what we have to do. It's literally.
Is there a visual that goes with this? Or?
Yeah, I'm just sorting it out now.
Yep. Okay. No problem. No problem. I'm early, so you might not even be ready.
Okay. You guys. No, not video. Screen.
Quick.
And. Okay, for YouTube. Sorted. Let me get this off.
You can see on Discord too.
Okay. So you've got that in Discord. Can you see that? Yep. This is what we call the
Alright.
12 steps to t-shirt logic. They're just sort of really quick understanding steps to make sure we're on the same path, right? Because
Okay.
we have found, we call this advanced simplicity, right?
Alright.
There is a whole thing about cogdis.
I know what cognitive dissonance is.
Okay. So watch
A
out.
real phenomenon in human psychology.
Yeah. Okay. So here we go. Straight line. A right line is that which lies evenly between its extreme points, that without curvature in any direction, right? So the idea here is what can we start off with and what can we state? Now, in Euclidean geometry, he starts off with a point, but you can't prove a point in reality, can you? So the idea here is, in reality, you can state a straight line, because the straight line is just the shortest distance between 2 points. You don't actually have to have the line there, but the shortest distance between those 2 points is guaranteed to be the shortest distance between those 2 points, which would be a straight line.
Absolutely.
Okay.
Euclidean geometry, this is true.
Yeah, but this is in reality, right? This isn't just in
We'll keep
geometry.
things,
A straight
we'll
line.
keep the discussion
Okay.
to a level at which that is true.
Okay, right. Okay, then a plane. A plane a superficies plane has only length and breadth. Those two dimensions, length and breadth, make it two-dimensional concept.
Okay.
Yeah, plane.
Sure.
Perpendicular. When a straight line standing on another straight line makes the adjacent angles equal to one another, each of the angles is called a right angle, and the straight line which stands upon the other is called perpendicular to it. That's Euclidean
Brilliant.
geometry definition of perpendicular.
Uh-huh.
Yep. Definition 10, book 1.
Sounds good.
Okay. And perpendicular to a plane. A straight line is perpendicular or at right angles to a plane when it makes right angles with every straight line meeting it in that plane. That's book 11, proposition 6. Euclidean geometry again. Book 11.
Sounds right to me.
Right, so they're the geometric ones at the beginning. They're very simple. Now we go into vertical, right? At right angles to the horizon, perpendicular, upright. In mathematics, it's a plane, a position, or a straight line. Vertical.
Okay, there's a problem with this.
Is there?
You said the horizon, which implies that there is only one horizon.
At right angles to the horizon.
We haven't agreed on that, and our whole discussion is going to be about how the horizon varies from place to place or does not vary from place to place. So if you imagine there's only one horizon, which this statement seems to make, then we're going to run into a problem.
At right angles to... Well,
can we say the local horizon?
Well, the true horizon then, over water.
The current horizon? The observer's horizon?
Well, you could have a topographic horizon, right? Since you've said that.
Can we just change the word the to a?
A horizon, to a horizon. But I mean, if that horizon's a topographic horizon, would you agree to it then?
To a topographic horizon?
How about if we just get rid of horizon altogether? Okay, it's perpendicular, upright. In mathematics, it's a plane, a position, or a straight line.
A vertical position?
Yeah.
I'm not familiar with the concept of a vertical position.
You could position something vertically.
I would call that an orientation, perhaps, would be more clear.
Orientate, a position, orientation in mathematics and vertical is an orientation. You've added to it, but yeah, I'll take that.
Okay. All right, that's fine. Yeah, I mean, if you just change the word the horizon to a horizon, I think we'll be cool.
Okay. Horizontal plane. Parallel to or in the plane of the horizon at right angles to a vertical line. In mathematics, either measured or contained in a plane parallel to the plane of the horizon.
Exact same comment. I noticed you even have at right angles to a vertical line, as if we understand there are more than one vertical line, but we don't seem to understand that there's more than one horizon. You notice
the plane of parallel
of the
to or
wording
in
there.
the plane of the horizon.
Parallel to or in the plane of a horizon.
Okay, well,
would-
but
I
it does
would
say
agree
in
to that.
mathematics, it does say the horizon.
I mean, I don't know who you're quoting from exactly here.
If I
but
could get you, so
no,
I'll get you
I
some
wouldn't agree to it.
definitions later. You check it now if you want in
No,
mathematics.
I'm not going to agree that there is only one horizon.
It doesn't say that there's one horizon.
It says the plane of the horizon.
Yeah.
So, which horizon?
The
It doesn't
horizon.
say. Any horizon.
Yeah.
Okay.
The horizon.
Cool.
Yeah.
So a horizontal plane is parallel to or in the plane of any given horizon.
Yeah.
Yes, and it is at right angles to vertical lines as defined with that same vertical horizon. Yeah.
Okay. Horizontal and vertical. Horizontal and vertical geometrically are perpendicular. Horizontal being the plane and vertical being perpendicular to it. They both have a common factor being the horizon, which they are either parallel or perpendicular to.
Yes, I'll give you that.
Mhm.
Yes, that's good.
Reference frames, horizontal and vertical. In reality, horizontal and vertical are the reference frames we use as our baseline. Any inclined plane will be measured as an angle to one of these reference frames.
Okay, it's an incomplete reference frame so far, but yes.
Okay.
Yeah, we normally consider up to be up and horizontal to be horizontal. And
Vertical.
That's common.
Yeah, vertical's both up and down, isn't it? That's what vertical is.
Correct.
And horizontal is on the X and Y, right? Anyway, plumb bobs and perpendicles. A perpendicle is anything hanging down by a straight line. A plumb bob is a tool for establishing a vertical reference. This is used in reality daily by many people. A vertical line is a straight line.
Looks good to me.
Very good. Level. Level is a straight line on a horizontal plane. A level is a tool for establishing a horizontal plane of reference from which vertical distances can be measured. An instrument for determining a surface is evenly horizontal, from Latin libella or balance level.
That's good, although I feel I should point out that that is not the only definition of level. I mean, you've already got two of them on here, so be aware that sometimes level is used in a different way than this.
Which way? I thought I was being comprehensive with level.
No, I just want to make sure, because that is a very common point of confusion, where we start with level is a straight line, and then someone else says, no, it is not. Right?
Oh well, that's the point we'll be getting over. So
if we're going through, these things to make sure we're all on the same page.
Yeah.
I am on the same page with you. You are going to use the word level to mean a straight line on a horizontal plane.
Yep.
And I'll accept that definition going forward.
Okay. That's good. And it's all right. A relationship between reality and geometry becomes apparent with the right line relationship between the two frames of reference used in everyday life. Level and plumb are perpendicular. Vertical and horizontal are perpendicular. This is not a coincidence. Geometry is reality. Would you agree?
I would say that was worded really weirdly.
Why?
It seems like maybe, I don't know, the two frames of reference used in everyday life.
Yeah.
And what are those two frames of reference?
Vertical and horizontal.
Okay, so it seems to me you're using the term frame of reference very differently from how I do.
Okay. Okay. How would you? What would you term that then? How would you suggest?
Relationship between reality and geometry becomes apparent with the right line relationship between the horizontal and vertical used in everyday life. You don't need to try to use the word frames of reference because I'm
orientations.
Correctly. Sure, between the orientations of horizontal and vertical in everyday life. How about that?
Cool. About this one here, a water level tool. A water level is any device utilizing the surface of liquid water to establish a horizontal plane of reference. The water level is lower tech than the more modern levels, but it can be more accurate over long distances and works without a sight line, such as around corners.
Such as around. Oh, yes, I understand. Yeah, sure. Absolutely.
Okie dokie. Well, that seems like you agree with us on these points, right? So now the idea is what we can do is let me get this back on Discord. So in order for us to go through a process to get to where we want to go, we need to go through how to build a proof. Now, Saragaki, are you in here? We got your proof.
I am here, yeah.
Wow, it's like Sean Hawkins. Yeah, there you go. Look, Blue. Is this one of Blue Marble Science's videos? Look at that. He's got me on it again. What do you think of that? I can science that. Now. Sean Hawkins. Sorry. Yeah, I've finished that screen. Okay. I've finished that screen. I've gone back to the Discord. I'm saying all Sean Hawkins.
That's homeless Sean.
Yeah, homeless Sean. He's posting videos of Blue Marble Science. And Blue Marble Science seems to be obsessed with me. I think it's because, right, I was holding a measuring rod and they've never seen one of those before. And they're just so obsessed with it.
Yeah. I haven't seen that video yet.
No, neither have I. I don't tend to watch videos like that. Right, so... Saragaki, can you put your proof in here, just so we can go through, like a basic proof in order to show how we build a proof. There you go. Can you see that in the live chat? I can see.
In live chat.
Yeah.
Something in live chat's going down. Oh yeah, I've seen this image pop up.
Okay, right. So, statement says. Vertical is a straight line perpendicular to horizontal. We've just gone over that, right? Okay. In the 12, so that's established. Vertical is a straight line established by a plumb bob. We've also gone over that, right? It is truth. Vertical equals plumb bob, obviously, just follows from that statement. Plumb is a straight line perpendicular to level. Okay. Things which are equal to the same thing are equal to one another. Therefore, you can say level is perpendicular to horizontal. Vertical is perpendicular to horizontal. And vertical is perpendicular to level. So therefore, you can work out things which are equal to the same thing or equal to one another. You could say level is horizontal. It is a natural conclusion, seeing as vertical is perpendicular to both horizontal and level. Therefore, level and horizontal are the same thing.
Yes, given the definitions we just agreed to. Yes.
So that's the logical sort of step as a what do you say? A cognitive sort of process that goes on in your head, where you link these things together right? So that's what we would call a logical proof.
Syllogism.
It is a
Syllogism.
mathematical proof as well because we're using perpendicular and geometry, right? But it is a logical proof for you to work through.
I'm not sure you're using the tilde correctly, but that's okay. We understand each other. It's good.
Okay.
It's good.
Right. Jolly good. So, for please take no notice of Sean. Somebody want to time him out? Can't be having that, Sean. Come on. 10 minutes. Give him a 10-minute timeout. See.
I was just thinking the same thing.
Yeah. That's
Yeah,
very
just
childish.
Yeah, you don't need to. Converse with that guy. It's almost Sean. Enough said. You don't even need to argue with him.
Yeah. Okay. Now,
Yeah, I would love to have a nice civil conversation. That'd be cool, right?
yeah,
Let's do
yeah.
that.
Yeah, I don't want
Yeah.
Sean
Sean,
coming
if
in
you're
trying to
listening-
antagonize anybody or.
We could talk later, right? You
Yeah.
know?
Right. So I'm just trying to I'm trying to go through the process of all of this as quickly as I can. I don't want to rush it, but
Yep, this is good. This is
okay.
good. Keep going.
So in Euclidean geometry, let me see. We have the first proposition within book 1. Just clip this down. Should really have been a bit better prepared, but we have had a crazy day today with people coming in here saying weird things. So this is proposition 1 in book 11. That one part of a straight line cannot be in a plane and another part without it.
Sure.
Okay, so that's something that you can prove geometrically.
Mm-hmm.
Now, I would say, let me see whether I can do this. Let me jump in here. I've never tried this before, so. Oh. Oh.
Technical challenges.
I don't think I've got the rights to be in here. I can't post me picture. Oh. I can't show you my GeoGebra.
You can't. Can you not screen share or?
Not on my other account at the minute. Can somebody give my account the role to screen share, please? FTT. How do you get to the bit where you
Oh,
should...
your other computer. Yeah. See that? It's not a. Looks like it's not an admin.
I can't turn the fucking sound off either. Oh. Nobody. Okay. Let me just sort this out. Do you want to talk amongst yourselves or something for a minute, please? Somebody.
Sure. Are there no admin/moderators in here anymore?
Okay, Emma's done it for me, I think. I need to know how to...
Oh, how's that weather?
The weather out here is pretty nice, actually. Clear day, moderate, not too hot.
God, you're lucky we've had nothing but rain and ice for like a week. I'm frozen solid.
Frozen? Where are you?
Australia.
Oh, right. Yeah. So down there, you're all in winter. You know, we could actually use some rain here. It's looks like it's drought for us for a long time.
Are you in that area where they've got the really bad droughts going in America?
Yeah, Los Angeles area. So, you know, California, Western California.
Yeah, California. I saw that. Yeah, I saw a video yesterday showing it was like all that real dark red color, showing that it was really bad.
Yep. Yeah. People are always asking me, you know, why don't they start, you know, why don't they just build a desalination plant? You're right on the ocean, a desalination plant. Build a big desalination plant. We'll have plenty of water. Expensive. It takes a decade to build those things, and it's expensive. Eventually they will, but
Yeah, and I think they're more interested in tearing the country down, not building it up.
yes, I think you're very right. I think people are super excited about fighting these days, and not so excited about planning for the future.
Right. Can you hear that feedback coming through?
Yes.
Yeah, that's
Yeah,
horrible.
I can't. For some reason, I can't fucking stop it. Can't get to the bit in it on the screen to shut it up.
Is that because it's going through two screens?
Because the sound, I can't stop the sound. I can't deafen myself. Can you?
Yeah, because then
Can you mute that? Or deafen it or something?
Now there is no echo from you.
No, there isn't.
Somebody muted it. Is that what you've done? No, that's deafen.
I didn't mute
Yeah,
anything.
deafen it. I don't need to hear anything.
Let's see if I can.
There you go. Who?
Ah, there's a stream.
There you go.
I see, I think, a GeoGebra or something.
Yeah. Right. So, get rid of that. Do that.
What the fuck?
Full screen. Okay. Yeah, what are you doing? You going? No. All right. So, let's get the screens off here. So what we've got here is a blank screen. We're going to end up, we're going to put 2 points in. 1, 2. Right? 2 points. Straight line. What we're going to do is we are going to move to circle, and we're going to put a circle there from that. But because we've got 2 points, we can also do this. Right? So now we've got a circle with
Circles.
what we call a vesica Pisces. Geometrically, what we can do is we can put a segment line in from there to there. But because we've done this vesica Pisces, what we can do is we can also put that there.
Okay.
Bro, Euclidia is making so much more sense now that I'm looking at this.
Oh, wait a minute. Where's my screen? Why is it so high? Move. Yeah, that's why I got Euclidia, so I could do this. Ooh. Right, so that's the perpendicular. Now, in order for us to extend this and to show that the straight line, no part of the straight line can lie within a plane and no part without it, right? We develop that straight line that we've just done for A to B to the edges. But, I mean, how do we do that? And what we do is we get back to the circle tool and we use the C and D, the perpendicular, right? So we make that circle there and then we do it the other way around. Oh, and there.
What?
So what we've got, we can have another segment now from this. Oh, I missed that. Where's my back till? Oh. Segment again from what? Come on, you can do it. There you go.
All right.
So that's extending that straight line. So if we put a point in there, then along that line, you've got A, G, B, and then the other point at the other end keeps flashing. Yeah, can you see if I got... you can't see me cursor, can you?
No.
No. Okay, so you've got that. Can I can I get a screenshot of that and then we'll go back into Discord?
Like anybody take a screenshot of that?
Okay, so you're with us on that. That's the basic concepts of that. And we'll go into Discord for the next bit. I don't need this account in here anymore. And back to Discord. Live chat. Paste. Okay, so in Discord now, you've got that thing that we've just made.
Yeah, I see it.
Now, let me show you the idea. Red. So you've got this point and this point, this point, this point. Copy, and I'll give you a new one there. So you see that?
Yes.
Now
We've
that
highlighted
is
in red some points.
yeah. So those points there. Now, if you imagine that call it the radius of that circle there, because that is one circle. So you've got at the midpoint at B, and then obviously the two ends. So if we was to say we were to have a water level, and within that water level there is how would we say it's a straight line? Well, if all of the points of the water level lie along those points, we could guarantee geometrically that that's a straight line.
I'm sorry. Hold on now. You're imagining there's a water level kind of like you drew the red things?
Well, a water level is a tool for establishing a horizontal plane of reference.
Uh-huh.
So if we could establish a water level...
Points?
Pardon?
Where are the 2 points of your water level?
There would be 1, 2, 3, 4.
Okay, so it's a 4-tap, if you will, water
It would be a 4-pronged water level, right? So if we could establish that the water level was on all of those, we could establish that it was on that straight line. We would have, you know, geometrically established just there.
Okay. Yeah, I think I'm with you.
Okay, now let me...
You build a water level with 4 open ends, right? 4 upright pieces, and you place them at like A, G, B, and the endpoint.
Yeah.
And then you would be looking to see, are those points all collinear or not, right?
Yeah. So, can you see that one?
Uh-huh.
That's one that we've got another water level, right?
Sure, just going the other way, yeah.
So, all of those points, those 3 points in the center, would be shared straight line segments. Both of the shared radius would be a straight line.
Yes.
Okay, so this is the idea, the principle of the realizing Euclid. We link the no part of a straight line can lie within the plane and another part without it, which is directly replicated with this.
Great so far.
Okay, now what we did was in order to check with the people who obviously would disagree, right? Because I don't know whether you're aware, but there are some people that don't like the idea that a water level is a tool for establishing a horizontal plane of reference.
Okay. I would suggest that there are some people in this conversation that just really, really don't want to agree with each other.
I know. Yeah.
And I think that's really all you're slamming into. But yeah, a water level, you know, both ends of the water level, if properly built, both ends will be at equal potential. And we can use that to, you know, use it to level things.
Yeah.
That's what we do.
So you're not a proponent of the hump or the drop?
Each point on a water level is at a gravitational equipotential. And the debate here is, are gravitational equipotentials collinear or are they on a curve?
Well, we're just dealing with the water level and the geometric principles of this, right? I don't think that comes into this for me.
Well, I mean, I agree with you all through all the up to this stuff where we said that you used level to mean straight line, right? So some people are going to want to argue with you on that, and I'll just give it to you. Let's just say we're using level in that way. And then you said that a water level establishes this establishes this horizontal. And I agreed to that. That is a 2-point. That is a 2-point water level. If you add a 3rd point to it, then now we're at the point of test. This is the question where the people who I think oppose you are going to say 3 points of a water level do not lie in a straight line. And therefore, if we're using your definition of level that we just agreed to, this device can't do that anymore. Is that, are we in agreement on that?
Well, see, that's why we've got this geometric thing to go with it.
Well, but your geometry is based on geometry. It's not a water level, that's a geometry.
It's based on the circle and the straight line.
Yes, in your geometry, you've got a perfectly straight line with 5 collinear points. Right? 5 points that lie on the same line.
Mm-hmm.
And then you, I believe, if I understand correctly, I'm leaping forward a little bit because we haven't quite got to this. I believe I'm understanding that you're going to make or you have made a water level with, I believe, 4 water locations. Is that correct?
Yeah, I'm going to relate it to this directly.
Right. Yeah. And so what we should see is that if your model of how gravity works is correct, then
I've not
we
got
should see that
anything
the
to do with
water.
that. It's just this is like a water level is a tool for establishing a horizontal plane. Here's the geometric proof of the straight line. Now, I'm saying we're realizing Euclid by using the water level to show that it matches this geometrically.
Great. What I'm saying is once you go from mathematics into reality, like you've taken it into a physical thing, right? Water in a plastic tube, right? We're no longer in the abstract. Now we've realized it, right?
Yeah, that's realizing Euclid.
It's real. Yeah. And so we do not expect it to be idealized anymore. It's not idealized. It's real, and so there are, errors. And I think if we do this well, we can use this as a test to determine how water really does lie.
So we're like what we're doing is we're showing that the Euclidean proof of this sort of stuff with the straight line and the proposition 1, book 11, how that can be done in reality to check Euclid. And this is the idea that we've had of how we're going to do it.
Check Euclid?
No, we're using the Euclidean proofs to, I don't know whether you say to check the water level. You seem to be thinking that something, but we're just using the water level to realize the Euclidean proof. The first one, the first, I think, the first proof that you can actually do in Euclid, in realized, because it's in 3D geometry, right? Solid geometry. You can't actually realize any of the 2D geometry.
Okay. In that case, I would say that no, you have not realized anything. All right.
How's that?
Because you made a grand assumption into this so far.
What assumption? We're just working through the proof.
The assumption is that the 4 points of the water level will be collinear.
A horizontal plane.
No.
Yeah, that's what you said earlier.
No,
water level is a tool for establishing a horizontal plane.
Yes, that's correct. It is a tool for establishing a horizontal plane, and we agreed that there could be more than one.
There could be more than one what?
Horizontal plane.
Not within the water level that establishes a horizontal plane. It's a horizontal plane, the water level.
Any 2 points of your water level will create a local horizontal plane. If you add a 3rd point, then now you have 3 possible planes that we could say are the horizontal plane.
Okay, well, so here we go, right? A straight line cannot lie partly within the plane and partly without it. So We say it's already a
the
horizontal plane. The tool establishes a horizontal plane, but you seem to establish. You think it establishes multiple horizontal planes, but I mean, once you started off.
Each pair of points in your water level creates a horizontal plane. And then you added the assumption that every additional point on the water level is in that same plane. But that is not true.
Well, it's water level.
Does it make it so?
Yeah, it's a tool for establishing a horizontal plane.
This is where it's become circular.
Okay,
No,
well, if we do this test and all of the points do line up on the straight line, will you then be able to say, well, yes, a water level does establish a horizontal plane? Okay, well, that's what we're doing. We're realizing Euclid.
So I don't know why the stress on the realizing Euclid. I mean, maybe that's what you guys are into. What I would like to see is you do a sufficiently long series of points on a water level.
How long? When you say sufficiently long, have you looked into how sufficiently long that might be for you?
I haven't. No.
No. Have you ever seen the Ruhiff numbers or seen Slice-Barkane's bending water level experiment?
I saw Slice-Barkane attempt it, and I was very disappointed that he never followed through and finished it.
Okay. Have you ever seen the related numbers to that?
Well, yes, and he went through the numbers, and I checked them. And I was pretty convinced that his proposed, test should have worked. And so that's why I was so disappointed that he didn't finish it.
Well, he's doing it again, apparently.
That'd be cool.
Hopefully.
So, didn't you do something very similar?
Yeah, he's got an updated one. So I'm going to give you is we had. Yeah, have you heard of Ruhiff?
Yes, I know. Ruhiff.
Okay, so like last year, maybe a couple of years ago, we were talking, and we're obviously going through this, but I don't personally like using the fantasy calculator. But that's just me personally. I like to get other people to do it. So we got Ruhiff to give us what we term as the Ruhiff numbers.
Okay, yeah, Ruhiff is quite good with these numbers. I'd be inclined to say that that's a good person to go with.
I don't know where they are. There we go. There. So they've been checked by quite a few people.
Mm-hmm.
There you go.
These are millimeters. Okay, 100 meter, 16. So it's 16 sections, 100 meters apart?
Yeah. And they match up end to end. And these are the
that's over a kilometer.
Drop numbers. Yeah. Well, it's a mile, isn't it? 1,600 meters.
Okay.
That's Slice-Barkane's test. So they're the individual drop numbers from the starting point of each individual level as you go away. Now, like I said to everybody, which of those do you think you could measure? Ones that you could.
Well, I know that the weather is going to have a lot to do with it. The turbulence in the air can make it really hard to see, and you need some pretty good optics.
Not for a water level.
So,
remember, a water level doesn't need a sight line.
No, you need a sight line. You can't see.
Not a water level. That's why we're using a water level. It doesn't need a sight line.
I see. You're expecting to see the water at different heights away from what reference?
The water level. Can we just go this? Right, so it says there that the drop of each water level. So I said to everybody, I could definitely measure 3.1 mil. Right?
From what? What are you measuring away from? Distance from what to what?
A water level.
A water level from what to what?
A water level to a water level.
Okay, but you already said those are 100 meters apart.
These ones are the numbers for the drop from horizontal of the water level.
Great. How do you measure the drop from horizontal?
Well, you measure the drop. You establish a horizontal and you measure the drop.
So you got like a ruler, and you hold it up.
Yep.
One end of the ruler, you put it on the water line.
Mm-hmm.
Where do you put the other end of the ruler?
On the other water line.
But they're 100 meters apart.
No. These are ones for this one here is Slice Bar Canes. These are the numbers for Slice Bar Canes drop. The ones that Ruhif's calculated for Slice Bar Cane. Now, all we're doing is saying at 200 meters, there's a drop of 3.1 mil. Right? At 200 meters.
Okay.
Okay. Now, at 400 meters, 12.6.
Uh-huh.
Okay.
What I'm not clear on is how you're planning to measure the drop.
Okay. Well, we'll get to that because this is the sort of the geometric proof. We're working you through it. So in relation to those two circles that you had earlier that I showed, you have two water levels. One that starts at one side and goes to the center and past the center, obviously, past the Vesica Pisces, and then one that goes the other way. Now, if we say the radius of that is 200 meters of the water level,
okay,
that's 400 meters overall.
Okay.
And then if you've got two, you put them together, you have an overlapping section of 200 meters. But with this array, you've got three water levels. Right?
You've got three water levels?
Yeah, you've got, there's three levels of the water that can be overlapped in the center. So there would be a shared straight line segment in the center with three water levels.
A, G, and B?
Yeah.
And you said the radius was 400 meters?
200 for the radius, 400 for the overall. So the overall with Vesica Pisces and the overlap would be 600 meters.
The overlap is 600 meters.
Well, all of them together. There's two 400 meters ones, but they overlap 200 meters, which makes the overall distance for the straight line 600 meters.
Okay, so you got 5 points, one all the way on the one end, one 200 meters from that, and then another 100 meters, and then another 200 meters.
Yep. Two separate water levels, each with 4 risers.
Oh, okay. All right. Okay.
Right. So when we bring them both together, if all of the water levels in the center line up, that they are matching, then we can say that those two at the far end are also matching.
No, you can't say that. No, you can't.
Can't you?
It's a neat trick, but no.
It's not a trick.
No, that isn't right. If I mean, what are we trying to test for?
We're realizing Euclid. We're trying to show that at no part of that straight line, the horizontal plane that's established by the water level, can be within the plane and another part without it. That's what we're trying to show.
Oh, okay, and I would say if they were indeed a straight line, that'd be true.
Okay. Well, a water level is a tool for establishing a horizontal plane. Are you saying we've chose the wrong tool to be able to do this test with?
No, I think what you're doing is measuring it in a way to try to get it to seem like it's what you say.
It just to get the water levels matching
The
up.
water level can tell you this. Your multi-tap water level can give you the answer, but not in the way you're using it.
Really?
Yes, and I think you know that.
The water level establishes a horizontal plane of reference.
Any pair of water taps will create a straight line.
It's just a tube.
Any
Have you ever heard of the law of communicating vessels?
Let's agree on what we're talking about with the water level, okay? There's 2 points.
Have you heard of the law of communicating vessels?
There are, on a water level, there are 2 points that we consider at any given time, and any 2 points, as we said from Euclid, creates a straight line.
Yeah, but the test is to show that no part of the straight line can lie in there. So we have to make it into parts. That's where the law of communicating vessels comes in.
Okay, and
have you heard of that?
I wonder if you could. I wonder if you're willing to let me just say my thing,
okay,
and agree or disagree. Can you do that?
Go on then.
Any 2 points creates a straight line. Agreed?
Absolutely. Shortest distance between those 2 points.
Right. So therefore, any 2 points in a water level, the 2 points of the water surface, we'll call those a point, and then we can connect them with a straight line. Agreed?
Yeah.
Okay. If you add a 3rd point on that water level, 3 points are not guaranteed to be in a straight line.
I think that's what's being tested, though.
Yeah, the law of communicating vessels would state that they are.
In general, 3 points do not guarantee a straight line. Can we agree to that?
In general, no. Just 3 points.
Now here's what you've done. You've said that the water guarantees that they do create a straight line.
Yeah, a water level is a tool for establishing a horizontal plane. Yes.
And here is where we disagree. This is the point of disagreement.
So you don't think a water level is a tool for establishing a horizontal plane of reference?
I think you're deliberately playing a semantic game.
I'm just saying, it's stating the fact. A water level is a tool for establishing a horizontal plane of reference. This is just a test to show that we can realize Euclid.
No, what you've done is say that any 3 points in connected by water are collinear. That is what you have said. Do you disagree?
The law of communicating vessels would say that. But the test is, look, I'll say it
That
again.
is not correct.
One part of a straight line cannot be in a plane and another part without it. So what we're doing, I suppose, is for you, we're going to be checking that a water level is a tool for establishing a horizontal plane across all parts of it.
No, and I don't agree to that.
Okay. So when you say that 2 points establish a straight line, which 2 points would you be talking about if you're talking about a water level?
No, and I'm addressing something that Paige is saying here and something that you were saying. And I feel like this is extremely deliberate and disingenuous. But did I agree before that a water level is a tool that can establish a horizontal? Yes, a water level is a tool, and it can establish a horizontal. If it has 3 taps on it, 3 points of water, then how many straight lines can we connect? We can connect 3. A to B, A to C, and B to C. Those are 3 separate lines. Yes, this is asking, this is extremely disingenuous. We all know that this is true. Okay, no one is going to argue. No one will argue that you can make 3 separate lines. Okay? Right? A to B, B to C, A to C.
Except if, of course, those are collinear points, then it would be the same straight line.
They could be collinear lines.
They could be, yeah.
But they are not guaranteed to be.
That's what's gonna have to be tested, right, in reality.
That's
So
what
this is
should
experiment
be
for
the test, because that is the point where we have a disagreement. The disagreement is not on whether collinear lines are collinear. The disagreement is that water forces them to be collinear.
and it would
Okay.
be tested. It will
Water
be
does
tested.
not force 3 points to be collinear.
Okay, here, check this out. I've got a whiteboard here. I've done this a few times. We do have a water level here. I don't know whether you can see it or not. You can see this here.
I see something on your...
See that one? How's that?
Uh-huh.
You see a water level here?
Well, I see... Oh, yes, I do. Okay.
Okay, water level.
Great.
And there's a water level over here.
Yeah, I see the other end.
So that's a water level, right? Now, I can move that and put it here.
Okay.
Then it would be a horizontal, right? From here to here. If I put it over here, it's a straight line from here to here, right?
As I said, any 2 of those points will create a local horizontal.
So this point here and this point over here, right?
Yeah,
okay.
sure.
So if this one moves over here, then it'll establish a horizontal plane from here to here.
Yes, it will.
And then over here and over there and over there. If it's 100 meters long, then over there 100 meters, over there 100 meters, over that way 100 meters.
Any 2 points you can use to create a horizontal line.
That's why it's called a horizontal plane, because this one doesn't have to move, whereas this one can move and go anywhere. And it will establish a horizontal plane for as long as the tube is. Now, do you have a distance, a maximum distance?
Let me ask you, so that we're clear. Are you working under the understanding that as you moved it around, all of those horizontals we were making were all coplanar?
Yeah, because this one would be in the same place.
And I'm saying no, you have not established.
Right. Okay. So let's say
that is the point.
Let's say, are we going to fix this one here?
If you wish.
Okay. Now this one goes further away. What happens to it?
What happens to it?
Yeah.
If referenced from, it depends on what you're referencing it from. What happens
from this
to
one
it?
here? We're referencing it from this water level. The same water level
will be established. Yes.
And if I put a water level here, then it would be a straight line, a horizontal line from there to there. Sure. Then if I move the water level further away, would this one still be on this horizontal line?
No, it will be a new horizontal line.
Which one? Where would this go?
Why don't you move that one down?
Move this down.
Sure.
Right, so you've got a water level from here dropping down.
Correct.
Okay. Now, what happens if we leave this one here?
What do you mean?
If we just leave this water level here and then we move this one?
The same shape gets created no matter how you move them around.
So this one goes back up again. And then this one starts dropping.
Down. They don't move up and down.
No, I know they don't. That's why they say on a horizontal all the way along or equal.
There's really only one question before us. There's only one point that we actually disagree with. On the one hand, we imagine that the plane of the water level is a flat plane. Right? All the points everywhere, water finds its level.
Horizontal plane.
Right. A horizontal plane is everywhere a unique plane all across the earth. Right?
Horizontal.
And on the other hand, there is what science teaches us. The mainstream textbook says that is not correct. Right? You're aware that mainstream says that's not correct.
Horizontal. Water level, horizontal laser level, perpendicular to vertical.
Are you aware that science textbooks say that you're not correct about that?
Not correct about what?
That water creates a single plane.
Right, okay, then which end is dropping?
That's a strange way of asking the question.
Well, you said it was dropping. Look at this. Look at this line here you've got. It's dropping.
It's a circle.
From there.
It's a circle.
It's not a circle. It's a straight line, perpendicular.
But the science textbooks tell us that it's a circle.
Right, so are you going to go with the drop? Or are you going to go with the hump? Are you going to put this higher in the middle? Because these are definitely level at each end. And it's horizontal in between with an equal elevation, equal altitude, one neither higher nor lower than the other. And that higher nor lower is measured on the vertical. It's neither higher nor lower at this end, and this end's neither higher nor lower than this end. Both relative to this vertical.
Or lower than what? Higher
than
or
this
lower
one.
Than what?
This one. This
higher
end. This end of the water level.
Define higher.
Vertically, on this vertical difference here.
Are you talking about reference to a plane or reference to the surface of the earth?
Talking a reference to this end of the water level here, referencing this end of the water level here, saying it's neither higher nor lower here, and this end is neither higher nor lower here.
All right, let's if we can we back up to your 12 points?
Yeah.
And apply them here.
Yeah.
Okay, we started with one of the very early ones. You said that there was a vertical. You established a vertical with a plumb line. Could you, on your little whiteboard there, please establish for us a plumb line? Where is the vertical?
There. Or this one? You want this one? Plumb line?
No, the plumb line.
Or do you want this one here?
Beautiful. Just use the beautiful. You want to line them up so that they're in the same spot?
Line one up.
If you can move the laser over, that'd be cool. So then they like right in the same spot, and everyone's like, "Oh, that's neat." No, that's fine.
We've got this one here as well.
So we have.
Don't want to scare you, but look at that. Look at that.
I stressed this when we first started. The vertical you just established is the correct vertical at that location. Right? Do we agree to that? You've now got 3, let's say even 4, including the laser, 4 separate vertical lines.
Yep. All perpendicular to this fucking horizontal. From the water level from here to here, water level, this level, laser level for there as well. Right. 4 verticals, 2 horizontals. Check it out.
And what is it that you think is wrong about my perception of what we just said? What we see here is what I see.
What is your perception of this? What you see here?
Okay, we have
3 verticals, 2 horizontals.
3 plumb bobs and a laser.
Yeah, right. And a water level. Don't
we
forget
have
the water
4
level.
Vertical lines.
Don't forget the water level.
That doesn't create a vertical, but we can make a perpendicular to it.
It's a horizontal.
We can make
Like
it
this one
perpendicular
here,
to
the
it.
laser
Okay.
one with the horizontal. And we've got the water level with the horizontal.
Okay. So we've got 5 separate vertical lines. And
No, there's
they
only
are not
3.
parallel.
There's only 4 verticals. But there's
Okay,
two,
whatever you want to say. We've
2
got
horizontals, 4 verticals.
As you wish. And they are not parallel.
Which aren't parallel.
The vertical
swinging.
lines are not parallel to one another.
They're swinging, I know. I don't think they'll ever stop.
I think that within our ability to measure, they are perfectly parallel.
Which one do you reckon would be perpendicular though? Which one would be the closest to being perpendicular?
Perpendicular to what?
Just perpendicular. Horizontal and vertical are perpendicular, right? So there's 2 horizontals and then there's 4 verticals. So which one of the 4 verticals would be the closest to being perpendicular to the 2 horizontals?
The one most centered on the same shared center are most perpendicular to each other.
So it's the one that's in the center, but in the center of what? In the center of the water level?
If you pick, would you pick one and I'll answer for each one individually?
What, the vertical for the water level, let's say?
The vertical for the water level.
Yeah.
What is most vertical for that water level? I would say eyeballing it looks like the laser. But I don't really know where your laser's at. So I'm going to say the orange. We'll say the orange one.
Okay.
Is the best.
Nice.
They're all very good, though. They're all very, very good.
Okay. So if we could prove, right, that the water level, all of the points on it, like if we added another one in the middle there and another one, then if we could prove that they were all on this straight line.
That's the question. Yes, exactly. Exactly.
So if we could make 2 of that 4 array that we had and then meet them up and make 3 of them match up there on a straight line and they all match up.
Brilliant. I wonder if you would do something for me. Do you have a whiteboard marker?
A whiteboard marker?
Can you draw us a diagram?
Yeah? And what, of the water level test?
No, I'm gonna describe for you the diagram I'd like you to draw, and I'd like you to do the drawing for the audience if you could.
You want me to do a drawing? Wow. Is this a water level? Do you want me to do the test?
I want you to draw the diagram of the test, and I'm going to talk you through how I'd like you to draw it.
No, you'll get the drawing of the test as it's going to be. Okay?
Right.
Yeah.
But I'd like to have you draw the diagram to my specifications so that I can illustrate why this is circular logic.
Circular logic?
Oh.
Okay.
If you have a whiteboard marker, I'll
do.
take you through it.
Do it straight lines because I use these mainly.
I've
got a few of them. Yeah, I mean, say, do I need to draw anything? Because I've got these. Are these not good enough?
Okay. Can you make a diagram of your test with those?
Water level.
I don't see enough points.
Okay, you want four points, right?
Sure. 4 points, 2 pairs, 8 total points. Right? That's your test.
Purple. Right, so okay, so
Very good, very good. So that's one of the water levels. Uh-huh.
Okay, I'll just do these
Go
2
ahead, draw
points,
in.
right? So that these are equal, right? You would say that this one isn't going to drop, is it? From this one.
Well, let's do your model first. Could you draw in the water levels for the two middle ones too, so everyone's very, very clear?
Well,
that
I'm going to
what
draw the
your
other one in
hypothesis-
first. Are you all right with this, though? Are you all right with
Yeah, I'd
this
like you
one
to fill in
being
the
here
two-
and this one being here? Where are we starting is what I want to know for you.
Would you mind filling in the two middle ones, please?
Filling in the two middle ones.
Yeah, where's the water level according to your model?
It's not a model. This is a water level.
You don't wanna use the word model.
This is a water level that establishes a horizontal plane of reference.
According to your hypothesis of that's how water level works.
Okay. This is what we're
Okay.
testing for, right?
All
This
right,
is
now draw in the other one hanging off the other side, right?
Colour's that purple. So we will go like that.
All right, different colors. I love it. This is brilliant. It's going to work really well.
Okay, and I'll put that there, that there, that there, that there. Right.
Okay, beautiful. That is
Can you see
prediction
that?
number one.
Two.
Prediction number one. I would like to describe for you how to draw prediction number two, please.
Okay. So,
okay.
Do you want me to wipe these top bits and then I can just
No,
sort of put
let's
back
leave
in?
them. Let's leave them for reference so that we can compare and see the difference.
Okay. Right, do you want this laser back here for?
Sure. Why don't we leave the laser on? That's great.
Let me just put it out of the way because it's keeps fanning in my eyes.
Okay, now I'm gonna say let's draw the same diagram. Would it be okay with you if we, on the other diagram, we just overlay it, we just mark the water levels? Would that be okay?
I've got green.
Just mark the water levels of where the other prediction would have them.
Okay. All right. So we're going to start here, are we? With the orange one at this side.
I think most people find it most comfortable to have the highest point be in the middle.
Oh, the highest point of which one? The highest point of the orange one in the middle is here.
No, one more to the right. One more to the right. One
The
more
midpoint.
to my right. Yeah. Okay, would you draw a line, let's say halfway up the tube?
Halfway up the tube, here.
Halfway up the tube.
Like that.
Okay. That is a predicted water level. Okay.
Okay.
So let's.
So
understand
that's
that.
where we've filled the water level up to. Yeah.
Now go to. You pick a direction. Let's go to the right. How about?
With which water level though?
Both. We're going to go to the
Both.
right.
Okay.
And
Right.
we're going to fill in the predicted water level over there.
Okay.
Right where your
so
fingers at should be good.
for the purple one and the
purple
orange one, we would be going down. This is 100 meters, right?
So we go down a little bit.
It would be
Very small.
It would be
but yeah,
down.
we'll exaggerate.
0.78 according to the Ruhif numbers,
Okay.
right?
And mark it. And is that? It's hard to see that. Could you maybe fill it in or something?
Where? Oh, here, like this.
Like you did for the other one. You did like a fill in. Good.
Okay.
Okay.
Right now.
Let's go further to the right.
Yeah. This one.
And fill in the
This is
predicted
another
water
200 meters. So what have we got there on that? Has anyone got the 300 meter number from Ruhif?
We can eyeball
I think it was something like, I know, but I want to get it wrote down on the board.
Okay.
It's definitely going to be down though, right? You want it? You want it going?
7.1
7.1.
millimeters.
Right, so we've got it going down 7.1 millimeters. Right? From this is your starting reference, the midpoint.
Yeah, could you do the fill-in thing on that starting reference for us? Because it's coming through on the video. It's pretty low res for me. So maybe filling it in makes it bolder. That's great. Okay, let's go the other way.
Go the
and
other
fill in
way.
the
So
rest of
this
them.
is going to be down 0.78 again.
Mm-hmm.
Down. Fill that in there. And then this one over here, obviously, down 7.1 mil.
Yep.
Okay.
All right. Great. Thank you for the diagram. That was awesome. Now let's go to the middle three where they overlap.
Yeah.
And on your prediction, which is the top ones, the orange and the purple tubes or black tube or whatever, they line up in all three spots. In, I'm going to say the Ruhif prediction, which is the bottom ones, all three spots also line up.
Yeah, but what you've done, you've made a mistake because you've got your water levels. This water level here is 7.1 mil down. This is 7.8 mil down. And then this one's higher. But then it goes down here, 100 meters. So this individual water level doesn't have a hump in the middle. You've got it dropping over here. Like, because you put another water level here by the side of it, somehow this water level here is uneven.
What I've done is helped you to draw a diagram of the prediction according to mainstream science. That is the prediction.
No.
We
You
don't
should have
make any
started. You should have
assumptions
started
about
at one
water.
end of the water level.
We don't make any assumptions about water levels. We simply say this is the way it works.
Yeah, but look at this. Look at this end of this water level. You've got it down 7.1 mil, and at this end, you've got it down 0.78 of a mil. You've got this is the high spot. It's 100 meters in.
That's the high spot in our diagram. Yes, it's just a diagram though.
It's the high spot of the combined water level, but individually, it's not the high spot of each individual water level, is it?
Right. Sugar Cookie here is saying still doesn't understand communicating vessels.
Yeah. You don't,
and
do you?
that is the point. That is really the point. The difference between what I am saying and what you are saying is that you are saying water is level is a fundamental is a fundamental fact.
Horizontal.
And it is not a fundamental fact.
It is. It's a horizontal plane of reference.
That is in fact the question that we are here to debate is not why is it this way, is it this way, right?
I would disagree with the debate part because
Okay,
this
it's-
is
yeah,
going to
it's
be
not a debate.
tested, of course, in reality
This is what we
with
should
the
be
water
here to
level.
test. Thank you. You are so right.
Right, can I we'll just do one. This is why I wanted to do one at a time, right? So let's go
My
with
point,
one
before you erase
water
it,
level.
before you erase it, please.
No, it's gone. It's gone.
Too late. He erased it.
Yeah. So
My
here we go.
whole
Look,
point, you'll
watch
remember.
this. Watch this.
You'll
We've got
remember my
one
whole
water level
point
here.
was to test your assumptions.
I personally think you forgot the fact that they are two different water levels with two different midpoints.
There you go. I've done it a lot bigger for you this time. Now,
Okay.
where's the high spot?
There is no such thing.
There's no such thing. So when we fill it up with water, where would the water lie?
When we make a vertical,
No. When we fill this up with water, where would the water come? Here, here, and here. If we put water in here, where would it come to? There.
I can't answer that question without more information.
Okay. Well, let's fill the water up here.
Are we using the your model or my model?
It just in reality, like if we were to put
Okay.
water in
You're gonna
here,
force me to
what
take
would
reality.
happen?
I have to then use my model.
Okay, so what would
Right.
happen?
Okay, you filled in one dot, and I can fill in the rest.
Okay, where would the rest be? Because this is the horizontal, this line.
No, no.
Yeah, it is. This line here is a horizontal, this red line.
It is a horizontal.
Okay, so where would the water be on this tube? If this is 400 meters from here to here,
And
this is 200
and
meters.
that horizontal is horizontal where? Where is it the horizontal?
Well, it's just filled up to that bit
Horizontal
there.
is only good at one spot.
What do you mean? It's a horizontal. It's a line. It's a horizontal line.
A horizontal line is only horizontal in one place in the world. That is why I stressed
This
we must
horizontal
have
is
a
just going
horizontal,
across
not
here as a horizontal would. Where would the water lie? If this is a 400 meter water level and this is a horizontal, and where would the water lie at this end if we were to fill this end up?
If that laser line is the horizontal at the far right end.
Here.
If it is the horizontal at the far, well, point to one of the ends for me.
Here, we just filled it up here.
Yeah.
Here.
Okay, if it is horizontal there.
Yeah.
If that line is horizontal where you are pointing.
Yeah.
Would you point again?
Here.
It is horizontal there.
Yeah.
That line is now not horizontal anywhere else, only there.
It's a horizontal
the
line.
The water at the far end is lower.
The water over here is lower. Now it's 400 meters. Do you want to go with the Ruhif numbers of 400 meter drop?
Oh, yes, I would take Ruhif's numbers.
Okay,
yes.
that's 12.6 millimeters. Right? Okay, so I'll just put a mark here. And then we're going to say down 12.6 millimeters. Right?
Okay.
Okay.
Great.
Now, if I were to get a water level at that end and start up and do the other one, or would you go like this here is 200 meters, so that would be down 3.1 mil.
Okay.
And I can't remember what
numbers are.
Buster said. 300 meters, 7 down
7.1.
7.1 millimeters. Right now.
Okay.
Now we get another water level over here. Should be on the other side. Right. What about this end over here?
You've still got your laser doing the same thing.
But it's
You haven't
horizontal
moved
here.
it.
This is where we've filled it up to, the water level. We've filled it up here. That's the fill
And they're not
point
gonna
for
line
this
up.
time.
It won't line up now because you filled it to a different level. You filled it
Right,
up.
okay,
higher
so
on
where
the
would
side
where
than you
would
did on
this
the other
end
side.
be at then?
It would now have to be lower.
It wouldn't have to be lower.
Well, if the
From
world
there.
is in fact curved, right? This is the big question. If the world is curved,
Yeah?
then the orange one would have to be at a lower level.
Okay. Down the same as that 12.6. So we go down here 12.6. And then obviously this one here.
Those are
be
different. I think you're.
100 meters.
I'm not sure that's correct because you've got two different horizontal lines that you're imagining are the same horizontal line. So I think you just messed up the math there.
Down
But
3.
they'll be at different levels. We can agree to that.
What? Well, yeah, but what we've got here is it's 12.6
two
down from
horizontals.
here, and this one is 12.6 down from here, but this one is only 3.1 down from here. So there is a discrepancy that's measurable.
No, it isn't. You've filled your water levels to two different levels. First of all, and then you referenced two different horizontals as if they were the same horizontal, and you can't do that.
But you did have a drop from that end and a drop from that end. So that's where
Okay,
we
look.
can measure the difference. Because these, according to the way you just did it, then we would see a difference here. It would be the same here.
I think
would be the same here, but different here and different here.
Yeah, so I wonder if we could just have you tell me what you think my model is.
What your model is? I don't know.
Uh-huh.
I can tell you that we did this test and these were all the same. And we can do it again. I mean, they're easy
and I'm
to
telling
do.
you that the way you did it, it's going to make a diagram like the first diagram we drew.
Where they're all the
I showed you
same.
how to draw the diagram.
Yeah, they're all the same. And look, if you look at these points, when you did that
All the
circle
water
earlier,
levels
boom, this
were
is where the
exactly the same.
vertical Pisces is. Here. And that's where the perpendicular. This is
really
built
very
to
simple.
replicate that vesica Pisces and the shared straight line test with the circles. Let me do that one.
Thank you for the time. It's really very interesting. Here I am to tell you what is the globe prediction. I told you the globe prediction, and then you're not accepting it. So I don't know what to do.
I don't know
with
what
you.
I'm meant to be accepting. Where did you put the center point of these two water levels? Did you put the center point in like a third of the way, like a quarter of the way across?
Yes, we drew a diagram. We drew a diagram where we put the center point in this
Yeah,
bar
but
where
this
your
is the
finger
center point here, which is like 100 meters.
We can
And
put it
then
anywhere you want.
You've got this one
We can put
here,
it
haven't
anywhere
you?
you want.
And this is 100 meters. But it's a 400-meter water level, and you've put the center point like right in the middle of the two different water levels.
Yeah, so Paige says, we agree you've shown the globe. That in no way means real life is that. I agree with both halves of that statement, Paige. Thank you for that.
Okay, so see this test, right? When we say this test and all straight lines, now you could get another one of these and put it here and another one here. So you would have them all lined up, wouldn't you? Or would you keep having this discrepancies all the way along?
The globe predicts that those tubes will line up side to side on every single pair. That is the globe
yeah, but that's because they're a horizontal plane of reference.
No. On a globe, it happens the same.
It can't happen the same on the globe.
I had you draw it.
You can't. No, you've got a quadratic function within your numbers.
Will you draw it according to my specifications again?
You draw it according to your specifications.
I will specify for you what is the globe prediction.
You've got a drop. But you've got a drop from the center here, which means you've got a rise from one side and a rise from the other side.
Am I here to represent the globe point of view, or are you here representing the globe point of view?
I'm asking you. Are you what this is your center point here? Right?
You can put the center point anywhere you want. You decide where the center point is.
You can't put the center point anywhere you want. It's a horizontal plane of reference. You can't make one point of it higher.
This is where you're being circular.
It's where I'm being circular.
We have 2 points of view, and we wish to create a test that can discriminate between them.
Okay.
Agreed?
You wish to design a test.
Well, what are you doing then?
With the water level establishes a horizontal plane. With this end here, this of the water level, is neither higher nor lower than this end over here. And that means if I put it here in the middle, it's neither higher nor lower than that end.
Same's true on the globe, dude.
No, you've just put one higher. You start it off at a high point and then drop down from it.
No.
You don't? Okay then. So where do you want to put the? Where do you want to start with your water level? Can we start here? Is that what you want to do? Let's start here at one end.
Okay, then erase the other line. Erase the blue line now.
Which blue
because
line?
that blue line is inconsistent with the orange line. Okay.
Right,
just
so let's
come
start
over
here.
to the next one. We're just going to go from left to
200
right.
meters. Right. Well, let me draw this again. This is that's dirty. That isn't it?
To draw, are we going to draw the globe version? Are we going to draw the globe version?
Draw the water level.
So can you that's fine. All right. Well, see, here's the deal. I'm here. If anyone's interested,
I'll just do the middle.
I'm happy to help you through explaining what the globe version is.
I'll tell you what. I've got a better
and
one.
comparing it to what you all are saying.
Okay.
I just want to emphasize that there are 2 points of view being represented. And if either of us were to say, my way is the only way, then that's sort of just the end of the conversation, right?
I'm not saying it's the only way. We're going over this one. This might be a little bit easier to show.
So there's 2 ways of looking at it, and we should be able to design a test that can tell which way is correct. And the way you've designed this test cannot tell the difference.
Okay, so can you see this?
And I can't help but think that's on purpose.
Can you see this?
Yes, I see 3 points.
So this is a water level. Where do you want to start?
Let's start at the far left.
This one?
Uh-huh.
Okay. So we'll fill it up here.
Lovely.
Right. Now, what about the
In
middle?
The middle one, a little lower.
A little lower.
1 finger lower. A finger lower. A little lower than that. Can you make it a little lower? Just to emphasize. Because this is the difference we're trying to highlight.
Okay.
And the far right one?
Yeah.
Lower still. Let's go 3 fingers down.
Okay.
All right.
Now, what I would say is we can, just to check, red. So what we'll do is we'll just put another 2 water level thing here. And we'll put another one in here, because then we can check this other side.
Sure.
Right, we can reference that.
Could I ask one question?
I don't know who that was.
Buster.
Let's finish the diagram and then new questions. All right.
So now these are just individual water levels. So should we fill this one up here?
Yeah, let's fill it to the same level.
Fill it to this same level here to check that one.
Yeah.
Okay.
Okay. Now I will give you the globe prediction for the other end.
Yeah.
It will be at exactly the same height.
As this one?
Yes.
And this one?
Let's fill it to that same level. We get to choose the level, right?
Okay,
so
we fill it to this level here.
Uh-huh. And
And
over to
then-
the far right one.
Yeah.
Exactly the same level
It's
as
this
the
one
blue
here.
line. Uh-huh.
Okay.
That is the globe prediction right there.
Now, let's walk over. Bring Emilo over to this side over here. Now, what happens now that Emilo's walked over to this side?
Uh-huh.
What happens to the water level here?
Nothing. They stay right where they're at.
So this water level at this end is higher than this end here.
No.
That looks higher.
They're all at the same level.
But you...
This is where my
They're all at
questions
the
come in.
same gravitational equal potential.
If they're just on a slope going down.
No, they're not. That's a curve. I was trying to make you draw a circular curve.
Yeah, but this one here, from here to here, has this amount of curve. This one from here to here doesn't.
Okay.
This one from here
Here's
to
what we
here
do.
doesn't, does it?
If you want to actually, if you're serious about this,
I'll put
y'all,
this
and
on.
you really want to do this, here's how you fix it. Stand where you got your, I don't know, is it a Wookiee? What does that do? Your little monster?
MLO.
Okay. And I want you to shoot a straight line from the water level where you're standing to the middle section of water level, please.
We've got a water level here, look. So you can see this water level.
Oh, he doesn't want to do it.
What?
Would you please, Bev?
What am I
Just
doing?
do what I ask. Draw a straight line. If you have a ruler, that'd be great. Or maybe get out your strings. Your strings would be good.
Straight line from where?
Straight line from the level of the water, where
Yeah.
your finger is,
Yeah.
to the level of the water in the middle.
Okay, you want me to draw this line. Now, do you think this is horizontal?
I'm not answering that question. I would like you to draw the line.
Just the red line?
Just draw that.
Do you want me to go past there? Like that?
And now, draw the line from the far right one all the way to the far left one.
That one?
Uh-huh.
From there to here?
Yes.
Nearly
you can
the
draw it in
same
the
thing,
middle.
isn't it? Pretty much the same.
They shouldn't be if we've made a circle correctly. Those should be two different
You've not made a
lines.
circle. You've just drawn a slope. You're just asking me to draw a slope as well.
There you go. That's good. That's really good right there. Okay. We have two different lines. They're
Two
not.
differently sloped horizontals.
That's right. That's right.
But
That
that looks
is
like a slope. They're both going in the same
testable.
direction.
That is a testable prediction, though.
Is it? That the water slopes the same way?
This gap, that gap
Looks like
you
it's
just
going
drew,
up that way.
that little gap at the far end, do you see it?
Yeah.
You made it like a skinny winny triangle.
Here.
Do we agree that you made a skinny little triangle there?
Here.
There's two sides. You make an angle. You could connect the two end points and call it a triangle if you like.
Yeah.
That's a
Equipotential
testable
angle of adjustment, we called that. But you've got
That's a
like a
testable
slope
prediction.
going down this way. That would be water flowing, surely.
No.
No?
Could I ask my question now?
I would say so. Go on.
Oh, please. Would you be okay with Bev if he drew a third water level?
Sure.
Okay,
You
on
can
the
draw as
out.
many as you want.
Okay, wait. Okay, so on the outside, Bev, could you draw a third one?
We've already got one like this one here.
Yeah, tell them where you want it to go from. From what to what?
Well, this is towards you. I was just wondering if you'd be okay with if you had a third one.
Third one.
You can draw as many as you want.
Yeah.
What the prediction is, the globe prediction is that the level of water in all the water levels there forms a circle, not a straight line.
Would you let me finish?
Yeah, go
If
ahead.
you had a third one on the outside and you
All the way.
started from, all the way.
Like that. And
Yeah.
How far do you have to go before the water falls out?
Okay. So now if you were that person that went to the far right side, I could science that. And you were to fill the third, you're that person on the far right with that third water level, and you filled it up to the same level as the far right.
Please do.
Yeah.
Okay. Now what happens?
What do you think happens?
I'm asking you.
Well, I try to just describe in very simple terms, which is that anywhere on that water level, anywhere, it will create that same circle that everything else does.
No, but
So
you walked all the
gonna
way
be-
over to that right side, and you've got an empty water tube, and you're filling it up, and you're
Uh-huh.
going to stop where that far right water level is. What happens on the other side?
Okay, let's head over to the other side, Bev.
Yeah, going that way.
All the way over.
Okay.
Right?
Yeah.
All the way, all the way, all the way. And draw a line at exactly the same line as your blue and your orange.
This one's here. Let's just do that.
Yep. And that's what happens.
Hey, I
Wow.
think we do have a Poria Canal. Do you want to see that?
That's a. I
You
wrote
wanna
a
see
song
that?
about it. You're just a physics denier, but that's okay.
Right. So
I'm not, no, well, what I'm saying to you guys, I'm trying to say it over and over, is that we have two different hypotheses, if you will, two different thoughts
Slope
about
water.
how we think water works, right?
Yeah, you
You understand that we have two different thoughts about that?
Yes, but I think that even on your globe model, this third level has to be at equal elevation on the tubes. Water in the tubes would be at equal elevation even on the globe.
Yes.
But you ordered Bev to mark the one higher and one lower, and this is
No,
incorrect.
those were the same elevation.
No, this
Our
is
diagram was
incorrect
just
according to your model. According to your model, this is incorrect.
No. I get to describe my model, right? The diagram we had, right, just wasn't flat. It was a little bit tilted to one side. That's all.
No, these tubes to which
According-
Bev
okay.
drawn, it was on one straight line, horizontal, parallel to horizon. Whatever globe it is beneath that, this was straight line, and these tubes were on straight line.
Okay, Mr. Paper Organist, let me ask you this. Let's see if you understand what my model even is. In my model, are people in England and people in Australia oriented in the same direction?
Horizontally or vertically?
Like, do they share the same vertical? People in the UK and people in Australia, do they share the same vertical in my model?
Vertical.
Or do they have different verticals?
You don't have the same vertical in your model. The trick question, don't fall for it.
No, it's not a trick question.
Yeah, you don't have
Where
the
Wally
same
says,
vertical.
"Oh, I know."
All
The
of
answer
your
is no.
verticals are different, dude.
That's correct.
Well, there you go. So you can't have the same. What are you talking about?
In your model, you have no up and down. It is completely relative. So talking about vertical lines, it is pointless because
No, we can agree on what a vertical line is. It's defined by a plumb bob. We did that
yes,
already.
but on the globe, you have different. They are not parallel. So
That is correct.
This,
That is
yes, I
correct.
know. We all know that this is not point of discussion because you are segueing from the point, my
No,
point, that
no.
this third level, even on your model, should be equal. This level should be equal in tubes, even in your model. This is your incorrect statement that it should drop because you show that it should drop. It shouldn't on your model.
Now,
Even on your model, you are
you have
incorrect.
to be more careful with the words, unless you want to deliberately try to, twist things using words. We have to be careful about the words, right?
I
When
am
we
not
talk about the
twisting. We are-
drop,
Don't
we're
antagonize
referencing
it.
from the original horizontal. Drop from the original horizontal.
No, we are talking about third level tube, which has only two ends, nothing in the middle.
It's funny.
It would always equalize, even on Earth, on globe Earth.
That's correct. They always equalize to that same circle. That's why every point on that circle, whether you
doesn't-
intersect it with one tube or another, they're all the same potential level. They're all the same
Yes.
elevation.
Yes, so yes, but you said to Beth to draw two different levels in that tube.
Because we
That's
were
the point.
referencing from a fixed horizontal. Do you recall that there was a laser on the screen?
Okay, so the experiment is to be that will show because the experiment would be on straight line. Whatever
No,
you
you
yes.
need to establish a straight line. You cannot say that a water level is a straight line because that is the point that is actually being tested.
No. Well, we're just doing the Euclid, realizing Euclid for the straight line. But
Can I lay out for you a little logical proof, and then you guys shoot holes in it for me?
you want
How
to
about that?
shoot a logical proof?
Yeah,
Well,
here's the
have you-
logical proof.
Have you got it wrote down?
I'll just say it out to you because I don't have it pre-written.
Is it an if? If then?
Right. I hypothesize that all points on a water level are in a plane. I will test that by putting two water levels next to each other and seeing if those 2 points are the same. What do you think? Did I just prove that they are planar?
Did you have any geometric backing for that?
I just described yours.
No, you didn't. I just took you
yes,
through the
yes, I did.
geometric test with the straight line.
What you guys have done does not differentiate between globe and
No,
and
it's
flat.
not.
And
It's a
here's the beauty.
straight line test. It's
The
not
beauty
for
of it
anything
is-
to do with globe. Don't
do
get
the test.
triggered with your globe.
You
It's
could
just
do the
realizing
test, guys,
Euclid.
If you want it, it's right there. But instead, you've chosen to do it.
We've chosen to use a tool that establishes a horizontal plane in order to show that no part of that straight line lies within the plane and another part without it. That's specifically what we're doing.
At what point did you demonstrate that your 4-tap water level is, in fact, in a plane?
Because the points matched up.
But are you saying points can't match up on a curve?
Yeah.
There's no way that two curves could match up the same?
Yes.
Okay, great. So I think we now understand each other. You think there cannot be two curves that line up with each
I
other?
don't see how the water level can curve. It's not possible.
Right.
Okay.
And
Do you
that's
wanna-
why it's circular. Because you're right back to the original question. Does it curve or not? And you've come back to, I don't see
No,
how it
it's,
could.
it's a test to show that no
Well-
two parts of a straight line. But see this here.
Okay,
This-
you drew two triangles.
We call it a aporia canal, right? So
Okay.
this is a canal,
Uh-huh.
right? Okay, triangular canal.
straight canal.
Yeah.
Okay.
And what we're gonna do is we're gonna set a horizontal at A
Okay.
here,
Mm-hmm.
and then Superficies is gonna get in his little canoe, and he's gonna go from A to B. It's a mile. A mile. I know it's meant to be an equilateral. It's just perspective,
Okay.
the way you're looking at it,
Yeah, I'll go with it.
right? So 1 mile from A to B.
Awesome.
What's going to happen to Superficies from A, according to the horizontal that we've set at A?
Okay. Like if you were to somehow establish a horizontal back at point A and hold that same horizontal and compare your position against that horizontal plane,
Yeah.
you would find you are now below that horizontal plane.
Do you know any numbers?
Oh, it's about 8 inches.
18 inches per mile square. Yes.
Yeah, but it's only 1 mile. It's only 1 mile. Right. Okay. So
can do
what
that
we're
in
going to do
Minecraft.
here is now
Uh-huh.
going to fly upside down, or getting his boat laid down. We're going to set a horizontal at B.
Okay.
And we're going to go to C.
A new horizontal.
Yeah.
It's a different horizontal from the previous horizontal.
Yeah.
Okay.
Off he goes. What happens?
Same thing. Same thing. You're going to find you're now 8 inches below that horizontal.
Okay. New horizontal.
Uh-huh.
And we're going. What happens?
You're now 8 inches below C's horizontal. We have 3 horizontal planes that intersect each other at an angle.
Uh-huh. And we've gone from A to B, down 8 inches. B to C, down 8 inches. C to A, down 8 inches.
But we're not going down from the same point, right? You agreed that we were creating a new
Down.
horizontal plane each
So
time.
we've gone from A to A here and here.
Uh-huh.
And
And
we've
you're in the
gone
exact same
down
place that you started.
24 inches.
No, that is not correct.
What?
Because you made a new plane each time you hit a vertex.
Uh-huh. Yeah,
Those
horizontal.
planes are not parallel.
We made a horizontal and we measured a vertical change from that horizontal.
It's cute. It's cute. Can you draw it from the side view? So that we can see where your 8 inches went?
Okay, so from A to B, we'll go down 8 inches. From B to C, we'll go down 8 inches. And from C to A, we will go down 8 inches.
No, that's not
And then
correct.
this is here.
No, that's wrong.
That's wrong because
Yeah, it is wrong, yeah.
It is
Super
because
wrong.
it is this is what your model assumes.
No,
This
it is
this
not.
is called paradox.
No, this is not correct. Would you like me to show you how to draw the model correctly?
Go on then. Yeah.
All right, you got a protractor right there. Is that mobile? Can you move that thing around?
Yeah.
All right, lift it up and maybe move that fish guy out of the way, and we can draw right there where the fish guy is.
Fishies.
Yeah, keep him up there. He's awesome. Okay, so move the protractor right up in that big white space, and I'll show you how to do it. Oh, it's a sphere or a circle. It's a circle. Awesome.
There.
Sure, anywhere you like. That's good. Okay. Let's do it on the bottom right. Let's do it. Okay, so take a point.
Look at this.
Yeah.
Calm.
So take a point and put it on the outside of that curve for me. The outside of that circle.
Take a point.
And label it a point. You got a marker?
Yeah.
Yeah. Draw with your marker a point on the outside of your circle. Let's say, I was going to do it on the white space. Put it down like at negative 30 degrees, or 30 degrees below horizontal, maybe?
Horizontal.
Where your finger's at is good.
The horizontal where?
Just put a dot.
Which horizontal do you want me to measure 30 degrees?
Just put a
from?
dot on the circle, please. Anywhere. Just
yeah,
anywhere.
There.
Well, that's just in the middle of your triangle. So yeah, how about there? How about there?
How about there?
Okay, that's point B.
That's point B.
So that's point B right there. Okay, now come down. Let's say 45 degrees from there. 30 degrees, anything like that. Come on down. Well, that's way more. Yeah, okay, right where you're at. Put your finger. Put a dot.
Yeah.
Okay, that could be point C.
It's point C.
And let's say in between them, dead in between them, we'll put point A.
This is the canal.
On your circle, dead in between them, on point A. Okay, so we're going to start at point A and make a local horizontal for me, a tangent to the circle
at point A.
A local horizontal.
This isn't the first time I've said that today. A local horizontal. A horizontal at point A that is tangent to the circle.
You can't.
You can't do that?
You can't make a horizontal here. Do you like me little?
Oh yes, you can.
You can't be. It won't be tangent to the circle.
Okay, then don't call it a horizontal. Let's just make the tangent at point A.
See that would
Just
be.
make the tangent at point A, please.
That would be the horizontal there at A. A tangent at A.
A tangent at point A. Mm-hmm.
Okay.
You know, if you just connect to the 3, you can take the circle out.
Yeah, it's hard to get a tangent, you know.
Well, if you take the circle out, maybe it's easier. I don't know. It's up to you.
There you go.
Okay,
Is this to explain the Aporia Canal?
So the fish starts at point A. Fishman starts at point A.
Yeah.
And he swims to point B. Okay, would you draw a line from point B?
Swims where? Like what? I know he's super fishies, but he's not going to swim. He can fly. I mean, this is super fishies for a reason. Look, he's flying.
Yeah, he's superfish. Superfish. Yeah. He goes from point A to point B.
Yeah.
Along a curved surface.
What do you mean along? He can just go straight there. He's cool.
Okay. Why don't you draw for us a perpendicular to the circle, connected up to that
perpendicular to the circle. I don't. Well, like where? Well, what are you talking about?
Tangent to the circle.
Perpendicular to which tangent? You
A
want
radial
perpendicular to this tangent?
No. A radial line from the center of the circle through point B extended outward.
A radial line.
From the
an
center
extension of a radius. Does that even have a term? Is there a geometric term for the extension of a radius? Do they have a name for that?
I don't know.
Toothpick tangent. Toothpick tangent. Let's have a toothpick tangent coming out.
Okay, awesome. Toothpick tangent. I love it. Okay. The segment of that ray you just drew, where the 2 lines intersect.
Ray.
That's the 8 inches.
What?
Put your finger right on the beat.
That's 8 inches. The toothpick tangent is an 8 inch.
No, that little line segment represents that 8 inches of downward. That's the 8 inches.
But this is the canal. But you're saying that canal drops 8 inches there.
Well, there's a new local horizontal at point B. So you're at the same elevation. You're at the same height above the center.
Going from B to C
of the Earth. You're at the same height above the center of the Earth. You haven't gotten any further from the center of the Earth.
So you shouldn't use the word height or elevation. You should just use distance from the center of the circle.
Yeah, that's less confusing. Thank you. You're at the same distance from the center of the circle at point A and point B. So you haven't gone away from the center.
I can see a bit of a problem here, though, right? Because you had 8 inch, 8 inch, and 8 inch. But this one here, if you do what you want, a tangent from B, then that drop to C is going to be loads.
You'd have to do it in 3. You'd have to do it in 3 dimensions to get the numbers right. Yes.
3 dimensions. What of the water in the canal on the side?
To get the diagram to line up with the 8 inches on each corner.
You'd
you
need
have to show it
3D.
in 3 dimensions. Yeah. Yeah,
But,
the new
but that's a
plane of
Euclidean
V-
sphere then. And Brenda will be telling you off.
I don't. Is Brenda here?
No, but it's a
Okay.
bit of a no-no talking about Euclidean spheres when you're trying to tell everybody.
If you say so. If
Well,
you
I
say
mean,
so,
I'm there. I'm
just
just
here
warning
to,
you. I don't know how
I'm just here
experienced
to
you are
explain
in
why
all
your
of that.
diagram up with the zigzags on the upper left corner is incorrect.
But
The
that's what
correct
you did. You
diagram-
went A, B, C. I mean, this is just a canal. Like,
So-
as you would expect, a canal. Like, everybody knows a canal.
So
It's
put
just
your
triangle.
fish on A. Fishman is on A. Okay, and he swims to B. Okay, on the flat planar, I'm not going to call it flat, but on the planar idea where we think that water forms a plane, that's what he did. But
Yeah.
on the globe, presumption on the idea that it could be a globe,
Down 8 inches.
he went from this other A, the red A, the downward at the
here.
new one. He went from there to the B.
Yeah, down 8 inches.
No, we just drew it. He at no point did he get any further from the center of the circle. He was at the same distance the whole time.
But that would be like a curve.
That's correct.
Like Blue Marble elevation profile for Lake Pontchartrain.
Yeah. Yes.
So
Very much so.
it would be a hump on each of side of this circle. Is this
It
triangle?
would be a hump in the
Yes.
middle, yeah. It would have to go up to go down.
Well,
Because
well,
we
it
were
depends on
talking
how-
about a
no.
horizontal in
No.
relation to the horizontal.
When you say up, you have to be very careful.
No,
Right.
because it's a horizontal
Once
and
we have more than
vertical
one-
is up and down. Like it's measured. The height is measured on that vertical datum.
Which vertical datum?
The vertical datum that's established by this plumb line. So any movement in this direction is called up on the vertical datum, a higher elevation. Anything below is coming down in elevation. And they're measured with like a measuring rod, like that, as the distance from here to here. That's the change, is measured with a ruler through a sight level.
And anytime you make the presumption that there is only one vertical, that all
There's
horizontals,
multiple verticals. Come on.
verticals that are
You can have a
not
vertical
coplanar,
wherever you want. Anyone
verticals
can
that
do
are
that.
not coplanar,
What?
right? Once you make the assumption that all verticals are parallel, all verticals are parallel.
I'm not making an assumption that all verticals are parallel. We're just making
great.
the statement that a water level is a tool for establishing a horizontal plane of reference.
And it can establish that horizontal only at one particular spot.
No, it's a water level. Goes from one
you
side
move it-
to the other side, and all the way across is a horizontal plane.
And that establishes the horizontal plane only at that location.
At what location? From here
Wherever you
to
put
here.
Wherever you put one.
Yeah, so the location is anywhere from here to here. Because there is a horizontal plane established from here to here.
Right. So, as I was saying, anytime you make the assumption that every vertical is parallel.
I'm not making an assumption. I'm saying that the water level is a tool for establishing a horizontal plane of reference. And that's all we did. We used a water level
Well,
in a
and then you
test.
extrapolated from that to
We-
say that.
No, we used a water level in a test.
But you used it incorrectly.
I used a water level incorrectly, says you.
That is true. Yes.
How do you use a water level incorrectly?
By assuming that every point of the water surface lies in a plane.
A
You assumed
horizontal
that.
plane of reference, yes.
Yes.
Is
You-
that
you
what you
assumed that.
disagree with?
Yes.
You disagree with a water level being a tool for establishing a horizontal plane of reference.
I didn't say that. No.
Well, that's what I'm saying.
So then-
A water level is a tool for establishing a horizontal plane of reference. That's what I'm stating.
Okay. Let me take it a little further then. If a water level is a tool for establishing a horizontal plane of reference, then does it follow that a water level with 3 taps guarantees that there is one and only one horizontal plane?
Yeah, you wouldn't normally put 3 taps in. We only did it because we are doing
Does
a
it or does it
test to
not?
prove
Does that follow?
that
From the-
one
from the
part of the
statement-
plane can't lie within the plane and another part without it.
You have taken the statement, a water level is a tool to establish a horizontal reference.
Yes.
You took that statement and extrapolated that to say the water level always establishes a horizontal plane.
No, I did it to say
Right.
this is a good tool for us to be able to use to realize Euclid, to show. Do you want me to put it in again? Like, you do know that the first proposition of Euclid, book 11.
And I'm saying the way you've used it, no, it is not.
Okay. So what would
It's
you
absolutely
use
not.
as a tool for doing that test?
I would use the exact same tool and I would measure it differently.
You'd measure it differently.
That's correct.
How would you
I would be
measure
looking
the
to-
water level differently?
The very basics would be to compare the difference between the 2 competing hypotheses. Not to make a straw man of either one, but to clearly establish what is the
Just tell me what is the competing hypotheses then, because I say that a water level is a tool for establishing a horizontal plane of reference. What
I would
is the
like you-
competing one?
Okay, please be more specific. More specific than it is a tool for. I mean, right? My speedometer is a tool for measuring speed. But does that mean that that's the only thing it can be done? It can be used for? Does it mean it's perfect? No.
Oh yeah,
right?
you could fill it
It's
up
just a
with water
tool.
and you could use it as a straw.
Exactly.
But it's not. A water level is a tool for establishing a horizontal plane of reference when you're using it
From that,
as a level.
From that, does it follow that any water level, no matter how large it is, will all be at the same level?
Not be at the same level, no.
At the same
They will
plane,
all
horizontal plane.
establish horizontal planes of reference. I say
And they'll all be the same.
yes.
And they'll all be the same.
They won't
That
all
is
be
the-
the same. They'll all be different. But they will all be horizontal planes of reference. And
they all parallel to each other.
they will all be parallel. Yes.
Okay. That is what I don't agree with.
You don't agree with horizontals being parallel?
Correct.
Okay. And do you
I
have
thought that was
anything
pretty
to
clear.
back that statement?
Yes, I have lots. What I would propose
Brilliant.
that you do is to understand that that is the question that really needs to be looked at here, whether that is true or not.
Whether a water level is a tool for establishing a horizontal plane of reference, or whether horizontals and verticals are perpendicular, or
No.
whether horizontals are parallel.
That one.
Okay.
Are all horizontals parallel?
In mathematics and geometry, yes.
No.
What do you mean, no?
Even in mathematics and geometry, no.
Well, all horizontals have a zero slope in mathematics.
Your definition of horizontal, back from the beginning, I insisted that you remove the word "the" and change it to "a," because they are not all parallel.
Did I say parallel at the beginning? I didn't. So
We
I'm
want
guessing
that.
you
We covered
know
it.
about the logical proof about horizontals being parallel.
And I'm guessing that you know the problem with it is that mainstream, right? This is what they teach. I'm not even going to say I'm advocating for it. I'm just going to say this theory exists. The theory exists
What theory?
that they are not all horizontal. And I would
What
like
are
to
not?
do it.
Or what are you talking about? What's not all horizontal?
I'm sorry, did I say that? Horizontals are not all parallel. Horizontals are not all parallel. This
Not
theory
all
exists
parallel. Are some of them
to each
parallel?
other. Sure.
Which ones are parallel?
The ones that are at the same location are generally parallel, and the ones antipolar to those are parallel as well. There's this theory that exists, right? And I'm telling you, I'm not even telling you that this theory is correct. I'm saying the theory exists and you need to recognize it because it's the mainstream theory, right? To suggest a different theory from that would be something, significant. It would be a significant finding if that was not true.
And I've been thinking about what you've been saying, and I'm wondering if you realize this, right? That if you want to equate horizontal planes to tangent planes to a sphere and vertical to radial lines and the extensions of them, you will end up in situations where you have vertical parallel to horizontal, which is absurd, of course.
Okay, let's talk about that. Would you
Okay,
ever
wait,
have?
before we do that, wait, 1 second, please. I just had to join for 1 minute. I've been listening on YouTube all day. Bev, thank you. This has been gold. Gold. Thank
All
you.
right, you're not contributing to the conversation. Thank you. The question was, do you have horizontals that are parallel to verticals? Is that
No, it was not a question. It was a blatant statement.
Well, it's
That
an
if,
incorrect.
no, let me make it again, okay? If you equate horizontal planes to planes tangent to a sphere and vertical to the radius of a sphere and the extension of the radius, of course, then you will unequivocally end up in situations where vertical is parallel to horizontal, which is absurd.
No, you've made a mistake.
Not at all.
No, he hasn't.
Your mistake
No,
was
no,
once
you didn't
again.
make any mistakes
It's all right,
there
Rob.
on your
No,
model.
you did.
Okay, I'm sorry. I can go back on mute.
Please do. The mistake you've made is to equate all verticals and all horizontals. There are multiple, right? If you say, let's take it carefully now. We don't want to make any mistakes, right? Right? If I've made a mistake, I want to hear about it, and I think the same should be true for you. I said that I think you said, and I'm agreeing, that the tangent at the surface of a sphere creates a local horizontal. Can we agree to that?
No, that's not what I said.
Okay, well, that is what I'm saying. So if you're describing what I've said in some other way, please, what's the difference?
I can break down the statement again.
No.
I said if you equate a plane tangent to a sphere to a horizontal plane. That was the start of the statement.
To clarify that now, because we're not trying to, right? We're not trying to misconstrue each other's words, are we? We're trying to understand each other?
Yes.
Okay, so let's ask clarifying questions. So to clarify, I say that the tangent to the sphere creates a horizontal plane, and I will call that the local horizontal, which is local at the point of tangency.
Yeah, that's what I just said, that you have equated a tangent plane to a sphere to a horizontal plane.
Very good. Now, the vertical at that same point is a radial point away from the center of, or through the center of that same sphere at that same point.
Exactly what I've just said.
Okay, those are perpendicular.
Yes.
Okay. So what's the problem?
That if you go back to the center of your sphere and take another radius, aka another vertical in this equivocation, and make a right angle at the center up to the circumference and make another tangent plane, then that tangent plane will intersect the other tangent plane at a right angle, making horizontal perpendicular to horizontal and vertical parallel.
Horizontal number 1 is perpendicular to horizontal number 2. Yes. There are multiple horizontals
And
in this model
vertical one
Yeah, check out the live
is
chat.
parallel to horizontal 2.
That's correct. Yes.
That's absurd.
Yeah, I mean, if you say
because I can back it up. Because vertical is perpendicular to horizontal, not parallel to horizontal.
No, you've made a mistake. That's a logical fallacy that you just spouted right there. That is not correct. You have made a mistake.
What?
You're very
He's
interested
made a
in logic.
logical fallacy.
Yes, you're very interested in logic.
Which mistake? What is the exact
Okay.
mistake?
There are multiple horizontals and multiple
Yes,
verticals.
and yes.
Okay, so when you said horizontal is perpendicular to vertical, now that's an error. You
How?
must say no. You must say there is a horizontal that is perpendicular to a vertical.
Oh, he's been coached by Betty.
It sounds
because
like
if you drop the a, now look, if you drop the a, you're giving in English, you're giving the assumption that there is only one.
Can you see in the
I
live
just
chat?
I just agreed with you there, right? There are multiple, both horizontal planes and vertical
then
lines.
you should have no problem leaving the a's in your logical statement. A horizontal perpendicular. I'm sorry. What was it? A vertical parallel to a perpendicular. You say it.
Any horizontal plane will be perpendicular to any vertical line.
No.
Can you see
let
in
me
the
go
live
again
chat?
then.
Can you
changed it to any?
Can you just look
Any
in the
would be
live
my
chat
chat.
for us? It's a tweet that I got
Listen.
ages ago. And somebody said, one person's horizontal is another person's vertical. Now, does that
Yes.
explain it a little bit better?
Yes. And that is not absurd.
It is.
I mean, you're just assuming that you're right and the other person is wrong.
No,
There's
you're saying
there
that
to
a
say
horizontal
right.
is the same as a vertical.
I'm saying there is a horizontal that is parallel to a vertical. Yes.
And that is absurd.
Yeah.
No, it is not.
And by the way, you are accusing us of making, let's say, begging the question, but at the same time, you are justifying yourself to do the same because you are
No, I'm not.
also making assumption. We are making assumption, okay, but you are also making an assumption.
I believe, and I'll state it again, I'm not even here to advocate that this is the correct model. I'm telling you that there are two models, and if you want
There
to design
is
a test, you can tell the difference.
there is only one reality.
I agree.
Okay.
I agree.
So why
There is only one
are
reality.
you concerned about different models? Are you not sure?
What I'm concerned with.
Do you know what
is that
reality
people
is?
learn to design a test that can tell the difference between two different competing hypotheses.
We don't have that. Or do you think this might be able to aid you?
I think
in you knowing, helping you out. Because we're just doing it for realizing Euclid, right? I put it in the chat a bit earlier. It says one part of a straight line cannot be in a plane and another part without it.
If you just want to do your test I mean, enjoy yourself. But if you want your test to show something meaningful, you haven't
Like
done
it's a
it.
globe.
Like realizing Euclid to show
You
people
have not.
how we
I'll
can
take it to the globe.
actually achieve geometric proofs in reality. That's what we're hoping to achieve.
Oh, okay. That's an interesting goal.
Mm-hmm.
But what I'm telling you is that if these globe dudes are correct, you haven't done that. So
What, a
don't you
straight
think that's-
line? Do you not think we can tell what a straight line is in reality?
No, I don't. No, I
You don't think we can tell what a straight line is in reality? It's 2022.
Not through our eyeball method. Not just by looking at it and saying, "Oh yeah, it looks straight." No, that.
No, we're using water levels, tools that establish horizontal planes. Do you not think a water level is a tool for establishing a horizontal plane? It's pretty simple.
To him, it makes a curved plane tool.
It is pretty simple. The globe dudes, right? There's these globe dudes, and they say
globe dudes.
Yeah, these
make them
glober
sound
heads,
like
right?
heavies. Who are
Yeah,
they? Do
these
they have names or?
Well, hey, he's not lumping himself in with them, so we're making progress.
Yeah.
Thank
Well,
you.
yeah, we're definitely not flat earthers, right? And if you're not a glober, then it doesn't matter, right? All we're
Well, no,
doing
it
is
does
going
matter.
over a test for Euclid. Now, do you think that will work for a straight line to show a shared straight line segment?
I think. Well, I think the jury's totally out on that.
On the
If you are
geometric
correct-
proof?
If what you're telling me is correct, and that water level, your water level all lies within a plane,
Yeah.
then yeah, you've done a neat demonstration of your theory. But on the other hand,
It's not
there's
really a
these other guys-
theory, but go on.
There's these other guys who are telling me that the water level creates a great circle, not a straight line, not a plane, but a
You
sphere.
should get yourself a water level.
Do they
and
say
try
drop or hump?
Sometimes they say sometimes they say drop, sometimes they say hump, sure. I mean, it's a sphere.
Okay, but never straight.
Locally straight. Any 2 points is
You
straight.
can't have a
how long
circle
is
that's
local?
locally straight. There's no such thing as a
What are you
locally
talking about?
straight part on a circle, is there?
Yes, it's in engineering. Yes, because it's so close to straight.
In engineering,
that
you
it's
have straight
immeasurable.
parts
In
on
engineering-
circles.
So you must
Uh-huh.
hang on, Bev. He must have a citation for that if it's in engineering.
Yeah,
They must have
I'm
it
an
in
engineer. I'm
textbook
not
or
actually a mathematician. I'm an engineer. So
Okay.
um,
So where in your
when we say
engineering
something
background?
is straight, I'm sorry. When we say something is straight in engineering, we mean to within some tolerance. We don't mean mathematic perfection. That's not achievable.
But do you say that of circles?
Yes.
You
A
say
circle-
straight of circles.
A section of a circle.
A section
considered
on the
straight.
circumference of a circle.
Yes.
In engineering terms, you call
Yeah.
straight.
Could be considered straight if it is a small enough section of the circle that it is, immeasurable or irrelevant how different it is from being straight.
Hey, could we go back to the 1.26 centimeters of difference? I feel like that point was kind of lost because of the two ends, like far ends of the water level setup. They are both dropping down towards each other in your model. I feel like that point was kind of lost.
Okay. In this globe model, right?
Which globe model?
There is only one globe model.
Okay.
There may be more than one other model, but I'm only aware of one globe model.
Okay, so you
In
are
that model-
stuck then, right? You are forced into a model geometrically.
No, absolutely not. I'm here.
okay.
I'm not here to tell you what's correct. I'm here to tell you how you could test between two different models.
Well, we
to see which
did. We've
one
gone
better
over.
matches
We've
reality.
gone over how reality would deal with it, with horizontal and vertical and water levels, the tools that establish horizontal planes.
But then it seemed like it seemed like you didn't understand what that other model predicted, because your description of what it predicts.
I wasn't looking at any other models. I was just knowing what goes on in reality. That's all I've dealt with.
Okay.
That's all I've talked
are
about.
you simply not interested in what mainstream science tells you about this whole scenario?
Mainstream science tells us about a water level. Does science deal with a water level?
Sure.
Right.
Sure.
Nice.
Why not?
Does it say it establishes a horizontal plane of reference or not?
No.
It doesn't.
No.
What does it say about the water level then?
Science tells us that, if you're going to believe the science dudes and all this mainstream stuff, it says that water is going to find an equipotential level.
Mm-hmm.
And then so that would suggest that if you integrate all the forces acting on the water, you add up all the forces that are acting on the water, it will create deny physics. It will create a surface where everything has got the same level of force applied to it. So the main force in question would be the force of its own weight. Can we agree to that? The force acting on the water in the water level is its own weight. And of course,
so there's no weight at the surface.
The weight of the water pulls it down, and then there's water pressure.
No. The weight of stuff acts from on top of it. So at the top of the water surface, right? What's the weight of the water there?
Water has weight, does it not?
Well, what's the surface weight of water?
Surface weight. Surfaces don't have weight. Surfaces are areas, not volumes. I'm confused.
So there's no weight at the surface.
The surface itself does not
of the
have
water,
weight.
right? Yeah. So there's no weight of
volume
water.
Has weight.
Yeah.
Volume. You need volume to get weight.
You just need a vertical distance, don't you? For the pressure, equal pressure.
Okay, you want to talk pressure?
With the water, if that's what you're talking about, yeah?
I'm just trying to summarize for you what the science says, right? And the science
give us a definition, a science definition of level or horizontal.
The better science definition of level is that it's a curved surface that represents an equipotential gravitational field on the Earth.
Yeah. Well, I've got dictionary. And
level,
flat, plane, even, smooth means having a surface without bends, curves, or irregularities. Level applies to a horizontal surface that lies on a line parallel with the horizon. Amazing how they did that. They got that past you.
And is that from a science textbook?
No, a dictionary.
Oh, okay. See if you can find another definition of level that matches the one I'm describing.
Can't.
I've seen it before. It definitely.
Go on then. You get it out then. Let's have a look. Right. Let's see. I'll get you a few more if you want.
Level definition.
Come on here. There's one here that says it's a horizontal condition, especially equilibrium of a fluid marked by a horizontal surface of even altitude. Water seeks its own level. So water seeking its own level, what they call is a horizontal condition.
So when you don't like...
There's multiple definitions of words. So if you guys want to play the game where we cherry pick things...
No game. No game.
I could dig down and do some cherry picking for you if you want. I don't think
off you
it's
go.
helpful.
I've got another one here. Level, synonyms and antonyms. It says, for practical purposes, level and horizontal are identical.
Yes, I agree. For practical purposes, that's true.
Identical.
For practical purposes.
Yep.
You saw that part, right?
Yep. Practical is when you use it in reality, right?
You want a different one?
I'm sorry, there was two people talking.
Sorry, Bev.
If you guys just
I
want to
was all
do,
glitching out.
just want to do
I just wanted
citations.
to ask you, science. When you don't like the
Mhm.
definition, that's when you want a different one because it doesn't comport with what you believe.
No, no. No, I don't like to play the definition game.
Okay, but then can I
My
just
entire point is that
We're
words
not
have
playing a
multiple
definition
definitions.
game, though. We're just trying to agree to terms.
Okay.
can I ask real quick, just before we go on? It says for practical purposes, and you agreed, right?
Yes, for practical purposes.
Mm-hmm. And are you aware that there are things like bridges or tunnels, for example, that are 10, 20 miles long?
Yes.
So that's practical, right? Done practically in reality over 20 miles.
No, that's a specific condition.
Well, okay
For
then.
practical
Somebody else take
purposes,
over.
I would say for practical purposes, that is, in general terms, right? We're not talking about.
But like practically, like for
special
canals,
project.
is that practical? Like a water level, would you call that practical?
Oh, a water level a couple feet long, sure.
Well, what about
A
400
water level
meters
hundreds
long?
of meters long? No.
What about a
That's not
canal?
special
Would
place.
you call a practical use of liquid finding its own level being a canal with different locks at either end, right? In between the locks. Would that be a practical use for the term level in the water in a canal?
I'm going to say no.
Oh.
All right. Now, if you guys want, we can just play citation game.
Go on
and
then.
that can
Come
be a lot
on.
of fun for
Come
you.
on. Don't just say you want to play the game. Play the game. Come on. Join in. We've done loads of them.
Is
Look
that
at the
what you
chat.
want?
It's got
Or
loads.
did
Yes.
you- or would
Yes,
you prefer
please.
to-
Join in. Get
Okay.
your stuff. Water level. Science definitions, please.
All right. Let's look.
Perpendicular to plumb if you want.
Where's
I've
Wally? Do you have
got one here. Look at
Evening.
check this one. Evening. This one says level, a horizontal plane or line, surface without inequality, state of equality, standard line of direction, instrument for indicating a horizontal line or plane, section of a canal from one lock to another, even, horizontal, smooth, equal to something else in importance, leveled, leveling, to make even, free from inequalities, bring to the same level, point in taking aim.
Here we are.
So like that. Canal. Horizontal. What have you got?
Here we go from
Merriam-Webster. Yeah. Are you going to give
Yeah.
us B as well underneath it, or are you just going to clip it off? Oh,
Well,
there
we're
you
playing
go.
the citation game, right? So you only want to cherry pick the one that you want, right?
No, I'm just saying. Having
we
no
will
part.
pick apart.
Rob!
Sorry.
So there you go. I cherry picked for you.
Well, okay. Well, but did you see the other definition?
Yeah, there's lots of definitions.
No, in that very same dictionary.
Yes, there's several. It has a whole bunch.
Okay, so what you're doing is you're citing, if you look at this bit here now, you're citing 3 of 3, right? So you've gone past this one already, but we'll go over it again because I think we did miss it. Definition of level. 3, 1, 3. It says horizontal condition. Horizontal condition. I can science that. Please, we're just going to science the shit out of this now. Okay. Horizontal condition. Especially equilibrium of a fluid
Hey, you know, we've been at this
marked
over
by
2
a
hours.
horizontal surface of even altitude. Water seeks its own
I'm just gonna
level.
read the dictionary.
Yeah, but
I'm
I'm going to go to your one now, right? Because you've cited it. It says, having no parts higher than another, conforming to the curvature of the liquid parts of the Earth's surface. Now, let's go back to this one. Horizontal condition, especially equilibrium of a fluid marked by horizontal surface of even altitude. It says, water seeks its own level. So can you just remind me, what is the liquid parts of the Earth's surface? What is that liquid part of the Earth's surface?
The oceans?
Water?
A lake?
Yeah, water.
Water, right, okay. And it says here, just a bit earlier, that water seeks its own level, and that is a horizontal condition. So can you just remind me how much curvature there is in a horizontal condition?
In which model?
Just in any horizontal condition.
In reality.
How much curvature? Because that's how you've got a conforming to the liquid part, the curvature. How much curvature does it need to conform to?
It's a sphere, approximately a sphere of approximately 4,000 miles radius.
But it does say the water is at equilibrium of a fluid marked by a horizontal surface of even altitude.
And that horizontal surface is a sphere.
Horizontal is a straight line, isn't it?
Not according to this definition.
Sorry?
Sounds like a problem
Words
with the
have more than
definition.
one definition. I think we've covered that by now.
Of
Words have more than
horizontal.
one definition. All right. So
Can I ask while we're on this?
So you guys obviously we've covered everything there is to cover.
No, there's one thing, because you brought it up.
I'm pretty sure he just circularized the horizontal one.
Yeah, he did. But
At
can
least
I
in
just,
the mind.
before you go, Mister, I can science that. You said conforming to the curvature, blah, 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 blah. Yeah?
That's what it says.
That's what it says, yeah.
Yeah.
Do you know what a vacuous truth is?
What is a vacuous truth?
A statement. Yeah, shout out Buster. So let's take the sentence, conforming to the curvature of the liquid parts of the Earth's surface. What happens if the liquid parts of the Earth's surface is horizontal, aka zero curvature? Would this statement still hold true?
Interesting point of view. Sure.
Exactly, thank you. Vacuous truth.
Very good. Yeah, that's genius. I love that. Right. Okay, so what we just established through this nonsensical rant is that words have multiple definitions, and you don't go to the dictionary to find out what reality is.
No,
guys.
I think what we've just
Right?
established is that
Agreed.
you're willing to change horizontal into a circle because of your model. I think that's what we've
No.
established.
We just established words have more than one definition. So
Horizontal doesn't have more than one.
yes, it does.
It's a straight line. Plane.
We can agree to that. See,
Well, what's
If we
the
wanna
other definition then?
if we want to communicate, the idea is not to try to twist the other's words to prove that.
You said there's multiple
The idea
definitions. What's the
instead-
other one?
The one that's consistent with this.
What?
Parallel with the plane of the horizon, horizontal, is the curvature of the liquid parts of the Earth's surface.
No, you can't have a curve be parallel, sorry.
Conforming to the curvature of the liquid parts of the Earth's surface is what it says here.
Yeah, but the liquid
And if we
parts
want to
are a
include-
horizontal condition.
Right. And does it say that in the same definition, or are we now jumping to a different definition?
It's within the same dictionary.
Okay. I'm not here to play dictionary with you guys.
It's not. It's just basic
Let's
understanding.
summarize. Let's summarize. I want to go.
I think
okay?
you're wanting to cherry pick and even cherry pick your understanding of what it says.
Okay.
I think you broke him, Bev.
So here we are, y'all. Here we are. I'm going to say yes. I'm cherry picking this definition for you because I want to emphasize that using definitions to prove reality is stupid. Okay? Can we agree to that?
Yeah, nobody's tried to do that. But
Yeah, we use
definitions,
water level.
definitions have definitions that
Go
are
into-
long-standing
go into the dictionary.
definitions because they have a
Just
meaning,
semantic.
right?
Go into the dictionary is just a semantic argument and has nothing to do with reality.
Okay. Why don't you stick with the science then?
Yes, thank
Physics.
you.
Physics.
Thank you. I would like to stick with the science.
Physics.
In the
yeah.
science, we are taught that the Earth is presumably a globe. Okay?
But this is presumption. This is not science.
Presumably.
Science
Yeah,
is
presumably.
science means
Hey,
that
let's stop
this is
interrupting for a second. Let's stop interrupting, okay? We are taught that. And so you're all aware that this is something that is at least out there. On the other hand, I hear from you folks that perhaps it's not true. Maybe
what's not true?
Maybe water always lives within a plane, right? A water level creates a straight plane that is not curved. Okay, we have
a horizontal plane of reference.
Suggestions. We have two suggestions. And going to the dictionary is
don't.
not going to tell us which one is real.
But
we need to go out to reality in the real world and do a test that can tell the difference.
We have.
And
we did a straight line test.
The next thing you did was you described
shared straight line segment, we called it.
And I was here to help
you talking all over Bev science that? You don't want people talking over each other. Why did you do it?
He wants to learn about tests, but he's...
Yeah, fair enough. That's what I'm saying. So you just have to listen occasionally.
Am I going to finish the summary or not?
You're giving you a summary.
Yeah, I'm summarizing before I go so that we can wrap it up, right? Okay, so you did a test, and I'm here to tell you that you have overlooked something in the mainstream model. That according to your test, you're going to get the same results whether the water is all in a plane or if the water is conforming to a spherical shape. Either way.
How did you work that out? Sorry, I've only just got it, mate. I don't mean to cut you down there, but I've missed out something here.
Mouth closed, please. Either way, whether the water is all in one plane or if the water is in a spherical shape, which are the two main theories being constructed today, or it could be any other shape like a potato chip, then the water levels at any given point will all be at the same level at that point, no matter what.
Is that how you summarize water level?
He can't tell what it is. That's what he says. He doesn't know whether it's a straight line, a concave, or a convex thing. He hasn't got a clue.
Using your test that you designed, you can't tell the difference.
No, we did a straight line test. Really,
I was there, mate. I was there.
You assumed it was a straight line. You compared it with
no assumption. What are you on about?
You assumed it was a straight line.
Yeah.
And you found that they lined up.
Yeah.
Okay, this is
it checked out with the geometry, right? And the logic.
Yes.
It all lined up to say that it was indeed what it said it was. The water level is a tool for establishing a horizontal plane of reference. And when we did it to realize Euclid, we had a shared straight line segment, just as we expected. Now, more people can come with more water levels, and we can do it even longer.
The formal name for that is confirmation bias.
Realizing Euclid, we did it.
What you did was confirm that your assumptions are consistent with what you tested. Okay.
Can I just point out?
They are.
Yeah. You said earlier that on your model they would also be at equal elevation in all the vessels of the water level. Correct. Which would not be true. So I feel like you've completely misunderstood the actual test. Are you over talking me now after making a big deal out of it? I'm saying I feel like you've misunderstood the test by being very defensive when you went through it. And I think if you could put some ice in your stomach, as we say here, just stay cool for a bit and actually go through it properly. I think when you understand the test versus having your misconception of it, it will be way more clear to you what's actually going on. I personally do not think that you have understood the test.
Me too.
Okay. I think that you are very clearly misrepresenting the globe model that you wish to test against.
You do wish to test against it, right? Here's the crux, right? You want to check the difference, straight line versus curve, right?
Yes.
And I don't got across to how that is actually being done with this test, which is why I think
not.
you've misunderstood. No, that's you say it's not, but that's only because you have misunderstood the test.
Okay, hold on, please. Am I misunderstanding the test, or are you misunderstanding the globe model? Either way is a potential at this point. Can we agree to that?
Or
are you
are
going to
you
go soon?
misunderstanding reality?
I gotta go.
Okay, but just before you do go, right? Can you how do you think this went tonight? Do you think I could have done anything better in order to present this test?
I honestly, I gotta be honest with you guys. I think you're being disingenuous, because I am here to represent what the globe model says. You've heard Where's Wally represent what the globe model says. I see that he's on here. I know that you've seen other people who tell you what the globe model says. We all say the same thing. So here you are telling us that we're all wrong about what
No. We're telling you, right, that in reality, this is something that we have done, and we have links to Euclidean geometry with this stuff, and it supports Euclidean geometry, surprisingly enough.
Yeah, you got me, sugar cookie.
Right,
Yes,
that's it. So now, how do you think I can better present that to you without you getting upset and thinking that your model is under attack? It's not. Your model's safe. It's in your mind. You keep that.
Okay.
This is just a test that we can do in reality. Do you?
Here's how you do better.
Think it's
you want to know
possible?
how to do better? Let me answer. Here's how you do better. Next time, you present the test and you say, please make a prediction according to your hypothesis of what we should see. And let the guest tell you what you should see. And then don't try to claim that they are wrong.
What? We should ask you what you think we should see in the test.
Yes, according to the model that I came to represent for you, I should be able to tell you what the prediction for your experiment is.
Okay,
but you did, and you did it wrong.
he'll get that back.
That you're misrepresenting the globe model.
Okay, but
okay.
I'm not. I'm not representing the globe model at all. I'm just representing the Euclid test that we did in reality. Realizing Euclid. That's what I'm showing you. That's all I wanted to show you today. Well, I wanted to run you through the geometric proof.
Okay. You either misrepresented the globe model or you neglected it. One or the other.
Yeah, I don't think of your model.
Okay, so you just
we try to neglect all models.
Yeah, this is a water level test. It happens above the surface. It doesn't matter any model. It exists above at an even altitude, as it says in the.
So that's where you've I've come to tell you, and I mean, you don't want to hear it, but according to the mainstream science, your test does not do what you said it does.
Again, sorry. Have you got has anyone else done any testing with the water level that you know
of? The Slice Barcane one the way he described it. You guys just go watch the Slice Barcane one. The way he described it would work.
What, you mean the leaky test? The leaking water level test?
Why don't you guys do that properly? Okay, why don't you go and do that properly?
It is really too bad that you've misunderstood the test so that you don't actually see the point of the test. I think that's a real shame.
Okay, let me say it one more time.
He still doesn't get the communicating vessels.
As open and objective as possible. I'm going to say there's two possibilities. you could be correct. I misunderstood your test. Or there's another possibility that seems very obvious as well. I could be correct and you misunderstood the model. There's at least those two possibilities.
No, my point is, sorry, Spot.
No, go on.
My point.
Those two possibilities exist.
But the only problem with that dichotomy you're presenting is that the test does actually distinguish between a straight line and a curved line. It's just the point has been lost on you onto how it does.
So you say. I say it does not.
I know you do, but I know that's because you haven't understood the test.
How do we objectively determine who's correct?
You would have to come back another day and we would have to go over it again with a little bit more cool temper and don't feel like your model is under attack or anything. Just go over it properly.
I'm sorry. I'm sorry if it sounds like I'm upset. I'm not upset at all. I'm just in a rush because
it might help as well if next time you come, like you now you know a bit more. You'll be able to give us what the globe model would predict, right? You're not as green with it.
How about Bev comes onto my channel and we do this on camera on my channel?
I'll try and get it even. I'll get it down a bit neater.
Okay,
and I think I could add in.
And what I'd like to do is have you describe your test, and then I will diagram out how the test should work on the globe, and you diagram out how you think the test works on the not a globe, and then we look and see whether the way you measured can tell the difference. How about that?
Mm-hmm.
All right.
I'll try. Can I
present a third one? Right, a diagram where you show both outcomes in the same diagram to determine which one will, when you do the test in reality, you can determine with the one diagram which of the two actually takes place.
We're going to make a prediction of how the test should go under each hypothesis.
Yeah, you're going to have to do people at each end as well, right? You're going to have to Dornagon it.
Sure.
Yeah.
Sure. Yeah, does that work for you?
Yeah. You can do the Dornagon and I'll just go with the horizontal.
Let's set it up. Okay? Because, what we want to try to do is get to some objectivity and and if I sound upset, I'm sorry. I'm not upset. I'm just really in a rush here. That's all.
Yeah, no problem.
Okay.
Yeah, thanks for coming. And definitely, me and you, we are going to science the shit out of that level.
I love it. That's awesome. Awesome.
Yeah.
Thank you. Thanks for having me.
And I've looked. Sorry, just before you go, I've seen a couple of your videos, and I'm hoping that you're gonna stick by your name there.
Yeah, absolutely.
Yeah, and go after the truth, right?
You betcha.
Sweet.
That's what I'm here for. Right? I want you to test it. You guys, you went out and did a test. Hey, that's great.
Yep.
Okay. Later.
Thank you.
Take care.
Well, that went well, I think. Better than could have been expected, really. The 12 went brilliant. Never had anybody go through
that
the 12
was really
like that.
nice.
Shoo, boom, straight through. Yeah.
I'm gonna have to rewind it and have a look right now.
Well, I've got 2 hours 56 on the actual record, so I did that recording for him. So if you want to, if you want to rewind it, go back about that far.
Lovely, all right.
But I will be putting this bit out as a special because, it definitely needs to be gone over, right? Everybody can have a look at that. We were Aporia Canal. Boom! Let's have some of that.
Isn't that? Oh, okay, you're great.
Yeah. Oh, yeah. It went the full way. The full lot. I think even we had a circular horizontal Because of Merriam-Webster?
Yep.
Yeah, I think I thought that at the end.
Yeah.
And I think that what Buster brought up with this level at two ends,
Mhm.
this was beautiful.
I don't think
because
he's still not understood that yet, swapping sides.
he don't understand.
Yeah.
He doesn't understand that even on his own model, this level should be a real level, whatever it is.
Mm-hmm. Should work from both sides, like it
Yes,
does in
it
in
would be
reality.
equal level, or even on the globe.
Yeah, yeah. He's not actually mentally tried to process that yet, and he's going to be in for some trouble, I think. But I'm guessing there is a bit of a link lost in the processing somewhere.
What do you mean? Oh, yeah, okay, yeah.
He can't see it, right?
I might look through and see if there's any questions that I can present to him. I think
And
I fell asleep. I'm a bit gutted, really, that I missed it, to be honest.
And I think he should revisit his word science in his name, because this is not science. What he was talking about, not science.
Well, in his previous videos, that's what he's trying to portray. He's saying he wants to help people find the truth, and using logic and critical thinking. That was it, critical thinking. So.
Yeah.
Yes, but he was not practicing this here. Sorry, he always was assuming globe, always, which should he should not, because in science you cannot have bias. You have to have evidence and logical thinking only, and then you can compare it with this model, and if it fits model, it would mean that this model is all right. But if it doesn't, sorry, model goes to trash can.
Yeah, I'm with you on that, mate. Yeah.
Yeah, that was a good night.
Well, he did agree that he's going to science the shit out of it with you.
Yeah. Yeah, I think we've just created. Let's science the shit out of that.
Yeah. Could be the new end, the new beginning.
I'll see you guys tomorrow or Monday. I'll see you guys Monday.
All right, see ya. I think it needs a dance as well.
I think he needs the visual of the double drop hump and the horizontal in between. He doesn't see that. He thinks they will be at equal elevation, the three vessels.
That's what I need to work out, how to do that.
Yeah, because the second he started in the center, like the wrong center, obviously, they're two completely separate water levels, number one, which he didn't include there, but he went to the center and created the hump from the center, the double drop to either end. So,
but even if you have hump in the middle, at the two ends you have equal level.
Mm-hmm.
So but he ordered Bev to draw lower level at one end. So he doesn't understand his model.
Did you get
because if we have hump, there would be at the other ends, or to both ends, would be equal level. Anyway, there is no other way.
That's the problem. That's why it has the double drop hump. But it was good what you said, what Buster did with just the end-to-end water level. He made it higher at the other end.
Yes, this is nonsense on his own globe model.
Mm-hmm.
Yeah, I'm sure you guys would have asked every question that I would have asked.
I'm pretty sure there might have been too many. Like, had to let some things go just to keep it. You could tell that like the model was under threat, and it's like I don't want to threaten. I just want to get through this test. But like the model jumps out. I mean, the people that we're talking to are not the people that we should be talking to. These people are too model afflicted. Yeah,
yeah, but I mean, if you go around making videos about critical thinking, then you should at least do some yourself. And then maybe that's what it is, you know, when they get put in a situation where it's evident that they're not critical thinking, then that's when obviously they're going to put the barriers up. Then they're not, you know, they're model afflicted, not necessarily completely stupid.
That was like 5 hours of cog dis.
It's free for all Friday. We're still live.
and non-stop begging the question.
And obfuscation as well, right? The first half was just pure obfuscation. Second half was a man defending a model, but not defending a model, right? He separated himself from the model. He's like, I'm defending it, but it's not mine. All right, I'm not having that. I'm not having that. I'm just putting up a case for that thing.
Yeah, that's what I heard.
Yeah.
And in his voice too, yeah, that's the moment I came in and listened, I was like, at what point are they in this, you know? How long have they been talking? What have they talked about? Because the tone of his voice told me a lot of things. And because, as you say, paper, you've got to stand in the middle, haven't you? Without the models. Exactly, you worded it perfectly a minute ago, and I'm not going to butcher it. It was, but that's in his name.
Yeah,
He
no
is
science. I couldn't jump in because I had to restrain my horses, but science is completely different from what he said it is. This is not science.
Yeah. Sometimes I suppose, you know, we haven't got to say these things. That's the thing we may have to learn.
Well, listen,
but Bev,
go on. I say just as with the guys that have FE in their name that aren't flat Earth, let's say, right? They're FE Dogma, FE Pilot, FE Data. Think of any of the other ones, right? You know, you've heard them. They're not.
Flat Earth Math.
Flat Earth Math, yeah, there's another one. There's
yeah.
loads of them. They're not flat earthers. Well, I think we may be finding something similar with the term science. Because, don't forget, Bob the Science Guy, Blue Marble Science. I can science that. Science it out. All of these people, I'm not too sure what they're meant to be doing, but I've not seen any of that scientific method. I've never seen any of that logical thought process.
Well, it's very poor, isn't it? You know, the science. If that's what they're going to have a definition of what science is, and then not do any of it.
He said generally what I infer from this what he said about science, the science is opinion of body of science. This is science for him, generally speaking.
Well, Bev, when you just said that there's not really much logical thinking going on there, he did refer back to, well, the textbooks don't say that. The textbooks don't say that. The textbooks don't say that. There's no critical thinking skills that go along with any of that either. So I think that's where kind of after the whiteboard, when you were drawing on, you know, doing all the diagrams for him. I think that's when it kind of started getting more of that verbal cognitive dissonance, is when it kind of maybe started to turn more model defender.
Well, I think he came in, he was already model defender. Sorry, that. Go on.
I'm just saying, yeah, he's probably listening now, so, you know, just when he comes, you know, if you meet up, you go over there, then he's going to have heard, you know, what's being said about what people think about how the conversation went.
Yeah, I've, like I said, me and Spot On have been having a conversation just recently, and we've decided that the only way you can ever go with these conversations is just to try to not trigger the model to start making a defense. And obviously we're in an arena where people with the models just already overriding everything everybody thinks about. They can't get the model out of their heads for long enough to actually look over something. The model derives everything.
Yeah.
Well, I thought you went over the definition perfectly as well. You know, that's a textbook for him to look at. You know.
He didn't address contradiction in his beloved definition, because at point A, B, and C, at one point, I can't remember which one it was a strict contradiction. So, but he is okay. He can cherry pick just one point from two contradictory definitions and said that this is definition, but definition is saying what the thing is, and it cannot be contradictory. He cannot see that. Definition cannot be contradictory, because this is otherwise it is bullshit definition.
And he also agreed that his definition that he, you know, admitted to cherry picking to represent the other side was very potentially a vacuous truth. He agreed to that. He thought it was genius to bring it up, right? So he still managed after that to say that that very definition said that horizontal is a circle, even after agreeing that it potentially was a vacuous truth.
That's
yeah,
why
that was amazing. Like how quickly he dropped horizontal being a straight line. Boom. Two definitions. Why? Because at one point somewhere it said it conforms to the curvature of the liquid parts of the Earth's surface. Therefore, sphere. Completely ignoring the horizontal condition. I find that amazing how quickly somebody can be like that.
Well, it's confusing for the listeners.
I bet that this part which conforms to curvature is the newest one in definition, and he didn't realize that this is new addition to all very old definition.
But I think that the world of science and technology has moved so far on in their opinions. I think that, you know, we've said about it before, that it's almost like they think it's old. You know, that's the old before, and now this is the new.
Yes, and they are calling science fiction. They are calling theories. It's completely wrong. Theory, it is not science fiction. Theory is proven. It's explanation of proven things. So first you have to prove things to be true, and then you can speculate on them. to describe them, what happened. Not speculating or assuming or begging the question. This is not theory. This is hypothesis at best, or just fantasy.
Good night. It has been a good night. You coming in, turn up. I am just about to wrap it up, so.
Yes, it's time for me, big time for me to bed. Good night,
2
all.
o'clock, yeah. Night. Yeah, thanks for joining. Interesting night, and we have done this in the live room as well. So thanks for everybody that's been here. It's been very controlled without other people. I don't think the mods actually had to do any work or anything stopping people from jumping in. So thank you once again for everybody that comes in. Just shows we have a very controlled environment, even though we do have some pretty lively characters around here. Thanks, everyone.
He's not fucking talking about me.
We could have done with Tina a bit earlier, though. I can tell you that.
Yeah, what was up with that? I'm sorry, Mike Jones, if you're not here. But, I was still awake, buddy. I'm sorry. Did we need Tina?
It's all right. It's all right. I think Brenda and Alfad got called off. They didn't do too well, and they had to disappear.
I was around for the first little part of Brenda and Alfag, and unfortunately, that was the end of my lunch. So,
right.
Well, who knows where it's going to go? You know, after this, maybe some other scientists
turn up. That's a bit bad. You've got a hot mic.
Maybe someone who's
turn up. Yeah, thank you.
Studying physics, or gets to hear this and feels that they may be able to do a better job than what they're hearing.
I hope so.
Globe representation, not necessarily the globe representation, but that of science and physics.
I hope so. So, thanks a lot. I'm just going to close it off. Anybody wants to come into the Discord. It's going to be a lively weekend. I don't know. Normally goes a bit dead at the weekend, actually, to tell you the truth. But, hey, who knows? It's been a hot one this week. And yeah. Okie dokie. So, I'm going to shut it down now. Thanks for joining. Thanks for watching. We might be back over the weekend, but if not, Model Affliction Monday. We'll have plenty to talk about. Yeah. Let's science the shit out of it. Let's have some. Come on.
That could be the new ending.
Yeah, maybe.
It is probably the single most important mathematical idea of all. The notion of proof by circle and line or ruler and compass construction means that geometry can be known about in a way that is different from knowing about physical things, and so makes geometry epistemically differentiated. Furthermore, starting from circles and lines alone and constructing a relationship using circles and lines alone makes the conclusions certain in a way that nothing else was at the time. In geometric reasoning, the argument and the conclusions were made supremely clear and evident to the senses. Indeed, the concept of proof, a mechanism that gave a warrant for claiming geometry to be perfectly and absolutely true, made geometry the very paradigm of what we mean true and certain knowledge to be. In effect, in our understanding of nature, true means true like geometry is true.
Come go with me. Open your mind. Finding the knowledge of the real world starts with the point of which has no parts. These are the axioms of life.
True.
And I take my chances with the old ways, finding the proofs in geometry. And I don't care what all the sophists say. I find the proofs in reality. They were right.
We call this
We know that they were right.
True. We call this proof. Like geometry is true.
Starting circles and lines alone, constructing the nature of what's known.
We call this proof.
Conclusions are clear and the evidence seen. This 3D space works perfectly. And I take my chances with the old ways, finding the proofs in geometry. And I don't care what all the sophists say. I find the proofs in reality.
Like geometry is true. Perfect. Absolutely.
And all around you is sinking sand. You have a place on which to stand. Foundations were already built for you.
Absolutely.
Open your mind, and I'll take my chances with the old ways, hearing the words of what the ancients said. They say my words sound like sorcery, but there's wisdom in all honesty.
True.
Come go with me. Open your mind. Come go with me. We'll find the truth.
Absolutely. True.